AWS technicians have a number of tools at their disposal for managing AWS. At the GUI level, we've got the AWS Management Console as well as the AWS Console mobile app. The AWS Management Console is a GUI web browser-based tool that provides full management capabilities for all AWS services. You can sign into the console using the AWS root account or an IAM user account. The console mobile app is also a GUI tool, but compared to the AWS Management Console, it only provides limited management. For example, you can start and stop instances or monitor various aspects related to your AWS environment, including performance metrics and billing. You can sign into the console mobile app using an AWS root account, an IAM user, or the combination of an access and secret key linked to an account. The AWS Command Line Interface, or CLI, is a command line-based tool that allows you to manage your AWS environment, and it's supported on the Windows, Linux, and Mac OS platforms. The current version of the AWS CLI is version 2. With the CLI, it allows developers or administrators to access AWS Service APIs, which lends itself to automation. Anything that you can type in could be placed into some kind of a script file for repetitive purposes, so it lends itself to automation nicely. The AWS CLI, as a convenience, is automatically pre-installed when you deploy an Amazon Linux instance from the Amazon Linux AMI or Amazon Machine Image. When you work with the CLI, it uses the AWS command prefix. So all of the following syntax follows to the right or after AWS. So for example, we could type from a command prompt, AWS EC2 help. This would give us help on the EC2 command set within the AWS CLI. To authenticate to AWS from the CLI, you use the AWS configure command, where you'll be prompted to specify an access key, a secret key, the default region, and also the default output format for command output. Examples of things that you might do in the CLI are AWS configure, which we've mentioned, AWS help. Now, if you want to learn more detailed help about a specific command subset, as we've seen, you could do AWS, then the next command level, in this case EC2, help, or instead you might ask for help for S3 and so on. Now, by asking for help in this case for EC2, you then might learn that we've got another level command, such as AWS EC2 describe-instances. You might learn about AWS S3 ls for list, and then specifying S3:/ in the name of a bucket to show bucket contents. So there are plenty of things you can do with the AWS CLI, much more than we are mentioning here. Another command line tool that allows you to manage your AWS environment is AWS PowerShell. Now, this is for administrators as well as it might be used by developers, but you don't have to be a developer to use PowerShell. It lends itself to automation, much like the CLI does. Again, anything you can type in, command-wise, to control AWS could be placed into some kind of a script file. PowerShell allows us to create scripts, and PowerShell scripts have a .ps1 file extension. You can even schedule scripts to execute at a particular date and time, and you can also use the PowerShell ISC, the integrated scripting environment, which has a lot of built-in syntax help as you're typing and provides functions such as debugging more complex PowerShell scripts. So that's as opposed to simply typing in PowerShell commands into Notepad, for example, and saving it as a PS1 script file. PowerShell modules are essentially collections or libraries of related PowerShell commandlets. So for example, the AWS PowerShell module is a collection of AWS PowerShell commandlets, just like there would be a PowerShell module for DNS management or for VMware management on the third-party side. We can use the get-module PowerShell commandlet to list all of the modules that are loaded in memory, or we can run get-module-list to show all of the PowerShell modules installed on the machine. You can then import a module to make its commandlets available using import-module, followed by the name of the module. You can also remove it from memory using remove-module. Newer versions of PowerShell will automatically import a module when you call upon one of its PowerShell commandlets. So as an example, we could run get-command-module AWS PowerShell. This would show us a list of PowerShell commandlets contained within the AWS PowerShell module. We could then use get-help once we learn about some commandlets such as new-ec2 instance, and we can pass it the -detail parameter to get detailed descriptions about how to use that particular PowerShell commandlet. And in some cases, it even will provide some syntax examples. Now, piping is an important aspect of PowerShell as well, where we use a vertical bar, or the pipe symbol, that passes objects to the next command in the pipeline to the right of the vertical bar. So for example, get-service normally returns all services installed on the local Windows host, but we could pipe that to the sort alias and sort by the status property. Developers will be interested in managing AWS through AWS APIs, where AWS cloud services are exposed via application programming interfaces. Developers can also integrate AWS APIs with their own custom APIs. Now, in order to work with AWS APIs, API keys, secrets, or authorization tokens will be needed. So for example, if a developer has an on-premises software component that they're building that's going to call an AWS API in the cloud, then that needs to be an authenticated type of connection. And calling APIs can happen over HTTP, so it can be an HTTP REST API, or it can be a WebSocket API, where WebSocket APIs are a little bit different because they maintain a persistent connection when we've got a client call made to the API, where HTTP is not persistent. Finally, we've got third-party management tools that work with AWS, such as CloudAware, which is used as a cost measurement mechanism and also a cost-saving mechanism in AWS, Cloud Conformity, which is a threat detection platform that works with AWS, and Turbonomic, which is used to optimize hybrid cloud environments in anticipation of cloud adoption, so for migrating from on-premises into AWS. When you want to use the AWS Management Console, you can navigate in a web browser to aws.amazon.com, where you can then click Sign into the console. From here, you can use an AWS root account, or you could use an IAM user account. So in this case, I'm going to specify the username for an AWS root account. After which I'll click on Next, and it prompts me, of course, for the password for that account. Now, there is a forgot password link, but I do remember the password, so I'm going to input it here, and I'm going to click Sign In. Now, by default, that's all you need to sign in to the AWS Management Console, given your credentials are correct. I've enabled multi-factor authentication, or MFA, for my AWS root account, and so it wants me to use my Authenticator app on my smartphone to pull up the 6-digit code. That's only good for 30 seconds before it changes, and I'll enter it here. And once I've done that, I'll go ahead and click Submit to authenticate to the AWS Management Console. One of the first things to bear in mind when you're working in the AWS Management Console after you've signed in is the region in which you are working, the perspective that you're viewing your resources from. And so in the upper right, we can see our username. We can also see the region, in this case, N Virginia for North Virginia. If I open up that drop-down list, that actually is the US-East-1 region. Now, that means that if I were, for example, to go down under All Services, Compute, and click on EC2, I could also search for it in the Find Services field. If I search for EC2, I could click to launch that management console. That'll show me my virtual machine instances, in this case, in the US East 1 region. But if I were to switch to a different region, let's say US West, Northern California, so that's US-West-1. So I'll click on that to switch to that region. And whatever I was just looking at, which was the EC2 Management Console Instances view, will be filtered to show me only instances in that region. Notice we don't have any in that region. So always be wary about which region you are working from when, well, not only in the console, actually, also from the CLI and from PowerShell as well, where you can specify the region that you want to work from. Now, if I click on the AWS logo in the upper left, it takes me back to the main landing page for the management console. If you don't know what to search for, you can just go ahead and scroll down through the categories of services until you see what you need to select. For example, if I'm interested in security, identity, and compliance, identity and access management, otherwise IAM, I could click on it from here now that I've located it, and that places me in the IAM management console where I can work with users and groups and so on. So the best way to get used to using the AWS Management Console then is simply to use it to deploy and manage resources. The AWS Command Line Interface, or CLI, allows AWS technicians to create and manage AWS resources from the command line, whether it's been installed and running on the Windows platform, Linux, or even Mac OS. Here at aws.amazon.com/CLI, we can see we have the options to download the 64 or 32-bit installer for Windows and also the Mac OS and Linux installer. Now it says here it requires Python 2.6.5. The newer versions of the AWS CLI actually will not even require that be installed first because everything is self-contained in the installation package. I'm going to go ahead and download and run the 64-bit installer for Windows. So I'm going to go ahead and download this to my Downloads TMP folder. We can see that it's an MSI file in this case for the Windows platform. Once it's been downloaded, we can go ahead and click on it to actually open that installer file. And then from here, we can go through the installation. I'm going to do a default installation. Once that's done, if I go to a command prompt on that same machine and simply type AWS, it should be recognized because we've now installed the AWS CLI. So from here, for example, if I type CLS to clear the screen and then AWS space help, I'll start to get a listing of the next level commands that would work with this syntax. So as we go further and further down, it's alphabetized. So there's API Gateway. So I could start using AWS space API Gateway and continue from there. And as we go further through, we can see we've got Athena, budgets. If we go down to the E's, we'll even see that we've got EC2. So we could run AWS EC2 space help to find out what we would type in after that. So now the help will be focused on the AWS EC2 command prefix. So we can see an alphabetized list of what would follow next, such as creating route tables, creating security groups, EBS volume snapshots, and so on. So from here, we can learn a lot about what to type in for syntax. We can also run AWS space, rather, -- version to see the version of the CLI that we are currently running. Now, this is important because when we look at different syntax examples, perhaps out on the internet as we're researching the CLI, we've got to make sure that we are using the correct version of the CLI that matches up with those syntax examples. Now, the last thing we should be aware of is how to authenticate to AWS. And you can do that with the AWS space configure command. So if I press enter, it's going to want my access key and my secret key. Here in the AWS Management Console, if I were to click on my username in the upper right and go all the way down to my security credentials, from here I could navigate down to access keys. Here I can see an access key ID. The secret key is not shown here. It's downloaded and saved along with the access key at the time of creation. Here we can see the creation date. You can also create new access keys. So I've already downloaded that Excel spreadsheet file. And here's what it looks like. I've got the AWS access key ID, which is what it's asking for currently, and then I've also got the AWS secret key, which it will then ask for. So this is going to be important for when we want to authenticate from the CLI. I've already entered in the access key value, so I'm going to press enter. Same with the secret key, I'm going to press enter. Then it asks me for the default region name, so I don't have to specify it with every individual CLI command. Here it's set to US-East-1, which is perfect for what I'm doing. And the default output format for the resultant display of command syntax, I'm going to leave it as a default format of none. And that's it. We are now authenticated to AWS. So we could run, for example, AWS EC2 describe-instances to get some details about the EC2 instances deployed, at least in that AWS region, US East 1. And we can see we've got some return values, so it's working. You can install the AWS CLI not only on the Windows platform, but also on the Linux and Mac OS platforms, whether those are physical or virtual machines. Now, if you're using Amazon Linux, the CLI is already pre-installed, but here I'm using Ubuntu Linux, where, of course, the CLI is not automatically pre-installed. So what I'm going to do here in Ubuntu Linux then is I'm going to use the curl command to download the zip file for AWS CLI version 2. So I've specified the URL within quotation marks here for HTTPS, and then I'm going to specify that I want that specific zip file. Now, if you're wondering, how do you know that crazy URL? Well, here I'm looking at the installation notes on the AWS documentation site for installing AWS CLI version 2 on Linux or Mac OS. And it's simply a matter of scrolling down and following the instructions. For example, for Linux, here's the curl command. To download the installer, they're using the unzip command to unzip it, and then they're running the install with elevated privileges using the sudo command, or sudo. So back here in Ubuntu Linux, let's press enter to get that file downloaded. And before you know it, it's downloaded. So we can see it was approximately 46.2 megabytes. Let's just do an ls-l here for the current directory. And there's the AWS CLI v2.zip file. So now what I'm going to do is run unzip for that file. So /AWS CLI v2.zip. It says, well, unzip's not installed, but you can install it with sudo apt install unzip. Let's go ahead and do that. And I'll clear the screen. I'll just use my up arrow key so we can get back to the unzip command to unzip those files. Okay, looks good. We're going to clear the screen, and I'm going to run sudo /current directory AWS / or I should say run /install. And we should be able to try this out. So usr local /bin AWS2, let's say -- version to make sure it's recognized and returns the version string for the CLI. And it looks good. Now, if I just type AWS2 by itself, we're good to go. So it gives me some help on the AWS original command line syntax. So we can now run AWS to begin managing resources using the CLI here in Ubuntu Linux. Another way to work with the AWS CLI, the command line interface, other than downloading and installing it on an on-premises host, is to deploy an Amazon Linux EC2 instance. In other words, a virtual machine, because it automatically includes the CLI. Let's check this out. So here in the AWS Management Console, I'm going to click on EC2 under All Services Compute to open the EC2 Management Console. I'm going to go to Instances, and I'm going to launch an instance based on the Amazon Linux AMI, the AMI, the Amazon Machine Image. So I'm going to click Launch Instance, and I'm going to use the Amazon Linux 2 AMI here. So I'll just click Select. And basically, I'm going to accept pretty much the default selections for everything, including the VPC and subnet affiliation. And I'm going to go through, maybe on the tags, I will add a tag. I'll call it name. We'll call it Amazon Linux-1. And next, maybe I'll tell it to use an existing security group that allows SSH connectivity, so port 22. And that looks good. I think we're pretty much ready to launch this. So I've got an existing key pair. I will acknowledge I have the private key portion of that I've downloaded, which I do have, and I will launch this instance. So once it's up and running, what we're going to do is make an SSH connection to it from on-premises. I'll use PuTTY to do that, and we'll verify that the AWS CLI is automatically available in that Amazon Linux instance. Now, before we can use the free PuTTY tool to make a remote SSH connection to the Linux host, we need to take the private key, that's part of the key pair for that instance, and convert it to a format consumable by PuTTY. So to do that, I'll use the free PuTTY key generator tool, where I'm going to click the load button and specify my downloaded key pair file from AWS. When I've done that, I get a successful notice about having imported the foreign key. So all I want to do now is save the private key. Now, when I do that, it'll be in a format consumable by PuTTY. So I'm going to go ahead and first specify a passphrase, and I'll confirm it, for safeguarding the private key file. So once you've saved that private key file somewhere, you have to refer to it in the PuTTY tool so you can make an SSH connection to the Linux instance. Back here in the EC2 Management Console, there's our Amazon Linux instance. So I'm going to go ahead and down below under the description tab, I want to copy the public IP for it. So here in PuTTY, I've specified the public IP of our Amazon Linux instance, but on the left, way down under connection, SSH auth, I need to specify the appropriate private key file that we just saved using PuTTY gen. Once we've done that, we can go ahead and go back to session. I'm just going to save that to the AWS Linux VM settings here, and then I'll click open to open a connection to that Linux instance. And it wants us to log in. So the default username here is ec2-user. I'll just maximize this PuTTY window. Then it wants the passphrase for our key file that we specified in the PuTTY gen tool. So I'm going to go ahead and put in that passphrase because it's accessing the private key. Then we're in. So I'm going to go ahead and clear the screen. And if I were to run, let's say AWS --version, we can see that the AWS CLI is actually recognized because the AWS command is recognized. So we can see the version string. So therefore, we know that the AWS CLI is available automatically within this Amazon Linux EC2 instance. You can use PowerShell commandlets to both deploy and manage your AWS resources. Here, I've gone in my browser to aws.amazon.com/PowerShell, where we can choose to download the AWS Tools for Windows installer. Now, under PowerShell Gallery, notice that we've got AWS Tools for Windows PowerShell, but we've also got AWS Tools for PowerShell Core and also AWS.Tools. PowerShell Core is essentially the open source version of PowerShell that allows us to run PowerShell commandlets on a variety of platforms, including Linux and the Mac OS. We've also got the ability to download specific modules, such as the commandlets that would support S3 management in AWS through AWS Tools. I'm just going to go ahead and download the AWS Tools for Windows installer. I'm going to download that to my Downloads TMP folder. Notice that that is an MSI or a Microsoft installer file. So I'm going to go ahead and save that. Now notice that also includes the SDK, the software development kit, which programmers would be interested in if they want to be able to access exposed AWS APIs. So once that's downloaded, I can go ahead and begin the installer. So I'm just going to go ahead and go through the installation wizard, accepting defaults. So now on that same machine in PowerShell, I'm going to run get-module -list. I want to see all installed modules on the machine's hard drive, and I'll wildcard it around the text AWS. And we can see that the AWS PowerShell module is, in fact, installed. And remember that the PowerShell module, in this case AWS PowerShell, contains all of the related commandlets. Perfect. So if I were to run get-command -module AWS PowerShell, and we'll pipe that to more to stop after the first screen full, we're going to get a list of the PowerShell commandlets within the AWS PowerShell module. So we can now get a sense about the AWS PowerShell module commandlets that allow us to manage our AWS resources. I'll press Q to quit out of that. Now, the other thing we need to be able to do is authenticate to AWS from within PowerShell. To do that, I can run initialize -AWS defaults, where I can also specify the default region with -region, such as US-East-1. Now, if I don't know the name of the regions, I could also run get-AWS region in singular, not plural. And here we see, for example, there's US-East-1. So let's get back to it. Initialize -AWS defaults, and I'm going to specify the -region parameter, and now I know US-East-1 is valid. Now, in addition to specifying the default region here for the session, instead of specifying the region with each and every commandlet that I use, I also need to specify the access key and secret key. These are available in a downloaded file, which I've already downloaded. It's a CSV file here when you initially create a key pair. So I can see that I've got an access key ID here and a secret key here. That's part of the creation of the keys in the AWS Management Console. So for example, here in the console, when I'm signed in, if I click on my user account name in the upper right and go down to my security credentials, it's from here I can go down to access keys and see the access key. You don't see the secret key. That's only available when you download the file upon creation of the pair. And if you don't have access to it, you can always create a new access key that would also include a secret key. So back here in PowerShell, I'm going to just press enter to accept the default, and I'm going to paste in the AWS access key as well as the secret key. And now we are in. We are now authenticated to our AWS account. So for example, if I run get-s3 bucket, we know we're authenticated because it's returning buckets. Developers can use a variety of different tools to manage applications in the AWS cloud. In this example, we're going to take a look at downloading the AWS Toolkit for Visual Studio, specifically for Visual Studio 2019 Community Edition, which I've already got installed on this on-premises host. So I've gone to aws.amazon.com/Visual Studio, where on the right, I can select to download the appropriate toolkit, in this case, for Visual Studio 2019. That takes me to another web page where I'll click the download button. And this is going to go into my local downloads TMP folder, so I'll just go ahead and click save. And we can now see it's in the midst of downloading. Next, I'll click on the downloaded package, and I will choose yes to install it. And I'm going to accept the default. So I'm just going to click Install. And before you know it, the installation is complete. Let's fire up Visual Studio. So on the Visual Studio opening page, I'll just choose Continue Without Code for now, down in the bottom right. And within here, I can go to the View menu and choose AWS Explorer so that I can start to explore some of my AWS options, as we can see listed over here on the left. Amazon CloudFront, Amazon EC2, AWS Elastic Beanstalk, AWS Lambda, and so on. Now from here, I'm going to click the little icon that looks like a plus sign on a person to add a new account profile. But here I'm going to call this Profile 1, and here I'm going to specify an access and secret key. Back here in the Management Console, you can click on your account name in the upper right and choose My Account to see your account ID. Now, after you've specified those credentials, select the appropriate region you want to work with. For me, it's US East, North Virginia. And what I've done here is drill down under Amazon EC2 and double-clicked instances, and we can see that it's pulling my instances from that location. So it's working. We've got authentication happening here directly within Visual Studio. So at this point, we can now build code and push it into the AWS cloud. So we could, for example, build a new project based on a basic web application, or we could build a Lambda function. Really, we could do pretty much whatever we wanted to work with. So I could build a web app. I'll just select web app. I'll choose next here. And I'll just accept the default. It's going to be called Web Application 3. And I'll go ahead and create that. And I'll choose Create. So it's in the midst of creating this locally here in Visual Studio. Now at this point, we would develop the code to suit our specific needs for this web app. But over here in the Solution Explorer on the far right, if I right-click on the name of my web app, I can choose to publish it as a container to AWS or publish it to AWS Elastic Beanstalk. So the integration with the tools for Visual Studio is successful. CloudFormation makes deploying AWS resources a piece of cake. It's so much easier than doing it manually through the GUI. So what we're talking about is having a template with instructions on the deployment or even management of AWS resources. Let's take a look at that. So here in the AWS Management Console, we're going to start by searching up CloudFormation and choosing it. And here we see we don't have any stacks. A stack is a configuration that consists of one or more AWS resources, but we're going to go into the designer in this case because you can build your own custom template or stack of items, which results from template instructions. Here in the designer on the left, you've got an alphabetical listing of AWS resource types that you might want to automate the deployment or management of. You've got a template canvas in the center where you can drag the items from the resource types pane on the left into the template canvas in the middle, and then see the resultant code down below. Notice the default template language is JSON, but it just as well could be YAML. Let's see how this would actually work. So for example, let's say I want to deploy an EC2 instance. Well, that needs to be deployed into a subnet, and a subnet depends on a VPC. So let's expand EC2 here, and I'm going to go to the Vs, and we're going to drag VPC here. Now you can resize this depending on how you want to display things on the screen, but when you do add items onto the canvas by dragging them like I've done, it will automatically add some code down here for that item. So in the resources section under the template, let's go do that. So I'll just click on it again here to select it. It jumps to it. Notice it highlights the name of it. That is not a friendly name. I want to call this, at least from the template perspective, VPC2. We can see the type of resource is an Amazon Web Services EC2 VPC. Now, the other thing to bear in mind is that there are plenty of properties that we could specify here in between the open and close curly braces for properties, but what do we put in here? How do we know that stuff? Well, as usual, it's as simple as documentation. Take a look at the CloudFormation documentation, and when you scroll down in that user guide, you can go all the way down to template reference, resource and property reference. A resource is something like an EC2 instance or a VPC, and each of those has a number of properties. So let's go down and expand EC2, and let's go all the way down to VPC to figure out what we should be putting in for properties. Here's an example right away in JSON. CIDR block. That's right, a VPC needs a CIDR block network range. And whether we want to enable DNS host names or DNS support, it's Boolean, true or false. Instance tenancies, whether it should be dedicated hardware or not. Even tagging information. Okay, now I have a sense of what I need to type in and how it needs to be formulated syntactically. So back here in the CloudFormation Designer, I'm just going to go ahead and place that code in there. So notice I've got a CIDR block specified here, followed by a comma and then tags. And then I followed the syntax according to the documentation. I want to tag the VPC with project and a value of ABC. So we could do the same type of thing for other items. So let's say, for example, I drag out a subnet. Now it says it's out of date up here because I've been making changes down here in the code for the templates. I'll just refresh. That's better. So in the same way, here's our subnet that's been added. I can, select it and it jumps down to it. Again, not a very friendly name. So I'm just going to call this, let's say, subnet 2. And again, I can add some additional properties here, the same way that we looked up the reference in the documentation for VPC properties. But let's look at something a little bit different that we've not yet encountered. We already know that we can resize these things. So for example, if I visually wanted the subnet to appear within the VPC, I can resize and move things around. Well, you don't have to do that though. That's completely preference. There's no requirement to do anything like that. Now, what we do though is we can specify that we want some of these things to be linked to others. So you can see the link line here. That's linked because I dragged it in it. But if we didn't have them visually displayed in there, let me just remove the link, we could still do it because if I point to each of these dots, they pop up with a different type of property. Here, this is the Subnet Route Table Association. The next one is the Subnetwork ACL Association. And then the VPC property ID. Okay, so this is where I could drag it, and we've established a link, kind of like it automatically did when I dragged the box for the subnet into the VPC. And there's also a depends on. So notice a different color here. It's kind of got a purple tinge to it. So I'm going to point that to the VPC. Notice the color of the arrow is not solid black anymore. So you can't have the subnet unless you have the VPC. So it depends on it. And again, you can just select the subnet, and down below it goes down. You can look at the reference documentation to add properties. And you would do the same type of thing, in this case, in our example, for an EC2 instance. So we can see we've got a lot of little dots around here. So the security group affiliation, the EC2 volumes that it's using, the image that it's using. Of course, these items, like if we were to choose, let's say, volume, we can drag that to an EBS volume resource that we might have drug onto the canvas here. Now, we didn't do that, so you could just go down and write the code in the properties. Okay, so I've got my VPC subnet, my instance, which I've called VM2, at least here in the designer. Next thing to do is to validate the syntax. I'll click Validate Template. It says template is valid. Now, that might mean the syntax you have is good, but what if you omitted something like a mandatory property? You're not really going to know until you try to deploy the stack, the collection of these items referenced by the template. So I'm going to go ahead and save this. When I click on the save option, I can either save locally on my computer or into an Amazon S3 bucket. I'm going to choose local file, and I'm going to go ahead and save it with a specific name. Now, once that's been done, we are good to go, meaning we're ready to deploy the stack. We can click the Create Stack button up at the top here in the designer, and the template is ready to go. And even though we saved it locally, there's still a copy in S3 automatically, so that's fine. I'll click Next. I'm going to call this stack Sandbox 1. What a great way to quickly deploy a sandbox for testing purposes. I'll go ahead and click Next. I'm not going to make any changes to the stack itself, so Next again. And on the review screen, I'll just click Create Stack. Now, you can see the Sandbox 1 stack creation is currently in progress, and we're looking at events over on the right. Now, this is important. You want to make sure you continuously refresh this so you can see what's happening. So, Sandbox 1, the stack, user initiated, VPC 2, resource creation initiated. Hopefully it succeeds. We'll just keep on refreshing, and we're going to get updates periodically. Oh, the VPC 2 creation succeeded. It says create complete. You want to look for the green status. So you keep doing this for a few minutes. Now, depending on how many resources are being deployed in your stack will determine how long you have to wait for everything to be ready. But it's actually creating the resources, which is way quicker than if you were to do it manually through the GUI. And again, if you know you need to spin up a testing sandbox environment repeatedly, this is definitely the way to do it. So we can see Subnet 2 completed, looks good. VM2, the resource creation has been initiated. So we just keep monitoring that until such time that everything looks like it's good to go. And we can see VM2 completed. So basically, the stack is complete now. If we refresh, we can see that the entire stack as a whole has completed successfully. You will know if there's a problem. You'll have a red status message. It'll roll back, and it'll give you, under status reason, some indication as to what the problem is, so you can go back and troubleshoot your template. Now, if I click Stacks over on the left, we'll see the stack is listed here. Now, in the case of a sandbox, to save on costs, the moment you're finished with those resources, you could simply select the stack and delete it. But before we do that, let's just check our work, meaning let's click on AWS to go back to the landing page. Let's take a look at VPCs to see if it actually created one. Now, if I go to your VPCs, it should have created it. And it looks like we are good to go. Here it is here with 11.1.0.0/16. It wasn't tagged, so we could call it whatever we want here. Really, that should be written into the template using the tags property. And in the same way, we'll have a new subnet that uses an address range within the VPC range. So here it is here again. There were no tags on it. And if we just go back and look at our EC2 management console, we should also have an instance because that was the third resource that we specified that was going to be deployed here. We can see it's initializing it right here. Again, we didn't add tag values to all of these items, so therefore they're not tagged. So at any point in time, when we feel like we are finished with that stack, we can just go back in the CloudFormation console and delete it. So I just select it and click delete. When you do that, you are deleting all of the AWS resources that were created from that stack. A CloudFormation template is just a text file. Now, it might be formatted in JSON or YAML format, but it really just is a text file as I've got open here. Now, this is a template file that was created using the CloudFormation Designer in the AWS Management Console. So you'll see a lot of details about that at the top, but if I just, let's say, search for resources, that's where the real template begins, then we'll be able to see the items within the template. So let's just search for that properly here. There we go, resources. So we can see we have the definition for VPC2, and we've got the CIDR block, we've got some tagging information, and as we go further down, we'll see it looks like we've probably got a subnet created here, subnet 2, as we can see listed here, and also by the type in the template. And ultimately, we've got a virtual machine instance that we're creating here. And in the template, it's called VM2. It's referencing an image and a key name. The point is, we've got a file already. So whether you design it yourself manually, just typing everything in, whether you use the CloudFormation Designer, whether you go to GitHub to download templates, it doesn't matter. But when you have this file in your possession, you can simply upload it into CloudFormation and have it, in this case, deploy these resources. Here in the AWS Management Console, I'm going to search up CloudFormation and I'm going to choose it. I don't have any stacks yet, but that's going to change because I can click Create Stack, New Resources. And here I can say I already have a template. Template is ready, except I want to point to it as a local file. So it's not in an Amazon S3 bucket. Then I simply choose the Choose File button. Once I've done that, the file name that I've selected shows up here, so I can view it in Designer if I really want to. I don't want to. I might do that if I want to make some changes to it, but I want to leave it as it is. I need a stack name. Let's call this Stack 1. No parameters that we're feeding into the template. It's just going to use the hardwired values. We're not going to change anything else about the stack. And on the review page, we're simply going to click Create Stack. We can see the stack creation for Stack 1 is currently in progress. So you're going to want to click the refresh button here so you can view the events as it goes through each item in your template and tries to deploy it. In this case, Stack 1 is trying to create VPC2, so the VPC initially, followed by any other items, which in our case includes a subnet and eventually a virtual machine or EC2 instance. And before too long, if we keep clicking refresh, we'll see that the stack has completed, which means that all of the resources listed here, the VM2 EC2 instance, subnet 2, and VPC2 have been successfully deployed from our template file. Depending on your requirements, when you use CloudFormation to deploy AWS resources, maybe to support a web application, with or without database support, there might already be a sample template available. Here in the AWS Management Console, let's go to CloudFormation. And in the CloudFormation console, we're going to click Create Stack with New Resources as opposed to using existing resources. Now from here, we can create a template in the designer. We already have a template file we might have even acquired from alternate sources on the internet like GitHub. I'm going to choose Use a Sample Template. And from the drop-down list below, you've got a number of templates available as simple versus multi-availability zone. So I'm going to choose, let's see, a simple WordPress blog. Maybe that's what I need to set up. I'll click Next. I need to give this stack a name. How about WordPress Stack 1. Now, depending on how the template was created will determine whether or not you need to specify parameters that are passed into the template when resources are created, as opposed to them being hardwired. So for example, we can see the database name, WordPress DB, but we need a DB password. We also need a root password for MySQL. Okay, so I'll specify that. And we need a DB user. So I'm going to put in a user name for that. We can specify here the instance type. I'll leave it on T2 small. And we have to choose a key pair name because it's going to be deploying an instance. So I'm just going to choose key pair 1. That's a key pair I've already created. And the SSH location from which SSH sessions can be initiated will be listed as anywhere. Okay, that looks like it's about it. Let's click Next. We don't have to add any of these other stack options. So I'll go ahead and click Next. And on the review screen, I'm not going to make any changes. I'll just click Create Stack. We can now see WordPress stack is listed here. The creation is in progress. So what we want to do is just keep monitoring it by clicking the refresh icon as it goes and creates everything. Notice here, we didn't look at the details in the template, but it's creating a web server security group. Okay, that makes sense. That created okay. So create complete is in green text. It's now creating the web server itself. So we can keep monitoring this until the resources are deployed. And in this case, it's going to be just another EC2 instance that shows up that we SSH to, because it's going to be based on Linux here. It asked for SSH information for the location. And then we can continue on our merry way configuring the resources created from this sample CloudFormation template. Just remember that when you're finished working with a stack, if you no longer need it, make sure you delete it, because if you leave things running like virtual machines and database instances, you are paying for it as it is running. So don't forget to clean up after yourself when you're finished with it. Tagging an AWS resource means adding extra data or metadata about that item, such as assigning a specific AWS EC2 instance to a project or flagging it as development instead of production. So it facilitates organizing AWS resources even for billing purposes. If, for example, you want to see all the charges incurred by project ABC. Now you can specify tagging through the GUI, which we're going to see here, and also through command line tools. For example, let's say here in the AWS Management Console, we're going to navigate to the EC2 Management Console. And maybe I'll go to the Instances view and I'll click Launch Instance. The point is that we can assign tags when we are launching resources or creating new AWS resources, and not only EC2 instances. So if we were to follow through and just select an Amazon machine image to create an instance from, I'm just going to go and keep clicking the next button in the bottom right until we get to the point where we can add tags. So you can add tags or metadata to new resources as you are deploying them. Now to do that, I would click the Add Tag button. For example, maybe I want the name key and then a value for that, let's say to be Amazon Linux 2. But I can also add additional tags. Specifically, you can add up to a maximum of 50 tags for a single AWS resource. So if I wanted to apply this or tag this as project ABC, I could go ahead and do that. So you can add and remove tags. You've got a little extra remove the tags as required. Notice in this particular example, because we're deploying an EC2 instance or a virtual machine, you can determine if the tags apply to the instances and or the disk EBS volumes associated with the instance. Now, having done that, that's fine. I'm not going to save that, so I'm going to choose Cancel. Now, when I have existing resources, I can also tag them. For example, I've got an EC2 instance here that is stopped, but I don't even have a name for it. So if I select that box to the left of that resource, see it selects the whole line, down below, we can click on the Tags tab. Now, if you want to specify the name tag specifically, you could add a name tag with the value here, or you could do it directly in the GUI interface here by clicking the little pencil. So let's say I want to call this Ubuntu-1. I'll click the check mark. It's done. And notice it adds the tag down here. You can do it either way. But I can also add additional tags. So I'm going to click Add Tag, and I'm going to create a tag, and I'm going to go ahead and add project with the value of ABC and save. So we can see now the 2 tags are here. And remember, up to a max of 50. I'll do the same thing, let's say, for my Windows EC2 instance I've already got deployed here. I'll select it, go down to tags. The name's already added, but I'm going to go ahead and create the project tag. And notice that ABC shows up in the list because I've already entered that in as a value previously. Go ahead and add that. Now, the other thing I'm going to do here in the AWS Management Console is up at the top, I'm going to click on the Resource Groups menu and choose Tag Editor. So here we can look for specific resources that we might want to tag using this interface. We can see the region is already selected. We could remove it and add another region from the list if we so chose. We can look for specific resource types. So for example, if I'm primarily interested in EC2 instances, I could choose the AWS EC2 instance resource type. And here we could specify tag keys and values. However, at this point, I'm just going to go ahead and click Search Resources. So you can even use this as a searching mechanism. So here I can see my Windows and Ubuntu EC2 instances that are currently showing up here. But if I want to filter it further, I could specify, let's say, project ABC. I could click Add, and of course, the filtered list now only shows items with project ABC. Now, if we were to, let's say, change it from resource type of EC2 instance to all resource types, let's do this again. Let's search for all resources flagged as project ABC. Well, we can see here we've got our 2 instances. Well, it's the same output, but let's remove project ABC. Let's just search for all of our resources here. And we can now see we're getting a bunch of them listed. So we can use the tag editor then to filter based on those tag values. You can use the AWS CLI to manage AWS resource tagging. Before we work in the CLI, let's start here in the EC2 Management Console where I've already gone to the Instances view. So here, if I select an existing EC2 instance, we can go down below and click Tags and see any existing tag key and value pairs. We can see the name key is here with a value in this case of Ubuntu-1, and we've got another key called Project with a value of ABC. Also take note of the instance ID. When you want to start modifying tags at the command line in the CLI, you're going to need to have the resource ID, in this case for an instance. Doesn't have to be an EC2 instance, could be an S3 bucket, basically any type of resource we can deploy in AWS. Here at a Windows command prompt where I've already installed the AWS CLI, I can run AWS EC2 describe -instances. Now this will return all of the information for all of my EC2 instances, including details such as the resource ID, which I'm going to need here in the CLI if I want to start making some changes to tags using the CLI interface. So here, for example, we can see the instance ID. So having done that, let's go ahead and use the AWS EC2 create-tags syntax. Now I'm going to use the --resources parameter, and I'm going to specify the resource ID, in this case the instance ID for my EC2 instance, and then I'm going to use --tags, and I'm going to say key equals cost center, so I'm creating a cost center key, and the value of that will be YHZ. Let's go ahead and press enter. Now we can also check our work here back in the AWS Management Console. So back here in the console, we're looking at the tags, but the screen's not been refreshed. So if I click on something else like the monitoring tab and then back on tags, it still doesn't show up. Well, why don't we click the refresh button up at the top? And now indeed, we can see for our Ubuntu-1 Linux instance, we've got a cost center tag, which shows a value of YHZ. You can use PowerShell to manage resource tags. Here in the EC2 Management Console, I'm looking at the instances view where I've got a Windows Server 2019 instance. What I'm interested in are two things. First of all, I need the instance ID here if I'm going to refer to it from PowerShell. Next thing I want to point out is that having that Windows EC2 instance selected, if we go down and look under tags, we can see there are only two key and value pairs, the name and the project. So we're going to go to PowerShell and we're going to add a cost center tag with the value, and then we'll come back here to check our work. So the first thing I'll do is create a variable called $tag, which will store the result of creating a new object using the new-object commandlet, and the type will be amazon.ec2.model.tag. Let's go ahead and press enter. I'll just type $tag. We can see it automatically knows that it should contain key and value pairs, so that works well. If I were to run $tag and pipe that variable to the get-member PowerShell commandlet, which will show the properties and methods. Actually, we can even say -type property if all we want to see are properties. We can see that it's got a key property and a value property, and they're both string items. So having done that, that means that if we want to call, let's say on the key property, we can do $tag.key. And from here, we can enter what we want. So for example, I want that to store, so equals, and in quotes, let's say cost center, and then maybe $tag.value equals, and let's say the cost center code here is YYZ. And I'm just going to go ahead and clear the screen with CLS, and let's just run $tag. Okay, it now contains cost center and YYZ. So our tag variable is now set up. The next thing we need to do is apply that to a resource. And we can do that using the new-ec2 tag PowerShell commandlet. Now, when we do that, we're going to have to pass it our specific tagging variable. So let's go ahead and try that out here. New-ec2 tag -resource. This is the instance ID of the AWS resource instance that I want to modify the tagging for. I'm going to use -tag, and this is where I'll pass it my $tag variable. Let's go ahead and press enter. Then we're going to go ahead and check our work in the EC2 Management Console. And after a moment, you'll see that it's done. Now, just be careful, because what I mean by that is, in this case, our instance. Well, let's just take a look at the Management Console first. Okay, so we can see our Windows instance is in an availability zone US-East-1A, and if we take a look in the upper right here in the console, we can see our current region is US-East-1. So if you are connected in PowerShell to a different region, then it might have a problem trying to locate that instance ID for this resource. Now, we didn't have that problem here in PowerShell, but if we did, we might be interested in getting a list of AWS regions. So for example, we can see there's one here called US-East-1, and then we can actually set that as a default here in our session. And we could do that using initialize-AWS defaults -region, in this case US-East-1. So just something to think about if you're running into errors when you try to manipulate resources through PowerShell. Now again, we didn't have that problem, fortunately, so let's get back to work here. In the EC2 Management Console here, I'm going to click refresh, because for our Windows instance, we now see that we've got our cost center key with a value of YYZ. In this demonstration, I will enable S3 static website hosting. Now, to do this, you need a bucket that you are going to create and store the contents of the website in. So I'm going to create a new bucket. I'm going to call this www.architect, let's say .local. Maybe this is going to be to store project files for architects that are available locally in a bucket. So I'm going to leave it as US East for the region, not going to copy existing bucket settings. I'm basically going to go through the entire wizard here and accept all of the defaults. So I've now got my new bucket, www.architect.local. I'm going to open that up and I'm going to upload some sample website files. So I'll click upload and I'll click the add files button. So we can see we've got an index.html file and a logo.jpg file referenced by the index.html. So let's go ahead and click Next and get that content up here. Notice that the default here is that public access to these files is blocked. Do not grant public read access. Okay, well, depending on the nature of your static website, if it's information that should be available to all without authenticating, then you would want to enable public access, but we'll deal with that after. For now, let's just go ahead and accept the defaults to get this content uploaded into the bucket. There are the files, index.html and logo.jpg. Now, what we're going to do is enable static website hosting. To do that, here in the properties of our bucket, we'll just go to the Properties tab here, we'll see the static website hosting panel. Now notice it currently says disabled. So let's click on it and I'll scroll down and we'll configure it further. I want to use this bucket to host a website as opposed to redirecting requests to an alternate website elsewhere. Yeah, I want to use this bucket. Okay, turn that on. What's the index document called? Well, it happens to be called index.html. We don't have an error document or any redirection rules or anything like that. So that's pretty much all we're going to do. I'm just going to go ahead and click Save. And then I'm going to scroll back up. Okay, so we can see that static website hosting is now enabled, where previously it said disabled in gray. I'm going to click on that because at the top of that panel, when we've clicked on it, we have an endpoint URL. Let's go ahead and click on it to see what happens. Well, this doesn't look good. It says 403 forbidden. Well, remember, the default with a bucket when you create it, unless you change it otherwise, is that all public access is blocked. Well, in this case, that's not good. I want this to be open to all. So I'm going to go ahead and click the S3 Management Console tab here to go back to that in the browser. So I'm going to go to the Permissions tab here for the bucket. Now, currently for block public access, we can see it says on. Well, I'm going to click the Edit button over on the right, and I'm going to remove that check mark. Okay, I don't want it on for anything at all. So I'm going to go ahead and click Save. Now it says, are you sure you want to do this? Type in the word confirm. Okay, I'm sure I want to do that. So I'm going to type confirm, and I'll click the confirm button, and it says public access settings updated successfully. Okay, well, that's good. If we were to go to the overview, then we can see here that our files are still stored here, and they're still just standard storage class. Now let's go back to permissions because, well, actually, let's go to properties first. Let's go to static website hosting. We could either click the URL down below again. We've already got it opened up here at the top, so I'm just going to flip over to that and let's do a refresh. Still no joy. It still gives us a 403 forbidden. Well, you have to do something else. Aside from making sure that you are not blocking public access, you're going to need to make sure that you have a policy that allows access to the objects in the bucket. So let's go back to the console. Okay, and let's scroll back up here. Let's go to permissions. I'm going to go to the bucket policy button. Now here you can type in the code for the bucket policy, but normally what one would do is click the policy generator button because it's easier. The type of policy here would be for S3 buckets, and I can either allow or deny. So for example, allow everybody, or I could specify using a comma to separate multiple principal names. So Amazon S3, and I can select the actions in this case that I want to allow, or I could just say allow everything. So creating a bucket as opposed to getting the ACL for a bucket and so on. So we can use the policy generator to do that if we so choose. Now here I've put in my bucket policy. So I can see here that we've got public read get object. The effect is allow as opposed to deny, and the service principal is an asterisk. So public access, everybody. And the action specifically here is get object. I don't want to allow full access, such as the ability for anybody to delete the bucket, but reading or getting objects, because this is going to be hosting a static website, that makes sense. Down below for the resource part of this configuration, I'm specifying the Amazon resource name or the yarn. So it's AWS S3 : and then the name of my bucket, www.architect.local/*. Everything in the bucket is what should be allowed when it comes to getting objects. I'm going to go ahead and save that statement. And now it says this public has public access. Well, yes, the bucket does. We even see that all the way up here. You can't miss it. Let's go back to our other web browser tab where we were trying to connect to our static website hosted in S3, and let's refresh. And this time it works. So we can see the HTML document that references our logo JPEG file, which is popping up down below. Everything is working as designed now that we've set the S3 bucket permissions accordingly. You can enable S3 bucket cross-region replication, or CRR, for increased redundancy, essentially to synchronize the contents of an S3 bucket, or you can filter out which objects get replicated to an alternate site. And you might need to do that for regulatory compliance. So to get started here, I'm looking at the S3 Management Console, where I'm going to click on an existing bucket that I want to enable cross-region replication for. So I'll click on it to open up the bucket. Cross-region replication is available under the Management tab, under the Replication button. So I'll click Replication. Now the first thing that it's going to say when I go to enable this is that you need to create a replication rule. You haven't created any rules. Okay, I'll click the Add Rule button, and then I get a message that says the bucket doesn't have versioning enabled, and it's required before you can configure cross-region replication. Well, that's fine. For convenience, there's a button right here to enable versioning. So I'll click on that. Now at this point in the replication rule for the bucket, I have to decide if I want to replicate everything in the bucket in all folders, that's the default entire bucket, or if I want to use a prefix or tags. So let's say, for example, I only want to replicate the contents of the projects folder. So I would type in the folder name, projects, and make sure I end it with a front slash. But I could also specify tagging values depending on how objects stored in the bucket have been tagged. So for example, maybe what I'll do is type in, how about cost center? This may or may not already be in use. It doesn't matter. But cost center here, I'll choose tag cost center, and then I can enter a value for it down below. So if I want to do that, I can. But I'm going to specify that I want to replicate the contents of the entire bucket, and I'll click Next. Now I have to choose the bucket that I want to replicate to, whether it's in a different region or the same region, whether it's a part of this same AWS account or if it's a bucket in a different account. Remember, larger enterprises might have multiple AWS accounts for different departments, business units, different countries, and whatnot. So I can select or enter the bucket name, or I can simply choose Create New Bucket, which I'll do. And the new bucket will be called Bucket YHZ, that's the original one, but Replica, and Replica 1. And then I choose a target region. So some other region I want to replicate this to, let's say Canada Central. Now, while I'm doing that, I can also change the storage class for the replicated objects. To save on costs, I might choose the replicated objects to be stored in Glacier automatically, since I know that they won't be accessed often. Instead, maybe the primary copy of that data will. But bear in mind that when changes are made to the primary or original bucket, the changes will be synchronized to the alternate or second replica copy. I'm not going to change the object ownership. I can also enable replication time control settings. The idea with this is it allows me to get some metrics related to knowing when replication has occurred. And so if I'm in an organization that has regulations that stipulate until you've got multiple copies of the data, it cannot be further processed, maybe this would be an option that we would turn on. So it depends on your needs, as it usually does. I'll click Next. Now the next thing I have to do is make sure I select or create an IAM role that will have the appropriate permissions to allow the bucket replication to occur. I'll choose Create New Role. I'm going to call it Bucket REPL for bucket replication. Leave the status to enabled, and I'll click Next. So here's a summary of my selections. I don't want to edit any of them, so I'll go ahead and click Save. Now bear in mind that it might take a few minutes for data to be replicated to alternate regions. It's not designed to be real-time when you have the initial write in the source S3 bucket. Now notice down below that we can see our rule is listed here, and we can edit or delete it, but we can also add additional rules that might have different settings on replication for this bucket. So you're not limited to having only a single rule here. Now, if I go back to my S3 management console where I'm listing buckets, notice I also see my replica. And of course, under the region column, I can see the region that's in. This is one of those AWS services, S3, where if you go to switch regions here, so if I click, let's say, up here in the upper right, where we normally select regions, we see global. And it says S3 does not require region selection, which is correct, as opposed to other resources like EC2 instances. So we can now see that we've got our source bucket, which we already had, bucket YHZ, and our replica copy, to which we have enabled cross-region replication. S3 bucket versioning is the type of feature you might expect in a document management solution, where multiple versions of single documents are retained. Now, that might be required for regulatory compliance, or it might be something that the business elects to use so that previous versions of a document can be reverted to. So to get started here in the S3 Management Console, I've got a bucket called bucket-projects. If I click on it, there's nothing in it, at least nothing yet. So I'm going to go to the Properties tab where I can then click on the Versioning panel to enable versioning. The default is it is not enabled, so I'm going to choose Enable Versioning, Save. Now at this point, I'm going to click Overview so we can see what's in the bucket. It's nothing. But what I want to do is start creating some content and working with it, at least at the multiple version level, to make sure the feature is working. So I'm going to create a folder, and the folder is going to be called 2020 Projects. And I'll press Enter, and I'll click on it, and I'll choose Upload, and I'm going to upload a sample file. So I'll click the Add Files button to do that. So I'm going to upload a text file called project_a.txt. I'll just continue through the wizard to accept all of the defaults. So we now see the existence of the project_a.txt file. So if I click directly on that file, I can then click Open to see what's inside it. So what we see here is some sample text and the word changed. Okay. So now what I'm going to do is open a local copy of that file, save a change to it, and upload it with the same name, essentially over top of what's already there. But because versioning is enabled, we'll have access to the current version and the previous version. So here locally, I'm going to modify that file, and I'm going to add -2 after the word changed. That's my change, and I will save this file and close it. Back here in the S3 Management Console in my breadcrumb trail at the top, I'm going to go back to my 2020 projects folder. There's Project A. I'm going to click Upload, and I'm going to upload the same file name again. It's going to be the file I just saved a change to. So Project A, and I'm just going to continue through the wizard, accepting all of the defaults. Okay, so at this point, I'm going to click on Project A, TXT. I'll click Open, and we can see our changes reflected here. It now says changed -2. But let's say we decide, look, I would like to see previous versions of this file. I'm not interested in this version of it. So I'm going to close that out. Notice that when we go back to the listing of objects within our folder, we've got a versions area at the top. It's selected on hide, but I can choose show. So now I can see variations of the project.a.txt file at different points in time, such as at 12:35 and 30 seconds p.m. versus 12:37 p.m., which is the latest version. Well, I'm interested in the previous version, so I'm going to click on the link, the date and time stamp link for that file, that version of the file, I should say, and I'll click Open. And notice it only has the word changed at the top, not the -2. So this is the previous version. So you can work with previous versions of documents and download them and do whatever it is you need to do with them after you've enabled versioning at the S3 bucket level. In this demonstration, I'll be using the AWS Management Console GUI to create an S3 bucket. Now you will have first planned the purpose of this bucket. Is it going to be used to host a website? Is it going to be used to store Office productivity files like spreadsheets and documents and slide decks for users? Is it going to be used to store backups? And you're going to be considering how you'll configure the storage tier, such as Glacier for long-term archiving. Now let's get started with this. I'm going to start by typing in S3 in the Find Services field, and I'll click S3 to open up the S3 Management Console. Any existing buckets will appear in the right-hand panel. We're going to go ahead and click Create Bucket. Now you want to make sure you're consistent in your nomenclature for AWS resources. So this needs to be established within the organization. So I'm going to call this Bucket, and then I'll put in a code that's been pre-established for my location based on airport codes. Then I'm going to determine the region geographically where I want this created. So I'm going to leave, in this case, US East, North Virginia. Now, if you already have a bucket that exists whose settings you would like to copy to expedite this process, you can go ahead and do that down at the bottom. However, I don't want to copy settings from an existing bucket, so I'll just go ahead and click the Next button. We can determine at this point if we want to enable versioning, if we want to store multiple versions of objects stored in S3. So for example, you might do that if you're storing user files here, such as spreadsheets. And as people make a change to the file and then put it back in S3, the previous version is stored also. And we can revert to that if there's a problem with the more recent version not being the correct one. We can also turn on server access logging. We can also use tags to track things like cost items. So if this S3 bucket, let's say, is used by the development team for testing purposes, then we might flag it that way. So we might put in here for the key department and maybe development for a value. Or you could tie it to a project for billing purposes, anything like that. Down below, I'm not going to turn on object level logging. We can also turn on default encryption, but we can also turn that on after the fact. Now that will use AES 256-bit encryption. And we can also enable object lock, essentially to lock certain objects that shouldn't be writable by anybody that has access to the bucket. I'm not going to turn any of those items on. And I'm not going to turn on CloudWatch request metrics, although if you do need to measure the performance of data being transferred into the bucket and out of it, you can turn on the CloudWatch request metrics option. So I'm going to go ahead and choose Next to move on to the next step, which determines public access. Do we want to enable public access to the contents of the bucket? Notice the default is to block all public access. Now, down below, we can fine-tune this. We can block public access to buckets and objects granted through new ACLs or through any ACLs. And we can specify that this will be applicable for new public bucket or access point policies. I'm going to leave it as block because the nature of this particular bucket, at least at this point, is that we don't want to allow anonymous public access. So we'll go ahead and click Next. Here we have a summary of our selections, and we have an edit link for each one of them should we want to go back and make a change. I don't want to, so I'm going to go ahead and click Create Bucket. And after a moment, we can see our new bucket here, bucket YHZ. If I put a check mark next to the bucket, we can see here some of the properties based on our selection initially. We can see the permissions. For example, block public access based on our config is enabled. If we want to change any of these, notice that these headings are links. So if I click on permissions, it takes me into the permissions of the bucket, which is really equivalent to clicking on the bucket name and then clicking on permissions. So under overview, we have the option of creating folders just like you would on a hard disk, and you can upload content, download it. You've got a number of actions that will be available once you've got content up here. So for example, let's say I create a folder called projects. So here's a new folder called projects. I'll click to open it up, and then I can click the upload button, and I can either drag and drop files to upload them into S3, or I can click the add files button. So I've selected a number of project documents here that I want to upload. So I'll go ahead and click Next. From here, I can see myself, the owner. I have read and write access to these objects. We could add access for other AWS accounts. Larger enterprises might have multiple AWS accounts for different business units, different countries around the world, if it's an international firm, and so on. I can also manage the public permissions for these new objects I'm uploading. Now, because the bucket's public access setting is to block all public access, that applies by default to these objects. So I'm going to leave it on do not grant public read access to these objects recommended, and that's what we're going to leave it at. So I'm going to go ahead and click next. Then I can control the storage class or tiering. Here it's going to be standard for frequently accessed data, but I could choose, for example, one zone IA for infrequently accessed data that we don't need any redundancy with. And of course, we might select that because it's cheaper than using, for example, standard IA. Glacier would be for longer term archiving, as we see down below. And Glacier Deep Archive is for long-term archiving beyond even Glacier. I'm going to leave it as it is, and I'm going to click next, and then I'll click upload. And after a moment, we can see that the contents have been uploaded here to our new folder within our S3 bucket. Now, if I scroll back up at the top, you have a breadcrumb trail. So if I were to click on the bucket, for example, we're looking at the overview where we can see projects, but I can look at all of the different properties. So we were asked if we wanted to enable options such as versioning upon bucket creation. Well, you can come back here and turn it on later. Or if you want to enable server access logging, encryption, as we go further down, object locking options. So we have a number of things that we can tweak after the fact. We already mentioned the permissions briefly, where block public access is enabled by default. We also can go to management, where we might enable lifecycle rules to automatically move data, for example, into the Glacier tier for archiving over time when that data is not accessed. We might enable cross-region replication, and so on. Now, if we go back to Overview and open up the folder and, for example, even click on a file, then we get all of the settings for that particular file. We can open it, download it. We can see some details related to that file. We can also click on Properties and manage that file in many different ways: encryption, storage class, permissions to the file. So we have a number of items we can do once we start creating S3 buckets and populating them with objects. Amazon S3 Bucket Lifecycle Management uses what are called transition rules to migrate data from one storage tier to another in an automated fashion, such as taking data that hasn't been accessed in a long time and moving it to the Glacier storage class. So to get started with lifecycle management, the first thing you need to do is open up a bucket. So here I'm going to choose a bucket I've got called Bucket Projects. I'm going to click to open it up. And then I'm going to click the Management tab up at the top. Here we can see Lifecycle, and below that, we don't have any Lifecycle rules created yet, but we do have an Add Lifecycle Rule button. So I'm going to go ahead and click on that. I need to enter a name for this rule. So I'm going to call it Migrate Infrequent Access Data. Now, the next thing I'll do is specify further details, such as a filter to limit the scope. Do I want to apply this to everything in the entire bucket? Sometimes that might make sense, or you might want to only apply this lifecycle rule to a subset of the contents of the S3 bucket. So whether you want to put in a folder prefix followed by a slash, or whether you want to start entering in a tag key, such as cost center, you could then choose cost center, and then specify a value, so you could do that. I'm going to leave it here empty, which means I want this lifecycle rule applied to everything in this S3 bucket. Then I'll click Next. Now, if you've got versioning enabled for the bucket, you might want to determine if you want the storage class transition to apply not only to the current version, but to previous versions, or maybe one or the other. I'm going to choose both. Now, we can add specific transitions for current versions or previous versions. So let's say we only want this for the current version. So I'm going to click Add Transition. And now I'm going to specify that I want to transition this, just scroll down here, to Glacier, let's say 100 days after creation. Now, this way, I don't have to worry or think about transitioning infrequently access data. I can just automatically create this rule. And in this case, after 100 days upon creation, it will be transferred to the Glacier storage class. So I acknowledge this, and I'll click Next. I'm not going to configure expiration for anything. I'll just click Next and Save. So we now see that we've got the entire bucket that is being subjected to this lifecycle rule that's going to migrate data 100 days after creation to the Glacier storage class. You can use the S3 Management Console to view and change S3 storage tiers or storage classes for objects that you have stored in S3. For example, here in the S3 Management Console, I'm going to open up an existing bucket which contains a folder called Projects. So I'm going to click to open that up. Now, what I can do, first of all, is already see the current storage class with the column over to the right for items that are stored in the S3 bucket. So currently, they're all set to standard. You can determine the storage class when you originally upload content into the S3 bucket. But you can also change it after the fact. So, for example, I could put a check mark in the box next to a file, and then I could go to the Actions menu and I could choose Change Storage Class. We can see currently it's standard, but I might switch it to Intelligent Tiering, essentially, which automatically determines, based on the usage of that file over time, how it should be stored. Or Standard, Infrequently Accessed, or Standard IA, which does include redundancy, or its counterpart, which does not, One Zone IA, which is cheaper, or Glacier for archiving, Glacier Deep Archiving for long-term archives, or even Reduced Redundancy, which is not recommended because you don't have multiple copies of the data. But you get to change whatever you want here. So for example, let's say I'm going to choose it as being One Zone IA, and I'll choose Save and Change. So we can now see under the column for storage class, it now reflects that change that's been made. But you can also do this at the folder level. So for example, let's just scroll up so we can see our breadcrumb trail up at the top. So let's say I went to my bucket, and let's say I put a check mark next to the projects folder. Having done that, now if I go to Actions, I can change the storage class from here. Now, you're not really changing it on the folder. That's not what's happening. What you're really simply doing is using this as a shortcut to set the storage class for all subordinate objects in and under projects. That's really all you're doing. So let's just go ahead and say One Zone IA if that suits our needs. I'll click Save and Change. So now if we open up the projects folder, notice, if you look over to the far right under the storage class column, indeed, all of the items are now set to One Zone IA for the storage class. You can configure a variety of different S3 storage classes for items stored in S3 buckets, and they can address different usage scenarios. We have to consider things like the amount of data that will be stored in S3, how frequently access to that data is needed. That definitely has an impact on the storage class. Any redundancy, we might need multiple copies, such as due to regulatory compliance of data. And ultimately, the cost is what is affected in the end when we think about the amount of data we're storing, how frequently we need to access it, and how much redundancy there is. There are a number of different S3 storage classes. The first one is Standard, which is really used for data that is not accessed frequently. So you can think of standard storage as being something that would be useful for hosting website files, or even for the storage of big data that's then going to be fed into an analysis engine. You've then got One Zone IA. Now, IA stands for Infrequent Access. And One Zone IA, as opposed to Standard IA, means that we don't have the redundancy because it's in a single zone, a single availability zone. So in the end, it is designed for data that doesn't require frequent access, such as the standard storage class or tier would dictate. Glacier is actually used for archiving. It's a low-cost solution, but depending upon what kind of retrieval you specify will determine how long it takes to retrieve archived data. So it could stem from minutes, potentially to hours. Intelligent tiering isn't a storage class, but rather a feature in Amazon Web Services for S3. where data is monitored and automatically placed in the best storage tier based on things like how frequently it's accessed. Whether you're using GUI or command line tools, you can set the storage class or tier at the S3 bucket folder level or at a specific stored object within the S3 bucket folder. Pictured on the screen, we have an example of using PowerShell to change the storage class to Glacier of an item stored in S3. This is done using the copy-s3 object commandlet. We use the -bucket name parameter and give it the bucket where the item exists currently. We use -key and refer to the folder and or item name. In this case, the item is called project_a.txt. We use the -destination key parameter in case we want to give it a different name. Here we're just using the same name, but what we're doing is using the -storage class parameter and passing it a value of Glacier. So we are changing the storage class from whatever it currently is to Glacier for the project_a.txt file. Amazon S3 Glacier is a cloud archiving solution for AWS. Retrieving data from a Glacier archive can take from minutes up to hours. You get to specify expedited retrievals as an option, so you might access data within 1 to 5 minutes based on a certain rate of the amount of data that gets retrieved. So it's considered an inexpensive storage medium for infrequently accessed data in the cloud. You can also configure policies for regulatory compliance. So, for instance, you might configure some kind of a legal hold option which makes archived data immutable. Immutable means that the archives cannot be altered. In other words, they're read-only. You can configure S3 bucket lifecycle management options to automatically move data into the Glacier type of storage tier. Now, that data would be inactive before it gets moved automatically to Glacier. When you work with Glacier, you first need a vault for archive storage. And the vault can be created even using the AWS Management Console. You don't have to do it at the command line. You can also use the AWS CLI or the REST API for programmatic access to Glacier, and you get to choose from the AWS Software Development Kits or SDKs which language you want to write your code in to talk to Glacier APIs. Now, this is going to be required when you are uploading and retrieving archived data. So while you can create a Glacier vault using the AWS Management Console, you can't actually upload and retrieve content from the archive using the GUI console. So pictured here, we can see two examples of working with Glacier at the AWS CLI level. In the first example, we are actually archiving something, uploading something to the archive. So we're doing that with the AWS Glacier upload-archive command. We're giving it our account ID, so --account-ID, --vault-name. In this case, the vault is called Vault1. And then we're giving it the item that we actually want to upload into the archive. We do that by specifying the --body parameter. Here, it's a file that we would have available locally called file.txt. In our second example, what we're doing is changing the storage class of an existing item that's already stored in an S3 bucket, and we're setting the storage class to Glacier so it will be archived. So we're doing that with the AWS S3 CP command. CP means copy. And what we're doing is specifying S3:// and the path, including the bucket name, the folder. There is no folder here, but if there were, it would be included in the path, and the actual item name. In this case, it's a file called licensekey.txt. Then we have a space, and we continue with the target. In this case, the target is the same bucket name and same file name, but we're using the --storage-class parameter, and we're giving it a value of Glacier. So that file, licensekey.txt, then, will now be in the Glacier storage tier. The other thing to consider is the Amazon S3 Glacier Deep Archive option. Now, Deep Archive is for really long-term archiving, where you might have to access the data perhaps once, maybe twice annually, so very infrequently. But retrieval can take anywhere between 12 to 48 hours. So you could consider this to be a great solution then for offline data protection. So perhaps protection of things like intellectual property documents of some kind, or plans, even long-term backups, financial records that you might have to keep for a period of time to remain compliant with regulations. As the name implies, using S3 transfer acceleration speeds up file transfers with an S3 bucket. And this is done by taking advantage of the Amazon CloudFront Content Delivery Network, or CDN, where data is copied or cached in different geographical endpoints around the globe. To get started here, I'm going to click on an existing bucket here in the S3 Management Console. Next thing I need to do is go to the Properties tab, and then down below under Advanced Settings, I'll see the Transfer Acceleration panel. Currently it's suspended, so it's not enabled. When I click on that option and scroll down, I have a link. It says, want to compare your data transfer speed by region. That sounds interesting. Let's click on that and see what happens. So it's taking a look at the source region where my bucket exists in North Virginia, US East 1, and it's giving me a sense of what a sample uploaded file to an S3 endpoint in that region would look like in terms of the transfer speed, after which it'll then show me the same type of thing but using S3 transfer acceleration. So we can now see it's doing the sampling for S3 transfer acceleration. Bear in mind that you pay when you use S3 transfer acceleration. However, if we take a look, we can see here it says it's 66% slower. Now, if you also are in a different region and you try the testing again, you might get different results, such as in this case, where the S3 transfer acceleration, in this case, is 17% faster. So you can gauge this based on the source, where your points are that you will be transferring files from, and where the S3 bucket resides, in which geographical region. So when I'm happy with the performance of it, then I can go ahead and enable and save the transfer acceleration feature. But remember, the benefit is when you have the origin location of file transfers being far away from the region where the S3 bucket resides. You can think of Elastic Block Store or EBS volumes as being similar to virtual hard disks that can be associated with virtual machines. To get started with building an EBS volume, here in the AWS Management Console, I'm going to click on EC2 under All Services Compute. Now here in the EC2 Management Console, I'm going to scroll all the way down under Elastic Block Store, and I'm going to choose Volumes. Existing EBS volumes will be shown here. Now we can also select an EBS volume, and down below, if we look under the Description tab, we can see the attachment information. So we'll see, for example, that it's attached to an EC2 instance. We can see the instance ID, as well as the name of it and the device reference for that attached disk volume within that operating system. So when you build an EBS volume and attach it to an existing EC2 instance, it's like adding another storage device that will show up in that operating system. So you would use the tools within the OS, whether it be Linux or Windows, to initialize that new disk device, to partition it, and to format it before it can be used. So to create a new volume, I'm going to go ahead and click the Create Volume button at the top. You always have to think about how this volume will be used. The default is General Purpose SSD for solid-state drives. Now, when I select that option, I can choose the size in gigabytes. It's set here to 100, but the IOPS will be somewhere between 300 and 3000, where IOPS is a measure of the disk throughput. Input-output operations per second is what it really stands for. But if you're looking for the ultimate in performance because you need this volume to support a workload that's very disk-intensive, then what you might choose is Provisioned IOPS SSD. When you do that, notice the IOPS field becomes available. So you can put in a value up to a max of 64,000 IOPS. That's a far cry quicker than going with general purpose, which maxes out at 3,000 IOPS. So depending on your need, will determine what you select. You can go with cold hard disk drive, that's the magnetic disk drive storage, where IOPS shows not applicable, so it's much slower. Cold referencing really the fact that you might want to have data that's infrequently accessed working with this volume. You've got throughput optimized HDD, again, IOPS not applicable, and magnetic standard. Anything that's HDD, hard disk drive, uses a magnetic standard disk in the AWS backend, which has moving mechanical parts, which is always slower than solid state drives or SSDs. So let's say I need the absolute best possible performance. So I could choose provisioned IOPS SSD. I'm going to leave it at 3000 IOPS, but if we needed much better disk I/O performance to support the workload, we would go ahead and choose it. Down below, I can determine the availability zone where this will be created. I can also create this from an existing EBS volume snapshot. Now, I want to create a blank, empty EBS volume, so I'm not going to do that. And I can also choose to encrypt this volume. So I'm going to go ahead and do that. And from there, I can then choose a key. I'm just going to choose a key I already have here called key east. Now, you don't have to encrypt it at this level. As a matter of fact, let's turn that off. So instead, I'm going to remove the check mark because you might choose to use operating system level encryption. So for example, if you're using a Windows operating system, you might elect to use something like BitLocker to encrypt that entire disk volume instead of encrypting it at this level. We can also add tags here. I'm going to call this name, and the value will be data disk 1, and I'll choose create volume. And I'll click close. So we can now see data disk 1 is in the midst of being created. Now at any point in time, we'll just select another EBS volume. You can select an EBS volume and go to the Actions menu and choose Modify Volume if you want to make some changes, such as the volume type or the size and items of that nature. You can also go into the Actions menu and detach it from an EC2 instance if it's already attached. Now I know this one is because detach is available and attach is unavailable. Of course, I could always just go down below under description and see the attachment information. So I'm going to go ahead and select data disk 1, and notice under the Actions menu, we have the option of attaching it because it's not already attached. We can also modify tagging information, which we could also do down here at the bottom by clicking the Tags tab. Bear in mind that an AWS resource cannot have more than 50 individual tags or key and value pairs associated with that item. After you create an EBS volume, you can then attach it to an EC2 instance, at which point it shows up like another disk storage device in that operating system. So here in the EC2 Management Console, I've already navigated to the Elastic Block Store Volumes view. I've got an EBS volume that I've got tagged here with the name of Data Disk 1. So I'm going to select it. Now down below, if I take a look under the Description tab, we can see that there is no attachment information. So therefore, this EBS volume has not been attached to an EC2 instance. This is also evident when we go to the Actions menu, still having it selected. We can't detach the volume because it's not attached. So I'm going to choose the Attach Volume option. Now from here, I'm going to choose, or I'm just going to click actually in the Instance field, and from the drop-down list, I'm going to choose an existing Windows EC2 instance. So I can see the instance ID here, I can see the name it was tagged with, and I can see the fact that it's stopped. So I'm going to select that. It automatically detects the device reference that will be used within the OS for this volume, and you can change it. I'm going to leave the default. I'm going to click Attach. So now for Data Disk 1, down below, if you look under the Description tab, we now see attachment information. And if we go to the Actions menu, Attach is no longer an option, nor is Delete. You'd have to detach the volume from the instance before you even thought about deleting it. And so let's go ahead and fire up that instance. So let's go to the Instances view. I'm going to go ahead and select that instance. And if we take a look down below, I'm just going to scroll down under the Description tab for it. We can see that we've got our second block device. The root device is for the OS. Then we've got our second block device. Here it's XVDF. That's our EBS volume that we've just attached. So it's showing up on this end as well. Let's go ahead and go to the Actions menu, Instance State, and let's start that EC2 instance and see what that newly attached disk volume looks like. So I'll pop in the public IP address here, username as administrator, and I'll choose connect, and I'll go ahead and put in the password that we've just decrypted. Don't ask me again for connections to this computer, and I'll choose yes. So when we get into this operating system, in this case Windows Server 2019, we then want to go into our disk management tools to see what that newly attached EBS volume looks like. So from the Start menu, I'm going to go ahead and start the Server Manager tool. I don't have to do this, but this is one way I can get to the place I need to be to manage disks. So for example, I could even go to the Tools menu here and choose Computer Management. And then once Computer Management opens up, we could then start working with our disk subsystem. Let's just maximize this by going into the Disk Management tool, listed over here on the left. So what we're seeing here is disk 1 here. It's unknown, about 500 gigabytes. It's offline, unallocated. So if I right-click on the disk, I can bring it online, and I can right-click and initialize it. Let's say we're going to initialize it as Master Boot Record or MBR. And at this point, I could go ahead and right-click on that unallocated space on that disk and choose, let's say, to create a simple volume. I'll use the entire space, and I'll just accept all of the defaults. So at this point, it's really no different than if you were working with a physical disk device that you plugged into a physical server. In Amazon Web Services, the Elastic File System, or EFS, is essentially a shared folder in the cloud that you can connect to, either from on-premises devices or from EC2 instances running in the AWS cloud. What it is an NFS share that we connect to, for example, even from a Linux host using the mount command. So let's get started here. I'm going to search for EFS in the console, and I'm going to choose it from the resultant search list, and I'm going to choose the Create File System button. First thing I have to do is specify the affiliation with a VPC and subnets. So I've got that automatically selected here, so I don't have to make a change. I'll choose Next. Now I need to give this a name, so I'm going to add a value for the name, and I'm going to call it Project. Actually, I'll stick with lowercase. Project Files. I don't have to stick with lowercase, but just to keep things simple and consistent. Now you can also enable lifecycle management here based on the items stored in this EFS file share, as we will call it. So maybe after 60 days since something was last accessed, we want to change it to a different storage class. Now that class is listed here as being the EFS Infrequent Access or EFS IA class. You would do this to save money for files that are still stored in EFS but that are not accessed often. Now, unless you have a very busy disk I/O workload related to this EFS configuration, you shouldn't have to use provisioned for throughput mode, or you shouldn't have to choose performance mode of max I/O. I'm going to leave the default selections because I know I just have periodic access to files here. I can also enable encryption for my EFS configuration. I'm going to choose to enable encryption of data at rest. And here, it's already got the KMS master key managed by Amazon that it's going to use. That's fine. I'm going to go ahead and click Next. I've got a summary. I'm going to go ahead and click Create File System. The next consideration is going to be, how will clients mount that cloud-based file system? So we can see here in our list that we've got a file system, and it's automatically expanded here. It's called Project Files. We can see the file system ID. And it's got 2 mount targets. If we open that up and take a look, we can see some of the details, such as the fact that it's general purpose performance mode, the throughput mode is bursting, and that encryption of data at rest has been enabled, and also that a lifecycle policy is enabled. You've got little pencils here next to the items that you can modify related to that. Now, as we go further down, because we specified a VPC and 2 availability zones, so the subnets are in different availability zones, we've got 2 different mount targets whose state is currently listed as creating. Notice they have different IP addresses and different mount target IDs. Now, up above, we have links. For example, from within the same VPC here, VPC1, if you've got EC2 instances in that same VPC, there are instructions for mounting this EFS configuration versus across VPC peering connections or if you're on premises. Well, I've got an Amazon Linux EC2 instance running in VPC1, so I'm going to click the first link here for mount instructions. So here it talks about choosing to install Amazon EFS utilities, and then continuing further down, we can see that we can use the mount command to mount a remote file system, that would be EFS in this case, as if it appears in the local file system where the type or -t would be EFS. Now, having done that, notice that we're prefixing that command, or we will be when we do it, with sudo to run the mount command with elevated privileges. Now you can use, instead of the EFS ID, you can also use here the IP address, which if we just close out here, we saw listed down below. There are two of them because we've got access to two of these configurations for EFS in different availability zones. So here in my remote SSH session with the Linux host in that VPC, I'm going to run sudo make dir / and I'm just going to call the folder on the root of the file system here EFS. Then I'm going to run sudo mount -t for file system type. I'll specify NFS4, and here I've placed one of the IP addresses in one availability zone, followed by a :/ and then a space, and then the local mount point in the local file system, which is what was created in our previous command. It's a folder called EFS off of the root of the file system. Go ahead and press enter. And after a moment, it's done. So if I change directory, for example, to EFS, well, there's nothing in here if we do ls because it's brand new, but I can work with it as a regular file system, as I might normally do in a Linux environment. And if I were, let's say, to clear the screen and type in mount, we'll see that we do have a mount point for NFS4. So the local /EFS directory is essentially pointing to 172.31.92.130 in the AWS cloud. It's an NFS shared folder. You can control access to the contents of an S3 bucket using a permissions policy, a bucket policy. To get started with this in the AWS Management Console, I'm going to go ahead and search up S3 and pop up the S3 Management Console. And I'm going to click on an existing bucket where I want to set the policy. Now to get to it, I'm going to have to go to the Permissions tab where I'll see a Bucket Policy button. And from here, if we already have a policy, it'll be shown here in JSON syntax, but we have nothing. Now down below, instead of typing it in from scratch, starting on line 1, we could click instead the Policy Generator link, which opens a new tab. And from here, we would choose for the type of policy, S3 Bucket Policy. Now we have to determine if with this specific configuration we want to allow or deny specific access to the bucket. I want to allow it. You could specify the principal or principals. You could have a comma separated list. Principals are security entities like user accounts that would have access to the bucket, or even IAM roles. Now you could also specify an asterisk here for everybody. So the AWS service is set to S3. Then you get to determine the action, or you could just choose all actions. But normally you don't want to do that. That's basically in violation of the principle of least privilege if you're just giving all access instead of only the access that's needed. And maybe the only access that's needed is to retrieve information. So maybe using the get series of actions in S3. So maybe get object, for example, to retrieve objects. So once you've configured this correctly, you also have to make sure you put in the Amazon resource name or the ARN for the S3 bucket. Now the ARN will look like this. I've gone back to my policy permissions page where I can see the code that's been generated here. I can see that the ARN here is set to AWS :S3 : and then the name of my bucket /*. We can see that S3 get object as an action has been selected. The principal here, of course, is the asterisk. The effect is to allow as opposed to deny. So I'm going to go ahead and save that policy. And notice when I do that, I get an error, access denied. Now, there was a message that was displayed here down below that says that the block public access settings turned on for this bucket will prevent granting public access. Okay, well, let's go to block public access up at the top. It's currently on. Well, that's not good. Let's click edit. We're going to turn that off, save that. I'm going to type in the word confirm as it requests to confirm I want to do this. I'm going to go back to the bucket policy again. And I've got my policy code in here now, so I'm just going to go ahead and click on save. Notice this time it says this bucket has public access. Now, naturally, you don't want to take this lightly. If there's any type of sensitive information, then you don't want to do this for the entire bucket. So now that we've done this, we need to test it. So the way we're going to test it is go to the Overview tab for the bucket where we can see, for example, we've got a projects folder. We've got a number of files available here, such as project.a.txt. If I were to just click the checkbox to the left of it, we can see the object URL over here. So let's just click on that. And notice it takes us directly into the contents of that text document. We aren't prompted for credentials or anything because the bucket policy, along with turning off blocking public access, allows us to view this S3 object. Every Amazon S3 bucket has an access control list or an ACL that determines which entities have access to the contents within the S3 bucket. To look at that, here in the S3 Management Console, I'm going to click on an existing bucket to open it up. I'm going to click on the Permissions tab at the top, then I'm going to click Access Control List. So we can see up at the top the canonical ID for the bucket owner, that is myself, which has the ability to list objects, write objects, and read and write bucket permissions. Now below that, we have an Add Account button for other AWS accounts. Now remember, larger enterprises could use multiple AWS accounts for different business units, different projects, or different countries, that type of thing. So you might require to open up what the contents of this bucket are to another department or another project and whatnot. So to do that, we can click Add Account, where we can specify a canonical ID number or an email address for that other account. And then, of course, set the appropriate permissions. Now, down below, we can also grant public access permissions for everyone or S3 log delivery group permissions for logging purposes. So back to public access, I've turned on everyone. Let's say we want to allow list objects. It says this bucket will have public access because that's what you're turning on. Now I could also elect to turn on writing of objects, but let's just leave it at list objects and I'll just click save. Now when I scroll back up, notice how it shows us that we've got public access for this entire bucket. So that if we were to go to the overview, let's say, where we can see folders, click on that. We can also see files. We could test out access to a file. So if I put a check mark to the left of a file, it pops up the property dialog box on the right where I can see the object URL to that file. So when I go ahead and click on it, it lets me straight into it. Now this is because we've modified the ACL, the access control list for the bucket, to allow listing of objects here for the S3 bucket. Now, there are many other ways that you can do this as well through a bucket policy and enabling bucket public access, making sure that it's not blocked. Here in the S3 Management Console, I can see I've got two existing buckets. And under Access, it says Objects can be public. Now, when I go to create a bucket, let's do this. And I'll just fill in a fictitious name with some random numbers. We're not actually going to create the bucket, but I want to show you that when you go through the process of creating a new storage bucket in the cloud, when you get to the block public access portion of the wizard, notice the default is to block all public access. So I'm going to click the X. I don't want to create this. Now, clearly that's not been left as it was for bucket YHZ because it says objects can be public. Okay, what does that mean exactly? It means public access to the contents of the bucket, such as not having to authenticate to gain access to files. So for example, if I click to open up the bucket, I can see there's a projects folder. Let's open that up. And I can see a number of files in that folder. I'm going to put a check mark to the left of one of them. And over on the right, I'm going to click the object URL to see if I can connect directly to it. Of course, it lets me in directly because public access is not being blocked currently, as it would be by default upon the initial creation of the bucket. Now let's check this out. So if I go back here in my breadcrumb trail in the upper left and click on the name of the bucket, and if we click on permissions, so here's block public access. Oh, it's been turned off down below. Well, that's not the default, but we can change it back if we so choose. If we decide, I don't want to allow basically anonymous access to the contents of this bucket any longer, you can change it around. So I'm going to click the edit button. I'm going to choose block all public access. You have a number of subordinate options here. So blocking public access to buckets and objects granted through new ACLs or through any ACLs granted through new public bucket or access point policies. Now that would be by going to the bucket policy up here, and also through any policies. So not just new ones, all of them. So we're blocking everything here. We're not allowing any public access. Okay, let's save this. It wants us to type in confirm. Okay, confirm button. And it says public access settings updated successfully. Let's try this again. Let's go back to the overview tab for the bucket. There's the projects folder. And there's, well, it doesn't really matter which file, but we'll choose the same file by clicking in the checkbox to the left. And I'm going to click the URL over on the right for that file. Now, if we do a refresh, we're now getting an access denied because public access has been blocked, meaning that it's been turned on, the blocking feature to block public access. Amazon S3 supports cross-origin resource sharing, otherwise called CORS, spelled C-O-R-S. Now, to explain this, imagine that you've got a client using a web app, so that means that the client device is connected to a specific DNS domain name for that web app. But let's say that there's a component in that web app that needs to call upon a resource in a different DNS domain. Well, that's where things can get a little bit sticky, and if permissions aren't set correctly, that request will fail. Now, we can enable this by setting up cross-origin resource sharing. To do that, you first need to create a CORS config XML file. Now, you could use a standard text editor and write it from scratch, but more often than not, you'd probably find yourself using the CORS editor that's built directly into the S3 bucket properties permissions page. And the next order of business is to create one or more rules. Now, you can create up to 100 rules within a single configuration. Now, these rules are used to define origin DNS domain names and what access they should have to target DNS domain names. And you'll see what I'm talking about in a minute when we look at a sample configuration. So you specify the allowed origins to target the bucket and the allowed HTTP methods, whether it's get, put, post, delete, or head. Now, pictured on the screen, you're looking at a sample CORS configuration. So we've got the first opening tag, CORS configuration, and at the very bottom, /CORS configuration to close that tag. Then we've got a single CORS rule within the configuration. The allowed origin here is listed with https:// and it's got a DNS name. This would be the origin name for, in our example, the web app that the user is connected to. Now that's the allowed origin tag. The allowed method in this case is only get. We've also got max age seconds here. Now, this is the amount of time that the client web browser will cache the response from Amazon S3. Now, this is just used to speed things up in some cases. Then we've got the allowed header tag, which has an asterisk in it. This is in reference, of course, to HTTP headers. So because this configuration is within the S3 bucket environment, we know what the target is. So we are allowing calls from the listed allowed origin. When you store something in an S3 bucket, For example, here in the S3 Management Console, I'll open an existing bucket and folder. Here we can see we've got a number of files in the bucket, and under the storage class column, they're currently set to standard. Now, we could select one or more of those entities, and we can go to Actions, change storage class, and maybe to save money, we would switch it to Standard IA, infrequently accessed, which costs less than the standard storage class. But how do you know, especially when you initially put contents or files into the bucket, that is going to be the usage pattern over time? You don't always know. And that's where the S3 storage class analysis comes in as being handy, because it'll watch access to your S3 objects, either the entire bucket or based on tags or some kind of filter string. It's up to you. And it will make recommendations over different time periods, number of days, of when you might consider moving things over to standard IA, infrequently accessed, to reduce your storage charges. Now, how does this work? Let's go back to the bucket. So I'm going to click on the bucket name and the breadcrumb trail up at the top. Now, if I go to Management, you can add lifecycle rules manually to determine that you want to move data to a different storage class, but that's not what we're talking about, at least not directly. S3 storage class analysis can help you properly craft your lifecycle policies, but it doesn't do it for you automatically. So what I'm going to do then is under Management, I'm going to choose Analytics. Now here for storage class analysis, we can search for filter, prefix, or tag. Well, really done anything yet. So I'm going to click Add down below. Now I'm going to add a filter called Filter 1. Now you can add multiple filters. Literally, you can have up to 1,000 filters, and you'll get a separate analysis report for each of those filters. And that can be useful if, for example, you're storing files in the bucket for project A as well as for project B, and you want to do a storage class analysis just for project A stored items. You could do that if you wanted to. So down below, we can put in a prefix, a text string prefix, or even a folder name, for example, or tag information that we want to filter by, or we can have this filter apply to the entire bucket contents. So I'm going to leave it empty so that the entire bucket will be analyzed, and I'm going to click Save. You can now see it says Analyzing your data. Now, realistically, you shouldn't expect to get meaningful information right away. This is designed to analyze your storage uses over time. Now, the different uses of data will vary depending on the nature of data, but here I've gone to the documentation for S3 Analytics so we can get a sense of what the result will look like over time. What you're going to start to see, just scroll down here, is you're going to get a sense of what it will present in terms of a chart or a graph that you can look at. So notice we can see here that we've got S3 objects between 90 and 119 days old, and we can see the amount of space that is available. But take a look as we go further over to the right, we can see S3 objects that are older, and these are classified as infrequently accessed, and they would be a good candidate for transition to standard IA as a storage class, standard infrequently accessed. So we can see from the legend above that the blue listings are for the amount of storage and the purple is for the amount of data that was retrieved from that overall storage. So the purpose then of S3 storage class analytics is to let it watch access to your S3 objects over time to determine if some things don't get accessed a lot or often and therefore should be transitioned to standard IA. And you would configure your lifecycle policy rules accordingly based on this resultant output. S3 object locking is a powerful feature. There might be times where you need to secure some objects stored in an S3 bucket from being deleted or modified. And we can do this through S3 object locking. But the thing is, it's one of those features that you have to enable when you create the bucket. For instance, let's open up an existing bucket I've got here called Bucket YHZ. I'll click to open it up. We're going to go to the Properties tab for the bucket, and I'm going to scroll down, and there's object lock. Let's click on it. And it says object lock can be enabled only when a bucket is created. If you're not sure if you're going to need these kinds of options to prevent modification of the contents of S3, maybe to regulatory compliance or maybe for legal hold reasons. Maybe you've been instructed by your legal department to enable legal hold for some objects in S3 because they might be used in a court of law. And for admissibility in a court of law, there needs to be a way to prove that the data was tamper-proof. So given that we can only do this upon creation time, it might be a good idea to create buckets with the option on, and then you can determine if you actually want to use it after the fact. Okay, I'm going to close out of that. We're going to create a new bucket here. So I'm going to go back to the Amazon S3 Management Console. I'm going to click Create Bucket. This we'll call Bucket YYY, and I'm going to click Next. Now, on this page here, the second page of the wizard here for Configure Options, if I scroll down under Advanced, there's Object Lock. However, I can't turn it on. If I just read a little bit further, the fine print below it, it says Object Lock requires bucket versioning. Let's turn on versioning up at the top here. Let's go back down and try it again. Yeah, that worked. Object Lock is now enabled. Okay, let's go through and accept the rest of the defaults to get the bucket created. There's our new bucket, Bucket YYY. If I click to open it up and go to the properties, sure enough, if we go down under Advanced Settings, there's the Object Lock panel. It's permanently enabled. If I click on Object Lock, we have some other options. We can enable Governance Mode. Now, it says very clearly here, if you do this, Governance Mode can be disabled by AWS accounts that have the appropriate IAM permissions. But if you enable something called Compliance Mode, it cannot be disabled by anybody, not even the AWS root account. That's interesting. So depending on your legal or regulatory requirements, will determine whether you enable governance or compliance mode. Now, either way, if you were to choose governance mode, you have a retention period, the default of which is 1 day. The same thing is true for compliance mode. What does this mean? That really means for how long compliance or governance mode, or in other words, how long objects will be locked, after which you can then delete them if you need to. So I'm going to go ahead and turn on Enable Governance Mode, and I'll choose Save. I'll leave the retention period at the default of 1 day. It says, okay, well, please type in confirm. Very good. We're going to go ahead and do that. So I'll type in confirm. Looks good. So let's go back up here, scroll back up, and let's go to the overview of the bucket. Let's upload a file to see if it picks up that change, because existing files will not have that applied to them. So I'm going to click Add Files and add a sample file here, and I'll go ahead and click Next, and basically I'm going to accept the rest of the defaults. So we've got a new file uploaded. Let's click directly on the file name. Let's go to the Properties tab for that file, and let's go down and click on the Object Lock panel for that individual S3 file, that object. Notice Governance Mode is automatically selected, and the retention date or the lock date is a day after today's date. Now notice what's different when you go into the Object Lock settings for an individual object as opposed to the entire bucket level. You get the legal hold option. You can turn on Enable for legal hold. Think of legal hold as being an override to the retention date. So basically, when legal hold is enabled, then this item cannot be modified until legal hold is disabled, regardless of what the retain until date says. So I'm going to go ahead and choose Save. Okay, so it says legal hold was successfully enabled for this object. So I'm just going to go back to the bucket. So at this point, we've enabled object locking at the bucket level during creation time, and we also saw how we can enable legal hold for an individual S3 object. Encryption of data at rest in the Amazon Web Services cloud is sometimes required to be compliant with laws or regulations. We can do it. We can set encryption as a default at the bucket level. So for example, here in the S3 Management Console, I've got an existing bucket named Bucket YYY. Now let's click on it to see what's in there. We've got one sample file called project_a.txt. If I put a check mark to the left of it and look over on the right at the properties, we can see encryption is set to none. Well, that's consistent with the fact that if I go into the Properties tab here for the bucket, and if we look at the default encryption, it's actually disabled. Okay. However, what we could do is we could enable an individual object in the bucket for encryption if we wanted to. So for example, project A, I'm going to select that checkbox to the left to select it. I'll go to Actions and I'll choose Change Encryption. It's currently set to none. Let's use AES 256. That's Advanced Encryption Standard, 256-bit encryption, where Amazon will manage the keys. Otherwise, we could use KMS, where we've got our own keys that we control, and that might be required sometimes to remain compliant with certain regulations. For this case, I'm just going to use AES 256 and choose Save. It says all objects will change encryption. Well, it's only one object up there. That's okay. Perfect. Change. Now, let's just click somewhere else and come back to Overview and refresh to make sure everything's good. And I'll just put the check mark to select that file again. Let's just check the encryption over here on the right. Notice now it says encryption, AES 256. Okay, but wouldn't it be great if we didn't have to worry about it? Well, we can set it as a default for the bucket. So let's go back into the Properties tab for the bucket. Let's go down to Default Encryption, and again, I'm going to choose AES 256. There's just a little note here that bucket policies, which control permissions such as reading and writing to the bucket, among other things, really get executed first or evaluated before bucket encryption occurs. Good to know. That's fine. Save. Okay, so we've enabled AES 256 encryption as a default for the bucket. Let's go back to Overview. Let's upload some new content to the bucket. So I'm going to go ahead and go through next and accept all of the defaults here. And we've now got a new file, project_B. And if I select it here and look over on the right, we can see that the encryption is automatically set now to AES 256-bit. So it's picked that up from our bucket default encryption setting. You can use the AWS CLI to encrypt the contents of S3 buckets. Here in the S3 Management Console, I'm looking at an existing bucket named bucket Y8Z, and I've got a projects folder within it with a number of sample files. And I'll just click on that to open it up. Notably, we're going to be working with project A TXT, project B TXT, and project C TXT. Now, if I click on any one of those to select it and take a look at whether or not it's encrypted, notice encryption is set to none. We'll just look, let's say, at project C. Same thing is true for it. Now let's flip over to the CLI and let's start some encryption. Now in this particular case, I'm going to encrypt that existing file. So I'm not going to set it as a default at the bucket level. So I'm going to do that using the AWS S3 CP command. CP means copy. If you're a Unix or a Linux person, then you definitely know that. So what I'm doing is specifying the S3:/ prefix, the name of my bucket, the project's folder. We know there's a file there called specifically project_A.txt, and we want to copy that basically to the same name. Repeating that, that's the target. But what we're doing is adding -SSE for server-side encryption. We're specifying we want to use AES 256, which means that these are Amazon-managed keys. Let's go ahead and do it. Well, we didn't get very far because there's a space. Syntax is wrong. Well, let's go back and fix that. These things happen. Let's try it again. Looks better, but let's go and check our work in the console. Back here in the console, let's just select Project A here, and let's just take a peek. And indeed, the encryption is AES 256. I didn't even have to click the refresh icon to see that change. But what if you want to encrypt everything? Certainly, you're not going to do it for each individual item. So we can do that. Here we're going to accomplish this with the AWS S3 CP command. So copy again. Same kind of thing, except instead of pointing to a specific S3 object, in this case, I'm just going to point to, well, I could point to just the entire bucket, but here I'm pointing to the projects folder within the bucket. And the same thing is true for the target. The only thing that's different here is I'm saying --recursive, and of course, once again, --SSC for server-side encryption. And I want to set it to AES 256. Again, Amazon-managed keys. That's fine. Let's press enter and make it so. We're going to go check our work here. So it looks like it did it to all of the items within the projects folder. So back here in the console, really, we can take our pick. How about project B budget XLS? How about that file? So we'll select that and deselect the other one. And we can take a look here. We see that encryption indeed is set at AES 256. PowerShell can be used to enable default S3 bucket encryption. In this example, we're going to take a look at an existing bucket here in the S3 management console called bucket YHZ. So I'm going to click on it to open it up and go to the properties. And let's just take a look at the default encryption panel. Currently it says disabled. Now we could, here in the GUI, enable it for either AES 256, where Amazon manages the keys, or AWS KMS, Key Management Service, where we can configure a key and select it to our choosing from here. So if we need to manage the key ourselves for regulatory or legal compliance of some kind. However, I don't want to change anything here. Let's just cancel all the way back out, and let's enable the default encryption through PowerShell. Now what that's going to mean is any new content placed into that S3 bucket will be automatically encrypted. To do this, we're going to use the set-s3 bucket encryption PowerShell commandlet. We're going to use the -bucket name parameter. Of course, we have to give it the name of the bucket, in this case, bucket YHZ. Then I'm going to use -server-side encryption conf configuration. So I'll spell out the word _ server-side encryption rule. That's a long parameter name. Then I'm going to have an @ symbol and then an open as well as an outer closing curly bracket. Now, after the first opening one, we're going to put in server-side encryption by default equals. Then we're going to have an @ symbol, another opening curly bracket, server-side encryption algorithm equals, and in quotes, AES 256. Then we're going to close that curly brace. So you've got two opening curly braces at different points, and you need to match them with ending curly braces. Let's go ahead and press enter to enable that. Okay, let's go check our work. So back here, we're still looking at the same page. Let's just click on something else, like the Overview tab and then Properties again, just to refresh it. Okay, there it is. Default encryption is set now, indeed, at AES 256. Let's see if it works, meaning let's upload some new content. So I'm just going to go ahead and upload something to the root of this bucket. I'll click the Upload button. And let's go ahead and continue on through the wizard, just accepting all of the defaults. There's the file we just uploaded, logo.jpg. And so I'm going to click on the checkbox here to the left to select it, and let's look at the properties on the right, and sure enough, it's encrypted automatically with AES 256 because we enabled that bucket option using PowerShell. In Amazon Web Services, a virtual private cloud, or a VPC, is a network definition that you create in the cloud environment to accommodate resources that will run in that network. Now, you will automatically have default VPCs, one specifically for each AWS region. And the purpose of this is it facilitates launching resources like EC2 instances right away without having to create a VPC. But on a larger scale use of AWS, you're going to want to configure your own VPCs to suit your own network requirements. When you deploy a VPC, you can configure it with an IP version 4 CIDR block or an IP version 6 CIDR block. So IPv4 or IPv6 IP address ranges. Now you can also determine when you deploy a VPC if it is a dedicated or a default tenancy, where dedicated means that any EC2 instances that get launched into the VPC, those instances will run on dedicated hypervisor hardware. And of course, that's more expensive than a shared or default tenancy. So it's a virtual network within the AWS cloud. When you configure a VPC, there are a number of other items to consider, such as subnets. Every VPC contains one or more subnets, and the subnet IP address ranges have to fall within the VPC address ranges. The next consideration are DHCP options. Now, DHCP options include things like whether we want to use NetBIOS names. Now, if you are going to use things like NetBIOS names, then you'll want to specify in your DHCP options set a NetBIOS name server, or more than one. You can also configure a DNS domain name or custom DNS servers or an NTP, that's Network Time Protocol server for network time synchronization, that type of thing. You can also configure a network ACL. access control list, which is essentially firewall rules for a subnet to control inbound and outbound traffic flow. You can also configure a route table that contains routing entries if you want to control traffic flow, such as to a specific internet gateway to allow outbound communication, for example, to the internet, for EC2 instances deployed into a VPC subnet. You can also tag VPCs and all of these different configuration items so that you can perhaps track them by project for billing purposes. VPCs have two DNS options, one of which is DNS name resolution, which is enabled by default. This means that you'll be using Amazon-provided DNS servers. You'll be able to resolve names, for example, for internet sites. You can also enable DNS host names. This one is enabled by default. What this does is it allows you to reference EC2 instances by name on the network, so private IP addresses within the VPC. Instead of IP address, you can use the name to connect to it. And it also will create public DNS names that you can refer to for EC2 instances that have public visibility. Now, if you don't want to use the DNS name resolution provided by Amazon DNS servers, then you could specify your own custom DNS server IP addresses within a DHCP option set configuration. You can use the AWS Management Console to create and manage VPCs. To get started here, I'm going to go into the Find Services field and search for VPC, and I'll run the return result here, which will take me into the VPC Management Console, where on the dashboard on the right, I could click Launch VPC Wizard, where you have 4 options to facilitate the creation of the VPC and subnets and even variations on hardware VPN access. However, I'm just going to go back to the original VPC Management Console that we started from, and I'm going to click on Your VPCs over on the left. So any existing VPCs naturally will be shown. And remember that you get a default VPC within each AWS region. You don't have to use it, but you do have one by default. We're going to create an additional one here, so I'll click the Create VPC button, and I'm going to call it VPC2. Now, the next thing I have to do is specify an IPv4 CIDR block, where CIDR stands for Classless Interdomain Routing. It's the kind of thing where you're going to have a network address that would look something like this. 13, let's say, .0.0.0/16. That's CIDR notation, where the /16 tells us we have 16 bits in the subnet mask starting from the left. Now, because there's 8 bits in each byte, that means in this case, the network address is really 13.0. Now, bear in mind, any subnets created within the VPC have to use an IP address range that falls within the VPC address range. We could also use an Amazon-provided IPv6 CIDR block, but I'm not going to turn that option on. I'm going to leave the tenancy to default. I could choose dedicated, which means that any EC2 instances that get deployed into this VPC will use dedicated hardware, which is more costly. So I'm going to leave it on default. That's all I need for my computing purposes. And then I'm going to click the Create button in the bottom right. So it says that the VPC was created. We've got a link to it. I'm just going to click the Close button. And indeed, we now see VPC2 is listed as being available. We can also see the IPv4 CIDR block that was assigned to it, and also notice that the VPC was automatically assigned a VPC ID by Amazon. Now, that is going to be required sometimes when you manage VPCs from the command line tool, such as the CLI, or if you're working using PowerShell commandlets. Now, when I select that VPC, down below, I can see under the description some details related to that virtual private cloud. Notice it's got a network ACL it's associated with. Now, if I click on that, we can see the ACL, which consists of inbound and outbound rules to control traffic to the subnets that will be created within this VPC. Notice that, for example, for outbound rules, all traffic is allowed, and for inbound rules, all traffic is also allowed. Of course, that could be changed. Now, I'm just going to close that out by clicking back on Your VPCs on the left, and I'll select VPC2 once again. We've also got a DHCP options set that is associated with this VPC. There it is. And we can see some of the details down below, such as the domain name that will be used, and the name servers is set to Amazon provided DNS as opposed to your own custom DNS servers. If you really wanted to do that, you could just create your own DHCP option set by clicking the button at the top and configure it accordingly, such as specifying your own domain servers or your own NTP timesync servers, NetBIOS name servers, and so on. But I don't want to do that. I'm just examining what the result of creating a new VPC is. Let's go back to VPC2. We can also see a route table is associated with the VPC to control network traffic flow. Let's click on that link. So now we're looking at our route table, and down below, if I click routes, we'll see any routing table entries. All we see here is an entry for our local private network address for our CIDR range. Of course, we could click edit routes, and we could add new routing table entries, maybe to make sure that traffic gets sent to an internet gateway or gets forwarded to some kind of packet inspection appliance for security purposes, and so on. But I'm not going to do that. Let's go back to the VPCs, and I'll select VPC2 yet again. So now that we've got that, we can see the tenancy over on the right here for EC2 instances that are launched into the VPC is listed as default. Now let's get to work with this, meaning let's get at least a subnet within that VPC. So I'm going to click on the subnets view on the left. Here I can see I've already got 2 subnets within VPC1. We don't have any for VPC2. So in the subnets view, I'll click the create subnet button. So I'm going to name this new subnet VPC2_subnet1, assuming that's the nomenclature that I'm using for consistency within my organization. Now I have to associate this new subnet with the VPC, so I do that next in the drop-down list. I'm going to choose VPC2, so I see the VPC ID as well as the name. I can determine if I want this within a specific availability zone. Sure, let's say I want it in US East 1A. Down below, I can see the VPC CIDR range, so I need to specify an IPv4 CIDR block for this subnet that falls within that range. So I'm going to specify 13.0.1.0 and /24, 24-bit subnet mask, which in this case means the network address for this subnet is 13.0.1. So that falls within the network of 13.0, 16-bit mask here, for the VPC. So I'm going to go ahead and click Create. And then I'll click Close, and we now see that we've got a new subnet here. It's called VPC2_subnet1. And if I select that, down below we can see some details like the VPC affiliation, the number of available IPv4 addresses. A couple of addresses are used automatically internally by Amazon Web Services, if you're wondering why that isn't a higher number like 254. We can see the Network ACL association. Notice here that auto-assigning public IPv4 addresses is set to no. When you select a subnet, which I've done here already, you can go to the Actions menu and you can make a few changes. For example, you might want to modify the auto-assign IP address settings and enable public IP address assignment for EC2 instances that you might launch into the subnet. We also have the route table affiliation here, network ACL. Of course, we could also specify additional tags here, maybe for tracking costs associated with certain projects, departments, and so on. You can use the AWS CLI to create and to manage VPCs. Here I'm going to use the AWS EC2 create-VPC syntax to create a virtual private cloud. Now, when you do this in the CLI, you need to specify with the --CIDR-block parameter the IP range that will be used by the VPC. Ultimately, subnets in this VPC have to fall within this range. So the range I'm specifying in this example is 12.0.0.0/16. /16 denotes the number of bits in the subnet mask. So in other words, 12.0, the first 2 bytes or octets, define the network address. Let's go ahead and press Enter. Now, if this succeeds, which we can see it has, we'll get some returned JSON output. Right away, I'm going to copy the VPC ID only because I know I'm going to want to manage this VPC. First of all, I want to tag it and give it a meaningful name. So to do that, I'm going to clear the screen and I'm going to use the AWS EC2 create-tag syntax. Now I have to specify the resource that I want to apply tags to. So I'll use -- resources, and this is where I've placed the VPC ID that was generated from our previous command when we created the VPC. Then I'll use -- tags, where I will set the key equal to name, comma, and the value of that key to equal VPC3. So I'm going to go ahead and press enter to do that. Now, the next thing I'm going to do is create a subnet within the VPC. And remember that the subnet CIDR range, or the address range, has to fall within the VPC range. So I'm going to use the AWS EC2 create -subnet syntax. And the first thing I have to do is tie the subnet to a VPC. And I do that with the --VPC-ID parameter. So I'll just make sure I have the correct VPC ID, which I do. It's the same here as above. And then I'll use the --CIDR-block parameter. And in this case, I'm going to specify a CIDR block of 12.0.1. Now, the 1 is where we have a difference between the VPC CIDR range and this subnet. So .1.0/24. There's a second difference. We have a 24-bit subnet mask in this subnet, where at the VPC it was 16-bit. And so that means that we have 12.0.1 serving as the network address for the subnet. So I'm going to go ahead and press enter, and we have some return JSON output, which is good news as it relates to the creation of that subnet. Now I'm going to take note of the newly generated subnet ID here, because the next thing I'm going to do is clear the screen, and I'm going to use the AWS EC2 modify -subnet -attribute syntax. I want to make sure EC2 instances launched into this subnet automatically have an associated public IP address. So I'm then going to use --subnet-ID. Here I've placed the ID of my newly created subnet, and I'm going to use --map-public-IP-on-launch. Now, what I'm doing here is making sure that there will be the automatic assignment of public IPs for EC2 instances launched into this subnet, which is being identified here via the subnet ID. So I'm going to go ahead and press enter. Finally, the last thing I want to do is tag the subnet and give it a meaningful name. So AWS EC2 create -tags -resources, and here's the ID of the subnet in question. Then I'll use the --tags parameter. I'll set the key equal to name, comma, and the value will be VPC3_subnet2. That is the name that I am assigning to it. Then we're going to check our work in the console. Here in the VPC console, we can see the newly created VPC3 listed here with a CIDR range of 12.0.0.0/16. If we were to take a look at subnets, we'll see we've got VPC3_subnet2. And if I actually select that subnet down below, we can see, in fact, that it is associated with VPC3. And we can see up here the IPv4 CIDR address range for the subnet with the 24-bit subnet mask. In this demonstration, I'll be using PowerShell to create a VPC. To start with, I'm going to use the new -EC2 VPC commandlet, and I'm going to use the -CIDR block parameter to specify the IP address range for this new VPC. In this case, it's going to be 13.0.0.0/16. We have a 16-bit subnet mask. In other words, the 13.0 portion of this is the network address. I'm going to go ahead and press enter. We get some returned information, which is great. It means that the VPC has been created. Now, the thing I'm going to take note of here is the VPC ID, because I'm going to want to modify that VPC. I'm going to want to tag it. And when you want to modify an existing item, you can do so by referencing its ID. So I'm going to go ahead and copy that VPC ID. So I'm going to use the new -EC2 tag PowerShell commandlet. I'm going to use the -resource ID parameter, and we can see here I've got the ID of the newly created VPC that we've just created up here in our previous command. I'm going to use -tag, then I'm going to use an @ symbol with an open and closing matching curly brace, and within that, I've got key equals name, semicolon, value equals VPC4. Let's go ahead and press enter. So we just tagged that VPC, and now it's named VPC4. Now, the next thing I want to do is I'm going to create a subnet that falls within the VPC address range. To do that, I'm going to use the new -ec2 subnet PowerShell commandlet. I'm going to have to specify -VPC ID. Here is the VPC that we want to create this subnet within, and I'm going to use -cider block, and here I'm going to use 13.0.1.0. The 1 is different. And also the 24-bit subnet mask is different because at the VPC level, we had 13.0.0.0/16. So this does therefore fall within the VPC IP address range. So now we've got that subnet created. Now I'm going to take note here of the subnet ID because much like we tagged the VPC, I also want to tag and give a meaningful name to the newly created subnet. So to do that, I'll use the new -ec2 tag commandlet once again. -resource ID in this case is the subnet ID that we just created up above. And then I'll use the same old -tag with an @ symbol, open curly brace, matching closing curly brace, key equals name, semicolon, value equals, and I'm calling this subnet VPC4_subnet1. So at this point, we've created both a VPC and a subnet and also tagged both of those items. Let's just check our work for fun in the console. So indeed, I can see when I'm looking at the VPC's view in the VPC Management Console that we've got VPC4. It's using the 13.0.0.0/16 CIDR range. And if I were to look at subnets, we'll also see the existence of VPC4_subnet1. If we select it, we can see it's associated with VPC4, and we can also see the IPv4 CIDR range listed down here at the bottom under the description tab. And of course, you can see it in the IPv4 CIDR column up above. A DHCP option set is a configuration that gets associated with a VPC. So here in the VPC Management Console, if I were to select an existing VPC, down below under the description tab, we can see that there is a link, a hyperlink here for the DHCP option set associated with this particular VPC. And if I click on it, it switches me over to the DHCP options sets view, where it is filtered up at the top for the ID of the DHCP option set that we selected. So having a DHCP option set selected, we can see down below some of the settings, such as a DNS domain name here that's been set, and the domain name servers here being set to use Amazon provided DNS as opposed to custom DNS servers. But what we're going to do here is create a new DHCP option set. So I'm going to click the Create DHCP option set button up at the top, and I'm going to call this DHCP Eastern. So this is going to be for the Eastern region. Now here I can specify a DNS domain name. So this might reflect, for example, fakeco.com. This might reflect something that we want to use as a DNS suffix for EC2 instances deployed into the VPC. We can also specify IP addresses for DNS or domain name servers as opposed to using Amazon provided DNS. Now, why would you do this? You might do this if, for example, you wanted to have your custom manual configuration of something like Microsoft Active Directory, which relies on DNS, to locate domain controllers. If you hover over the information icon, it says you can have up to 4 DNS servers. These would be IP addresses. Make sure you separate them with commas. Okay, so if I have one, then I could specify it. And I'm going to go ahead and put one IP address here for a custom DNS server. If you want to use the network time protocol to synchronize time over the network between devices, you could use NTP servers and specify their IP addresses. Same thing if you're using the older NetBIOS name server to resolve names to IPs. You could specify NetBIOS name server identities and also the NetBIOS node type. The node type is a numeric value, for example, to a peer-based configuration that is used to resolve NetBIOS names to IP address through mechanisms such as broadcasting on the local area network or using a WINS NetBIOS name resolution server. And finally, down at the bottom, we can see here the AWS command line interface command that is generated based on our configuration, should we want to put that in a script or reuse it for a variety of different platforms like Linux, Unix, OS X, or Windows. So at this point, I'm happy with what I've changed in this DHCP option set. So I'm going to go down to the bottom right and click the Create DHCP Option Set button, and it says it succeeded. So I'm going to close out of there. Now I'm going to make sure that I'm not filtering this list any longer. So we can see here our DHCP option set up at the top. It's called DHCP Eastern. And what we can now do is associate that with VPCs so they will pick up the settings from that configuration. So to do that, we would head back over to the VPCs view, select the VPC in question, go to Actions, Edit DHCP Options Set, and from the drop-down list, select the appropriate item. I'm going to choose here DHCP Eastern, and I will click Save, and it's done. So now having VPC4 selected, if we look down at the bottom under Description, we will see quite clearly that the DHCP Options Set is now referencing DHCP Eastern. DNS name resolution is important because it allows for an easy way for devices to communicate over a network using a DNS name, as opposed to the more difficult to remember IP address. Let's start here by going to the EC2 Management Console here in the Amazon Web Services environment. I'm going to take a look at my list of instances. I've got one here running Windows Server 2019. It's currently running. Down below, having that EC2 instance selected, under the Description tab, we can see it's associated with VPC2. I'm going to go ahead and click the link for that. That opens up a new tab. It's filtered the list of VPCs for VPC2, which is selected. And notice from the Actions menu, we've got the option to edit DNS resolution and the option to edit DNS host names. Let's start with Edit DNS Resolution. When you create a VPC, by default, DNS resolution by Amazon provided DNS service is automatically enabled, as evidenced here by the checkmark. Now you can remove the checkmark if you want to not use Amazon provided DNS servers, but that means that you won't have any name resolution. So you would have to configure DNS otherwise. So for example, I'm just going to cancel out of that. What I could do is go to the DHCP option set view, click Create DHCP Option Set, where here I could specify one or more DNS server IP addresses. But if I were to go back, let's say, to our VPCs view, and once again, I'm going to select, let's say, VPC2, I'll go to Actions, and I'll choose Edit DNS Host Names. Now, this is normally enabled by default when you create a new VPC. Its purpose is to automatically assign a DNS host name to EC2 instances deployed in this VPC. Now, if your instance has a private and a public IP address, then you get two DNS names, one private one and one public one. If we were to go back to our instances here, we've got our WinServe 2019-1 running within VPC2, and notice that there's no public DNS name. Well, that corresponds to the fact that for VPC2, DNS host names is not enabled. If we were to enable that and save the change, it says DNS host names updated. And if we go back and let's say refresh our list of items here in the instances view, notice that we now have a public DNS name. So we also have a private DNS name listed over here on the left. So we can use these names to communicate with this instance instead of the more difficult to remember private, or in this case, also public IP addresses. Elastic IP addresses, or EIPs, are independent AWS resources that allow you to have a separate item that has an IP address that you can then associate to an EC2 instance. To get started here in the AWS Management Console, I'm going to switch over to the VPC Management Console, where in the left-hand navigator, I'm going to scroll down to Elastic IPs, and I'm going to choose Allocate New Address. Now the scope is for a VPC, and I'm going to leave it on Amazon Pool. So we get an IP address from the Amazon Pool of available IPs. Otherwise, I could choose Owned by Me, in which case we will have had to have already configured what's called a custom pool. So I'll leave it on Amazon Pool, and I will click Allocate. And we can see the Elastic public IP address listed here. I'm going to go ahead and click Close, and we now see the Elastic IP listed. Now, having that selected, we can then go to the Actions menu and associate it with an EC2 instance. Now, specifically, we have to choose either an instance or a network interface. So So I'm going to choose Instance, which is the default selection. And from the Instance drop-down list, maybe I'll choose my Amazon Linux instance, which currently is running. And I can then choose the appropriate private IP. So I'm going to select private IP address, and I'm going to click Associate. And it says it succeeded. So let's go take a look at this. If I close out, we can see here our Elastic IP starts with 34.197. So I wonder what it would look like if we went to look at the EC2 instances. So if we go look at our instances view, we're going to see Amazon Linux. There it is, Amazon Linux 1. And notice the IPv4 public IP is listed as being the one that starts with 34.197. So we have successfully created an Elastic IP address and associated it with an instance so that it has a public IP. One of the many options you can specify when launching a new EC2 instance is whether or not it has a public IP address. Let's take a look at that. I'm going to go to the Instances view here in the EC2 Management Console, and I'll click Launch an Instance. We're really going to launch one. We're just going to look at some of the options here. So I'm going to go ahead and select any AMI that's shown. I'll click Next in the bottom right, so we get to step 3 quickly. Configure Instance Details. Now down below, we can select a VPC and a specific subnet. For example, here I'll choose VPC1_subnet1. And down below that, we can see the auto-assign public IP. Here it's set to use the subnet setting, which is set to enable. So this is a subnet option. Now, we could, of course, override that when launching an instance by choosing enable or disable, but the default is to use the subnet setting from the subnet selected up above. Let's go take a look at that subnet. So I'm going to return to the AWS Management Console. I'm going to search for VPC and press Enter. And I'm going to go to the subnets view on the left. I'm going to select the VPC subnet in question. And I'm going to go to the Actions menu and choose Modify Auto Assign IP Settings. We can see here it's turned on. The check mark is enabled to enable Auto Assign Public IPv4 Address. Let's turn that off. So I'm going to turn that setting off. Save the change to the subnet. Let's go back to the EC2 Management Console, and let's try to launch an instance in the same way again. So I'm going to go and select the first AMI, and I'll click Next in the bottom right. And notice here that the auto-assign public IP option now in step 3 simply says Use Subnet Setting. It doesn't even say Enable in parentheses anymore. Now again, we can override that when launching the instance by choosing Enable or Disable. Now you might wonder, should I or should I not assign a public IP address to my EC2 instances? Well, it's not a black or white type of answer, yes or no, all of the time. Rather, you should try to minimize the number of EC2 instances that are directly available from the internet because they have a public IP. You might want to make sure, for example, that they only have a private IP, which they will by default, and that they're only accessible perhaps after authenticating to a VPN or through a jump box in the cloud. VPC peering links VPCs directly together. Now you can do this between different AWS accounts or within one AWS account, even between AWS regions where each VPC might be in a different region. Now VPC peering is designed so that you have EC2 instances, for example, in either VPCs that communicate with each other as if they're on the same single network, even though they're not. So pictured in our diagram, we've got VPC1 to the left and VPC2 listed over to the right. Now with instances in VPCs 1 and 2, after VPC peering is enabled, then they'll communicate as if they were on the same network. Now what does that mean? Well, the subnet IP addressing between both VPC1 and VPC2 would be different. They're different subnets. However, any traffic that gets routed between the VPCs, such as when EC2 instances communicate, is routed privately through the Amazon backbone without traversing the internet. Now, inter-VPC traffic then is routed privately, but it's also not transitive. Now imagine that we added VPC3 to this diagram, and VPC2 and 3 are paired together. Well, if that were the case, it does not automatically mean that VPC1 and VPC3 are considered peered indirectly. That's not the case at all. So this means that we have VPC peering that is not transitive by nature. Now, the other thing to bear in mind is that you can also turn on DNS name resolution for peered VPCs so that you can communicate using DNS names. When you configure VPC peering, the first order of business is to create VPCs and subnets as usual. Next is to create a peering configuration between the two VPCs. Now, when you do that, it's a two-direction type of thing. You would do the same thing twice from the perspective of each of the two VPCs. And then you have to accept the peering request from the initiating VPC. Finally, the last thing you'll have to do is adjust the route tables for both VPCs so the traffic is routed accordingly. So in other words, what you're going to have to do is add the network range, the CIDR network range of the other VPC into the VPC route table, your VPC's route table. And when you do that, you will select the appropriate VPC peering ID in the target field. You can configure a subnet to determine whether or not a public IP address is automatically enabled for EC2 instances launched into that subnet. Let's take a look at the setting here in the console by pulling up the VPC Management Console, and I'll click on the subnets view on the left, and I'm going to select an existing subnet here, VPC4_subnet1. Now down below under the description tab, I can see that auto-assign public IPv4 is set to no. We can change that. So having the subnet selected, I can go to the Actions menu and I can choose Modify Auto-Assign IP Settings. When I do that, I can then check on the Enable Auto-Assign Public IPv4 Address. Then I can click Save. We can now see down below under the Description tab, it now reflects that change because it says yes, where before it said no. Let's go and launch an EC2 instance into that subnet. So I'm going to go to the EC2 Management Console. Maybe I'll go to Instances, and I'll click Launch Instance. I'm just going to go ahead and just choose any AMI, any instance type, just to get through the wizard to step 3, Configure Instance Details, where if I were to select, let's say VPC4, and there's VPC4 subnet 1, the auto-assign public IP address option here is set to use the subnet setting, which is now enabled because we are deploying this into a subnet where that option has been turned on. Now, you might want to consider this carefully because having a public IP address means your instance is directly reachable from the internet. So as an alternative, you might consider deploying a jump box connected to the internet that would have to be authenticated to before allowing access to instances with only private IP addresses. A virtual private network, or VPN, is used to connect securely over an untrusted network such as the internet to a target network elsewhere. So it's an encrypted point-to-point network tunnel. Now, in order to do this, you need to have a VPN appliance. Now, this can come in the form of either hardware or it could be software running on a host that allows VPN connectivity. You also need a public IP address. Now, this would only be true if you are linking your entire on-premises network, for example, to the AWS cloud through a site-to-site VPN. Now, you can also use a pre-shared key, PSK, or a PKI certificate for authentication between the two endpoints to establish the VPN tunnel. An AWS site-to-site VPN is normally used to link your on-premises network to the AWS cloud through an encrypted tunnel. Now, in order to do this, we need to configure an on-premises customer gateway. This is a configuration we create within AWS. We then have an encrypted IPsec VPN tunnel linking the on-premises customer gateway to our AWS virtual private gateway, which is also another item that needs to be created in the AWS cloud. Now, your on-premises customer gateway represents your on-premises VPN appliance, be it hardware or software. If it happens to be behind a NAT router configuration, then you'll need to specify the public IP of the NAT router that allows connectivity to your on-premises VPN appliance. We can also create or configure an AWS client VPN. This means that we've got VPN client devices that make a connection over an encrypted TLS VPN tunnel, normally over port 443 to AWS. Now this happens by configuring an AWS client VPN endpoint. So if you've got traveling users that require a secured connection to AWS resources, an AWS client VPN is the solution to use. When you go to configure an AWS site-to-site VPN, the first thing you need to do is create the customer gateway, which represents the on-premises VPN device. You then need to create the AWS virtual gateway, which represents the Amazon Web Services VPN device. And then you create a VPN connection that links the gateways together. And when you're creating that connection, you can accept defaults where things like the pre-shared key would be generated by Amazon, or you can specify your own. In AWS, you can configure a site-to-site VPN to link an on-premises network into the AWS cloud. Now, this type of VPN is an IPsec VPN that uses IP protocol type 50 and also UDP port 500 or IKE. So to get started with this, I need to create three things, essentially. I need to create a customer gateway, which represents the on-premises VPN termination point, and I need to create a virtual private gateway, which is the Amazon VPN termination point, and I link them together by making a site-to-site VPN connection. So to get started here in the AWS Management Console, go to search for VPC to launch the VPC Management Console. And in the left-hand navigator, I'm going to scroll down under Virtual Private Network VPN, and let's start with the Customer Gateways. So I'm going to click Create Customer Gateway to begin this configuration. I'm going to call it Customer GW1 for Gateway 1. Now at this point, I can select either dynamic or static routing. If your specific VPN termination point device, whether it's hardware or it could be software as well, doesn't support the Border Gateway Protocol or BGP, then you'll have to leave it on routing of static, which I will do here. The next thing I need to do is specify the public IP address of the customer on-premises VPN termination point. Now that would also work even if it's behind a network address translation or NAT device. It just needs to be reachable. So here I'm using an OpenVPN server. So all I have to do when I go into the admin user interface under configuration is go to network settings, where I can see the IP address, the public IP address of that OpenVPN server. So I'm going to go ahead and copy that. And back here in the AWS Management Console, I'm going to paste that into the IP address field. I can then optionally select a certificate that was generated in AWS Certificate Manager or ACM. But I don't necessarily need that if we're going to use a pre-shared key to establish the tunnel on both ends of the VPN connection. So I'm going to go ahead and click Create Customer Gateway. And we can see it says that the Create Customer Gateway request has succeeded. I'm just going to click Close, and we can see that the customer gateway is listed as being available at this point. Now that is the customer gateway, but we have to configure a virtual private gateway, which represents the Amazon VPN termination point in the AWS cloud. So I'll go to Virtual Private Gateways, and I'll click the Create Virtual Private Gateway button. Call this Amazon VPN GW1, and the default autonomous system number, or ASN, is set to Amazon default ASN. Now what this means is it actually uses a value of 64,512. This number identifies networks on the internet that are making a connection in through this VPN endpoint. So I'm going to leave this as it is, and I'm going to click Create Virtual Private Gateway. I'll click Close, and we now see that we have our Amazon VPN gateway that's created, but notice the state is detached. So what we need to do then is attach it to a VPC. So having that virtual private gateway selected, I'm going to go to the Actions menu and choose Attach to VPC. And from the VPC list, I'll choose an existing VPC called VPC1, and I'll choose Yes, Attach. We can see the state is now that it is attaching. We can click Refresh until such point that it is successfully attached to VPC1. And after a moment, we'll see indeed that it is attached. Okay, so we've got a customer gateway created, a virtual private gateway. Now we have to link them together with the site-to-site VPN connection. So I'll click on that over on the left, and I'll click Create VPN Connection. I'm going to call this VPN Connection East 1. And this is not for transit gateway, it's for a virtual private gateway. So I have to select that from the list. We only have one. There it is. I'll choose it. Then we have to also specify the customer gateway, whether it's existing or new. Well, it's existing. That's the first thing we created in this demo. So I'm going to choose the customer gateway from the list. Then down below, we can specify the routing option. Again, dynamic requires BGP, the Border Gateway Protocol. I'm just going to select static. Now, when I do that, I can specify the static IP address prefixes that I want to use. But if your VPN appliance on-premises supports Border Gateway Protocol, then you should allow it to propagate routes dynamically. So I'm going to go ahead and leave it on dynamic then. Then I have my tunnel options. For redundancy purposes, there are two tunnels. That's why you'll see references here to Tunnel 1 as well as Tunnel 2. So there's two tunnels available for a single site-to-site VPN link. Now you can specify the CIDR IP address range for Tunnel 1 and Tunnel 2. Now if you hover over the information icon, it gives you some suggestions as to what allowable values are for that item. We can also specify the pre-shared key for Tunnel 1 and Tunnel 2, or let it all be generated by Amazon, which I'm going to do. Now there are advanced tunnel options. Again, it's set to use default options, which is usually okay. But if we were to edit some of those options, we get to choose encryption algorithms that would be used, and also integrity, signing algorithms that would be used, and so on. I'm going to use the default options, and I'm going to choose Create VPN Connection, and then I'll choose Close. Now we can see our VPN connection is now listed here in the site-to-site VPN connections view with a state of pending. Now it's going to be that way until the tunnel is established, once traffic starts getting sent through the tunnel. With the site-to-site VPN connection, bear in mind that clients on each side of the VPN tunnel don't need to have a VPN client. Instead, they just route traffic through their local VPN endpoint when it's destined for an IP address range on the other side of the VPN tunnel. Now, having that site-to-site VPN connection selected, down below we can click the Tunnel Details tab, and we can see both of the tunnels. So for redundancy, we can see the outside IP addresses, one for the customer VPN appliance and one for the Amazon VPN appliance, and also the inside IP CIDR range that was assigned automatically. We let it be generated by Amazon. Currently, the status of the tunnels is down, again, until the tunnel is established and traffic starts flowing through. Now, of course, the on-premises VPN appliance public IP address must be reachable. That device must be up and running. But we're not quite finished yet, and the reason that we're not quite finished is because we have to download the configuration using the button with the same name above so that we can configure our on-premises VPN appliance with this VPN detail. So when I click Download Configuration, I can choose the vendor of the VPN appliance for the customer gateway on premises. So whether it's Barracuda, Checkpoint, Fortinet, Juniper, Palo Alto, SonicWall, Yamaha, all these variations. We have a lot of them. Or we could just choose generic if ours is not there. Same with the platform and the software version. And we can download a file with the configuration items for the inside IP CIDR ranges for Tunnel 1, Tunnel 2, and the pre-shared key. Remember, VPN appliance on premises, your customer gateway currently will never establish the VPN tunnel because it doesn't even know what the pre-shared key is yet. We could have specified it, but in our specific configuration, we let it be generated by Amazon, and that's one of the things that we'll see inside this downloaded file. So let's go ahead and download this file. And once that file's downloaded, I'm just going to click to open it up. It's just a text file. My computer is set to open text files in WordPad. So we can see we've got an Amazon Web Services VPN connection configuration. So we can see the VPN connection ID, our virtual private gateway identifier, and our customer gateway identifier. That's the configuration on the AWS side, but then we have IPsec tunnel number 1 details. And as we go further down, we can also see the pre-shared key value. Now, that's going to be important. You can see details like the encryption algorithm. Now remember, we could have selected a lot of these items if we went into the advanced configuration. We looked at it, but we didn't change any of the values for each of the 2 tunnels. And here's the IPsec configuration for tunnel number 2. So we can see the protocol, ESP encapsulating security payload. That's for IPsec. Got a lot of the details. As we go all the way down through, we've got all of the information needed to configure everything for our VPN customer gateway, which is the on-premises VPN appliance. While site-to-site VPNs work well when you need to connect an entire network, for example, a bunch of devices on an on-prem network, into an AWS Cloud VPC. However, there are times when you're going to need single instance type of VPN connectivity, such as for users working at home or employees that are traveling for work that need a secured link over the internet, that's the VPN tunnel, to connect securely into AWS. So let's configure a client VPN endpoint. Now, before we do this, one of the dependencies is to have a server certificate that will be used by the VPN endpoint in Amazon. So to check that out here in the console, I'm going to search for ACM, that's the AWS Certificate Manager. Now, when we open up that console, we can see that we've got a certificate that I've named VPN Certificate that has been issued by Amazon. So this is going to be important as it's required to set up the client VPN endpoint. So let's go back to the main management console screen. I'm going to search for VPC and fire up that console, because on the left, as we scroll down under Virtual Private Network VPN, that's where we'll see client VPN endpoints. I'm going to create one by clicking the Create Client VPN Endpoint button on the right. For the name, I'm going to call it Client VPN East 1. For the client IPv4 CIDR range, we're talking about an IP address range or a pool that will be used to allocate IPs to connected VPN clients. So I'm going to use 10.0.0.0/16, let's say. Now, here's where I have to select the server certificate. That's what we checked out first. So here it is listed here. I'm going to go ahead and select it. Now, that is a requirement. That is not optional. But down below under authentication options, you could opt to use mutual authentication. This means that aside from a server certificate tied to the Amazon VPN endpoint, you could also choose a client certificate that would have to be installed on each connecting client device. However, the other option for client authentication is Active Directory. I've already got a simple AD or simple Active Directory instance configured in AWS, and I can select it from the list. This is an Active Directory instance where you would have to have created user accounts and passwords. They would use those credentials to authenticate to the VPN. Down below, I don't want to log the details of client connections, but if, for example, for regulatory compliance I need to, I could turn on yes and configure the CloudWatch logs log group name and the log stream name. I'm going to choose no. Now, if I don't specify DNS server IP addresses here, then the current DNS servers used by connecting VPN clients will remain in use. Now, if you specifically or exclusively only want name resolution for your AWS environment as per your AWS DNS configuration, you could do that. So I'm going to leave those empty. The transport protocol can either be TCP/UDP for port 443, so essentially an SSL or TLS-based type of VPN connection. And I'm going to enable split tunnel. By doing this, what happens is any client traffic that's destined for an address range on the Amazon Web Services side will go through the VPN tunnel. But any traffic that is not will instead go through the client's current internet connection, such as if the client is simply connecting to a standard internet website, not an AWS one, then that'll just go through their regular connection as opposed to through the VPN connection that we're configuring here. So I'm going to scroll down and click the Create Client VPN Endpoint button in the bottom right. And after a moment, it says it was successfully created. So I'm going to go ahead and click Close. And here we can see it in the view. Now, the state of this connection is currently listed as pending. What we need to do now, having that client VPN configuration selected, is go down under associations. We don't have any VPN targets. You need at least one. So I'm going to click Associate. I'm going to choose a VPC and a subnet here that I want to associate, and I'll click Associate. Okay, that was successful, so I'll click the Close button. Notice currently the state of that connection is that it's in the midst of setting up the association. So I can click the Refresh button to track that progress. And after a few minutes of refreshing, you'll see that the state is associated for the client VPN endpoint to that VPC subnet, and the overall state of the client VPN endpoint now says available. The next thing that we need to do is add authorization rules. So I'm going to go to authorization down below and click authorize ingress. So I know this is the CIDR IP address range of the subnet that I want users to have access to. This is a subnet in AWS within a VPC. I can allow access to all users or a specific Active Directory group. I'm going to leave access for all users that successfully can authenticate to the VPN, and I'm going to click Add Authorization Rule. Then I'll click Close. So now we've got an authorization rule that's been added. Currently, the state is showing as authorizing, so I can keep clicking the Refresh button to monitor the progress of that configuration. And before you know it, after refreshing, you'll see the state for the authorization rule is now listed as being active. I've gone to the OpenVPN Connect website to download the OpenVPN Connect client, which is free for Windows. So I've downloaded and installed the software. Back here in the client VPC config, we need to have that endpoint selected, and we need to have downloaded the client configuration file, which I've done. Then when you fire up the OpenVPN Connect client, you can select from URL or file to bring in that downloaded config file for the AWS client VPN endpoint. We can drag and drop the file here, or click the Browse button to the file that was downloaded for the VPN client configuration. Once we do that, it automatically populates a lot of these items. Of course, we're going to have to specify our username information here, in this case, for simple Active Directory in AWS. Now, after you've clicked the Add button in the upper right, you'll see the OpenVPN profile listed here. We can click on it at any time, at which point it'll prompt us for the Active Directory password for the username that we specified. And after you do that, you'll see that it starts making the connection to the AWS client VPN endpoint. In this demonstration, we're going to examine a route table configuration in AWS to get a sense of route table propagation. Now, route table propagation is important for routing to work properly, such as across site-to-site VPN connections, so that clients on one side of the tunnel know that if they want to send traffic to a specific destination network, that it's to be routed through their local VPN endpoint. So to get started here in the AWS Management Console, I'm going to search out VPC, click on it to open up the VPC Management Console. The reason I'm doing this is because I want to start by going to my list of existing VPCs, of which I have one. It's called VPC 1. Now, the next thing I want to do, having that VPC selected, down below under the description tab, I can see the route table link, and I want to click on that link. So now we've got the route table that's associated with that VPC selected. And having that route table object selected down below, we can see it's associated with a couple of subnets within VPC 1. However, if I click on the Route Propagation tab, we can see that we've got an entry here for Amazon VPN GW1. That's an Amazon Virtual Private Gateway, which represents the Amazon side of a VPN device in the AWS cloud. If I were to click Edit Route Propagation, we can turn on the Propagate option. Now, this is essentially dynamic routing, and it's used if the customer on-premises VPN appliance supports the Border Gateway Protocol, or BGP, as opposed to configuring static routes manually. I'm going to go ahead and click Save, and at this point, we can see that route propagation for our VPN gateway configuration in AWS is now enabled. Communicating over the internet is not the only way to make a connection to the AWS cloud. Another option is to use AWS Direct Connect. This is a dedicated private network circuit. That means that we have our own type of communication link that does not traverse the internet. It links our on-premises network directly to an AWS VPC. Now, by not traversing the internet, this means that we've got a dedicated or private network link, otherwise called a network circuit, as we've seen above. Now, when you configure an AWS Direct Connect circuit, you can specify between 1 and 10 gigabit per second types of connections. Now, with AWS Direct Connect, because we have our own private network link, it's predictable bandwidth as opposed to the internet, which is shared by many users. With AWS Direct Connect, your on-premises network needs to have a router configured to make the link directly to an AWS VPC. It's an OSI layer 2 point-to-point type of connection. Now, configuring AWS Direct Connect means configuring virtual interfaces. Now, with the virtual interface, you could make a connection to multiple items, both public and private, in AWS. So you could split one circuit, let's say, into multiple virtual interfaces, or you can have an interface that might connect to a private AWS resource in a VPC, and also another interface for that circuit that connects to public AWS resources like public-facing web applications. So when you provision an AWS Direct Connect link, the first thing you have to do is submit the Direct Connect request. And you can do this, for instance, using the AWS Management Console. Now, within 72 hours, you will get a response from Amazon Web Service. This is a letter of authorization that will be sent to your email account, the one that's linked with your AWS ID, your root account. The next thing that happens is you need to provide the information that you get from AWS about your on-premises router to the co-location provider. Now, this is something that you specify when you configure Direct Connect. You have to select an area or a region where a co-location provider exists that supports Direct Connect. Finally, the last order of business would be to configure your on-premises router to make the link through the co-location provider directly to an Amazon Web Services VPC. Now, in order to know how to configure your on-premises router, when you set up Direct Connect, you will specify the manufacturer, the model, and the version of the software running on your on-premises router, and then you can download a router configuration file to configure the virtual interface on your router. Then, of course, you would test connectivity to AWS resources, whether they be private or public, through Direct Connect to ensure that the network link is active. In this demonstration, I'm going to use the AWS Management Console to provision a new AWS Direct Connect circuit. So to get started here in the console, I'm going to search up the word Direct, and then I'll choose Direct Connect. So I'm going to click the Create a Connection button, as I've not already configured this. And I can either choose Classic or Connection Wizard. Connection Wizard is recommended, so I'm going to choose that option. And down below, I'm going to use the Development and Test Resiliency level, because that's all I'm doing is testing out this dedicated private circuit that doesn't traverse the internet to link my on-premises network with the AWS cloud. Now, in a production environment, if you want the best resiliency, so high availability, then you're going to choose maximum resiliency as opposed to high resiliency. But of course, there is a cost change with maximum resiliency compared to high resiliency. In this case, development and test will suit the requirement, so I'm going to go ahead and click Next. We don't need redundant circuit connections. From the bandwidth drop-down list, we can choose from up to 40 gigabits per second. In this case, I'll choose 10 gigabits per second. Now, what we're doing here is specifying a location where we want to have a connectivity point into the co-location provider, which in turn gives us a direct link into the AWS cloud. So for the location, we can choose from the drop-down list, or we can filter it out. For example, if I want to filter it out for Toronto, we could specify that as well. So I'm going to type in TOR And already we can see an entry here for Toronto, Canada in the CA Central 1 AWS region. Then we have to select the service provider in that location. For example, I'll choose Bell Canada. Now, if I go down under additional settings, I can specify some tagging info, which I will. I'll click add a tag, and I'm going to add the name here. It's going to be Canada Central Direct Connect. So that's the tag key and value I want to add, and I'm going to click Next. So at this point, we can see the connection summary. So we've got 2 connections that will be set here for Bell Canada in Toronto, and they're going to be 10 gigabits per second. So I'm going to go ahead and click Create. So even with this development and test, we still have a bit of protection or resiliency with our 2 connections. They're just going to the same provider, but we still have 2 links. I'm going to go ahead and click Create. We then get a message here that says we can download our Letter of Authorization and Connecting Facility Assignment, so the LOA CFA. Now that's once the connection has been approved, and then we need to provide that detailed information in the LOA CFA to our network provider. In this case, it's going to be Bell Canada in Toronto, and they're going to order a cross-connect configuration for us. So essentially, we will have a link into the Toronto location for Bell Canada. That's going to be a private link, a dedicated circuit link, and then from there, we have a direct link into AWS. I'm just going to go ahead and click Continue. We can see here that we've got our specific connections that are listed here. We can click on any one of them. And here, of course, we can see action is required, but we could see the general configuration and that the connection has been requested for our service provider, Bell Canada. We just haven't received anything about it yet. So until Bell Canada, in this particular case, completes the cross-connect configuration in their facility, we won't have an established dedicated link using Direct Connect. Now remember, at any time, we can go look at our connections. So I've got the connections view on the left, and I can see that the state is currently that it's set to be requested. Now, after we get our letter of authorization, we can then create a virtual interface, which is a link into our VPC. So I would click Virtual Interfaces over on the left. We don't have any currently, but we can click the Create Virtual Interface button, and we can choose from 3 different types: private or public, depending on if we want to access VPC items through the Direct Connect circuit using private versus public IP addresses. So let's say private. Or we could also use a transit virtual interface. So I'm going to leave it on private, and then we could fill in some of the details, such as filling in the virtual interface name. I'm going to call it Virtual NIC 1, and then we would choose the connection. Now, of course, we don't have a connection provisioned yet, so therefore we can't complete this phase of the configuration. But once you've configured the virtual network interface, then when the connection comes up, you're ready to go. You'll be able to access items, in this case, using private IP addresses in AWS through the Direct Connect circuit. In Amazon Web Services, you configure a NAT gateway to allow EC2 instances that have only private IP addresses to access the internet through the NAT gateway's public IP address. So to configure this, we're going to start by going to the VPC Management Console. So here in AWS Management Console, I'll search for VPC to do that. So we're now in the VPC Management Console. Next thing I'm going to do over on the left is scroll down until I see NAT gateways. Now currently we don't have any, so I'm going to click the Create NAT Gateway button. The first thing I need to do is associate this with the subnet. So I'm going to choose an existing subnet called Subnet1, which is in a VPC named VPC1. Now, I need to have an elastic IP address for the NAT gateway. It needs a public IP, whether we choose an existing one from the list or we choose Create New Elastic IP, New EIP, which I'm going to do here. So we can see it's showing us the new public IP address. Perfect. So I'm going to go ahead and click the Create a NAT Gateway button. And it happens pretty much immediately. But the next thing that I need to do is I need to edit route tables. Now, for subnets where we've got EC2 instances that have only private IPs that we want to allow access to the internet, we're going to have to make sure that those subnets have a routing table entry to go through NAT, the NAT gateway we just defined, when going out to the internet. So let's click the Edit Route Tables button to make that happen. So here we've got a route table selected in the Route Tables view. Down below, if I look at subnet associations, just to double check everything, indeed, it looks like it's associated with subnet 1 and 2 in VPC 1. So that's important. Now, the other thing I want to do here is actually click on the Routes tab, and I want to click the Edit Routes button. So I want to make sure that the default route, which for IPv4 is represented with 0.0.0.0/0. Now currently it's set to go through an internet gateway, which I'm going to select and press delete. And then from the drop-down list, I'm going to choose NAT gateway, and I'm going to choose the ID of the NAT gateway that we just defined. Then I'm going to click Save Routes. Then it says routes are successfully edited. Click Close, and indeed, we can see when we look down under the Routes tab for the selected route table that we've got the default route that is now set to go through our newly defined NAT gateway. So this will be applicable then for the associated subnets where we've got EC2 instances that have only private IP addresses. In Amazon Web Services, within a VPC, you can configure an internet gateway, and this allows connectivity to the internet. It also allows connectivity to EC2 instances with public IPs from the internet. So to get started here in the AWS Management Console, I'm going to search up VPC, and I'll click on that because that's going to open up the VPC Management Console. In the left-hand navigator, I'm going to click Internet Gateways, and notice that we don't have any yet. So I'm going to click the Create Internet Gateway button, and I'm going to call it Internet GW1. And then I'll click the Create button. It was successful, so I'll click Close, and we can see it listed here in the Internet Gateways view, but the state is showing as detached. Well, that's because we haven't yet linked it with a VPC. So I'm going to leave it selected in the view. I'll go to the Actions button, and I'm going to choose Attach to VPC. And from the list, I'm going to choose an existing VPC that I have. I can also expand the AWS command line interface or CLI equivalent command based on my selection above if I wanted to do this from the CLI on the Linux, Unix, or Mac OS X platform from a Windows command prompt, of course, and using PowerShell. So we can go and select that. However, I don't need to worry about that. We're doing it here in the GUI, so I'm going to click Attach. Now we can see the state of the Internet Gateway has changed to Attach. So the next thing that we have to do is make sure that subnets within our VPC, VPC1, have a route to use the Internet Gateway to get out to the Internet. And so to do that, we have to look at VPC1's routing table. I'm going to click the Your VPCs view on the left. There's VPC1, and down under the Description tab in the bottom right, there's the route table link. I'm going to go ahead and click on that. Click on the Routes button, and I'm going to edit the routes by clicking the Edit Routes button. And when you do that, you'll see any of the existing routes. Here I have one listed with the status of black hole. That usually happens when you had a route for an item that no longer exists. And so you can simply click the X to remove that and save the routing table. And I'll do that and click Close. However, I'm going to go back in and click the Edit Routes button, because what we want to do is add a route, a default route, for internet destined traffic to go through the Internet Gateway. So to do that, we click the Add Route button. The default IPv4 route is referenced as 0.0.0.0/0. Now, if I hit the backspace there, we can also use the IPv6 default route, which would be ::/0. However, here I'm going to specify 0.0.0.0/0 for IPv4. Now, what do we want to route through for the default route? Well, under the target drop-down list, I'm going to choose Internet Gateway, and here I'll choose the Internet Gateway that we just created. We see both the Amazon assigned ID as well as the name that we specified upon creation. Then I'll click Save Routes. It says the route was successfully edited. Perfect. I'm going to close out of that. We can see that the associated subnets are both subnets within VPC1, so any EC2 instances deployed into either of those subnets will know that the default route is set to go through the Internet Gateway, thus providing Internet access. An Amazon Web Services egress-only Internet Gateway, as the name implies, is for outbound Internet communications. Now, specifically, it's tied only to IPv6 addresses, so outbound IPv6 traffic to the Internet, much like you would do with IPv4 by configuring an AWS NAT gateway. It would allow outbound access to the Internet, EC2 instances only with private IPs, while preventing connections from being initiated from the Internet. And that's also true with an egress-only Internet gateway. It prevents Internet-initiated connections for IPv6, but it allows outbound connectivity from within EC2 instances running within your VPC subnets. So to get started here, in the AWS Management Console, I'm going to search up VPC, and then in the VPC Management Console, I've got the egress-only Internet Gateways option on the left, which I will click. And remember, this is only for IPv6 addresses, which are 4 times as long as IPv4 32-bit addresses. They're 128 bits long. So I'm going to start by clicking Create Egress-Only Internet Gateway. I'm going to tie this to an existing VPC that I'll choose from the list, and then I'll click Create. It says the egress-only Internet Gateway was created. Perfect. Remember, this allows only outbound IPv6 connectivity to the Internet. So now it's listed here. Now the next thing I'll do is click the link for the VPC because I want to look at the route table for the VPC. So the VPC selected down under the description tab, and in the bottom right, I'll click the route table. I will click, well, let's start by clicking subnet associations. We can see 2 subnets are associated with VPC1. Now I'm going to click the routes button to edit routes. And I want to add a new route. Basically, I want to add the default route for IPv6. Now above we see the default route for IPv4, 0.0.0.0/0. But for IPv6, it's referenced as ::/0. Next, we have to define what we want to send default IPv6 traffic through. And so from the drop-down list, I'm going to choose egress-only Internet Gateway, which is specifically for IPv6 outbound traffic, and I'll select it from the list, and then I'll click Save Routes and Close. And now it's done. So if we've got some instances configured with IPv6 in those subnets that need to make connectivity outbound using IPv6 to the Internet, they can do so through the egress-only Internet Gateway. In Amazon Web Services, VPC transit gateways are a crucial network component when you want to link together resources in multiple VPCs. Pictured in the diagram at the bottom, we've got 2 on-premises locations that can use either a VPN site-to-site link or a direct connect circuit that make a connection to the Amazon Web Services cloud. Now, specifically, they can make a link to the VPC Transit Gateway, which you can think of as being a hub for network communications. By linking VPCs, such as we see here, VPC1, VPC2, and VPC3, by linking those to the VPC Transit Gateway, each VPC has access to each other VPC. So in other words, instead of having to link VPC1 with 2 and then 3, and then doing that for each and every VPC, all you have to do when you introduce new VPCs is attach them to the VPC Transit Gateway to allow connectivity between all VPC resources, all the VPCs connected to the VPC Transit Gateway. So it kind of acts as a hub for network communication where the VPCs are the spokes. Now, to configure VPC Transit Gateways, you start by creating a VPC Transit Gateway in AWS. You can also then share that gateway with other AWS accounts. You attach VPCs to the gateway, and then you update subnet routing tables. Now, you need to attach items such as a site-to-site VPN connection to the Transit Gateway as well. Now, the updating of the subnet route tables is required because traffic that is targeted for other VPCs needs to have a target of the transit gateway that was attached. And then that way the traffic will be routed properly. So this is very useful if you need to segment workloads in the AWS cloud environment into separate VPCs, yet still maintain connectivity between VPCs. And when you're talking about a lot of VPCs, the transit gateway configuration option makes a lot of sense. Over time, you may find that you have numerous VPCs and VPN connections related to your AWS environment. And instead of interconnecting all of them specifically with one another, you can centralize that type of connectivity configuration and management using a transit gateway. So to get started here in the AWS Management Console, I'm going to search up VPC and then open up the VPC Management Console. Where on the left, I'm going to scroll down in the navigator until I see the Transit Gateways section. I'm going to click Transit Gateways, and we're going to build a new one. This serves as a centralized hub type of configuration to which we can attach VPNs and VPCs. So I'm going to click Create Transit Gateway, and I'm going to call it Transit GW1. I'm not going to modify the default Amazon side ASN. I can enable DNS support for name resolution for any VPCs that I attach to this transit gateway. We can also enable the ECMP support option, where ECMP is an option that stands for Equal Cost Multipath type of routing. So it's when we have multiple ways to send traffic to a single destination. I'm going to leave the default route table association item and route table propagation, and I can also enable multicast support. Now you would do this if you need to send multicast traffic among different subnets for any VPCs that are attached to the transit gateway. Multicast traffic is IP traffic that is destined not for everybody on a network, as in a broadcast, and not for an individual host, as in a unicast, but to a group of machines that are expecting a transmission. That's a multicast. I don't have that requirement, so I'm not going to turn on enable for that. I can also configure options so that we can share this for different AWS accounts. And I can also turn on auto accept for that. So we can enable auto accepting for shared attachments for transit gateways. I'm not going to do that. I'm just going to create this individual transit gateway in this AWS account. It says it succeeded, so I'll click close, and indeed, we can see our transit gateway is now listed with the state of pending. Now, there's nothing else you need to configure to get it to a state of available. Just hang tight for a few minutes and keep clicking the refresh icon until the state is available. The next thing to do is to configure transit gateway attachments. So I'm going to go ahead and click transit gateway attachments, and I'm going to click the Create Transit Gateway Attachment button. First thing I have to do is select the Transit Gateway ID. Now that's the one that we've just created, so I'll select that from the list. We have to determine if we're creating an attachment to this Transit Gateway or this centralized hub of connectivity from a VPC, from a VPN, or from a peering connection. I'm going to leave it on VPC. Now I have to give this attachment a name tag, so I'm going to do that. I'm going to call it VPC2 attachment. I have a second VPC called VPC2. I want to enable DNS support. I'm only using IPv4, so I don't have to enable IPv6 support. And as you can see, it's not enabled by default. So let's choose the VPC ID for the VPC that we want to attach to our transit gateway. In this case, it's one that I've already got created called VPC2. Down below, we can see that we have some subnets that are available, subnet IDs that we can select from that list. And then we can click Create Attachment, which I've done, and I can click Close. So we now have a VPC attachment for VPC2 to our transit gateway. So we can repeat the Create Transit Gateway Attachment process essentially to link multiple VPN connections and VPCs to this centralized hub, this transit gateway, to allow connectivity for resources on either side of the VPCs or the VPN connections added to the transit gateway. A VPC endpoint is used to allow a private connection from a VPC to specific AWS services. Now, this means that the traffic between the specified VPC and the AWS service, let's say it's an S3 bucket, doesn't leave the Amazon network. So it doesn't traverse the internet. So imagine, for example, you've got an EC2 instance in a private VPC that's got software that needs to talk to files in an S3 bucket. So we can achieve this using a VPC endpoint instead of configuring some kind of a gateway or NAT type of connection. So to get started here in the AWS Management Console, I'm going to go to the VPC Management Console, search up VPC, and in the left-hand navigator, under Virtual Private Cloud, I'm going to choose Endpoints. Any existing endpoints will be shown here. I'm going to choose Create Endpoint up at the top. Now we can make a link to AWS services. We could find the service by name or go to the AWS Marketplace and filter out the list. I'm going to leave it on AWS Services. And if I scroll down far enough, we can see it's all these standard AWS services like Athena, CloudFormation, CloudTrail. And as I go all the way down alphabetically, I'll come across S3. So I want to use an Amazon gateway type of endpoint as opposed to interface type for S3 to allow connectivity. Now then I have to specify the subnets that will be associated with the route table to access the endpoint. So here's a route table that's got two subnets associated with it. If I hover over that, I can see the subnet identities. So it's subnet 2 and subnet 1, which exist in VPC 1. So I'm going to select that route table, go to scroll down. Now I don't want to provide full access to S3. I want limited access. So I'm going to choose custom for the policy item, and I can click the policy creation tool to configure this. For example, the type of policy will be an S3 bucket policy. I want to allow any entity, although I could specify the names of those principals, but here I'm going to leave it on all. I want to allow access for all of them from within those VPC subnets to Amazon S3, and the actions I want to allow are only to retrieve information. So for example, maybe I'll choose the get object S3 bucket action. Now for the Amazon resource name or ARN, I could specify a specific S3 bucket, or I could put in an asterisk for all buckets. Then I'll click Add Statement. Then I'll click Generate Policy, and from here I'm just going to copy this because I now want to use this in the policy part of the configuration for my VPC endpoint. Then I'll click Create Endpoint. And we can see that the VPC endpoint was created. So I'm going to go ahead and click Close, where we can see our listed VPC endpoint. So now EC2 instances in VPC1 subnets will have the ability to read or get object for any S3 bucket that we've specified in that location. Amazon Route 53 is a managed DNS service. This means that you don't have to manually provision a server and configure the DNS software on it. Instead, you just configure the details for DNS name resolution, and the underlying infrastructure takes care of the rest for you. So it supports name resolution. Normally, this means that we have a friendly DNS name, a fully qualified domain name, or FQDN, that we need resolved to an IP address. Although there are times when you might want to do a reverse lookup where you already know the name, but you are querying for the IP address. So you can use Route 53 to resolve names for AWS services and basically anything else outside of AWS on the internet as well. You have the option of registering a DNS domain name if you don't already have one. You can do that directly to AWS. You can transfer a DNS domain name that you might already have registered with an external DNS registrar such as GoDaddy. You can also create public or private hosted zones. With a private hosted zone, you don't have to have anything configured ahead of time, where you can then create DNS record sets for name resolution. Now, Amazon Route 53 also supports DNS health checks. The purpose of this is to verify that an application is reachable when it's connected to by name through DNS, through Route 53. So endpoint connectivity is checked either over TCP, HTTP, or HTTPS. The purpose is that when a back-end endpoint is not reachable, then any DNS queries going through Route 53 that might resolve to that IP are not sent to it because it is an unhealthy endpoint. You can also control Amazon Route 53 traffic flow by creating different types of traffic policies. Now, Route 53 allows for global traffic routing because of AWS's globally based infrastructure at the network level. You can use latency-based type of routing. This means that based on a user request for content, latency-based routing will take a look at the AWS region where that content might be hosted that would provide the best performance. In other words, the least network latency. GeoDNS is based on geography. So in other words, the geographical location of the country or even the continent of the user that made the request. So it can mean that we can redirect people, for example, to a web app that has the appropriate language or settings in it for that part of the world. The other thing to consider is that we can also configure geo-proximity types of routing policies. Geo-proximity is a little bit different because what it does is it looks at the physical distance between a resource within an AWS region and the user to determine the quickest way to get to something. Then there's weighted round robin. Now, the idea with a weighted routing policy is to make sure that traffic gets routed to resources based on the settings we specify. So if I have a weight of 100 for one DNS record and 200 for another, so they're the same DNS record name that point to different IPs, the one with a weighted value of 200 gets twice as many requests sent to it than the one weighted with the value of 100. Amazon Route 53 supports DNS zone hosting. This means that the DNS zone and its associated record sets are stored within the Route 53 AWS infrastructure. To get started here, I'm going to search for Route 53 and select that to open that management console. If I look at the hosted zones view by clicking on it in the left-hand navigator, I'll see any existing hosted zones. Here we can see we've already got a hosted zone and its type is public. You could also have a private one where you can make up the domain name. Public hosted zones have to be mapped to a DNS domain name that you already own. If I click to open up an existing hosted zone, we also have the option of importing a zone file. Now, a zone file is a DNS formatted file you might have on an existing DNS server, such as on premises, and you can reuse that here in the cloud by exporting it from that system and importing it here. However, in this case, I'm going to go back to hosted zones and I'm going to create a new one by clicking the Create Hosted Zone button. Now, for the type, it's either public or it's private, where a private DNS zone hosted in Route 53 can be associated with an Amazon VPC, as we can see further down below. So we can click in the VPC ID list and we can select the appropriate VPC from here. So for example, I'm going to choose an existing VPC I've created called VPC4. I'm going to call this domain name quick24x7.local. That's the DNS suffix. And that's all I'm going to do. I'm going to click Create. So at this point, I've got a newly hosted DNS zone. And we can see that there are two default records here, the name server or NS record and the start of authority or SOA record. Now, to make this useful, we would normally create a record set. For example, I'm going to create a record set, let's say for www. Now, notice it's adding our .quick24x7.local DNS suffix at the end. And what we end up having is a fully qualified DNS domain name, an FQDN. Now, I want to build an A record here, which allows us to resolve an FQDN to an IPv4 address, or if you wanted to do an IPv6 address for resolution, it's a quad A record. If you wanted to configure mail exchange records for the transfer of email based on email domain name after the @ symbol, you could create an MX record, a CNAME record, which is an alias record that points, for example, to an A record. You might have a reverse lookup record, a pointer record, which means we already have the IP address we would like the name returned. You've got a service locator record. That's the type of record that Microsoft Active Directory uses to locate a domain controller. So to read group policy settings or to authenticate domain user account. So we have a number of different types of records that can be created for the record set. I'm going to choose an A record, and I'm going to fill in an IP address that would resolve after users connect to www.quick24x7.local. I want that to connect to 12.0.0.1, where presumably I've got a web application running. I'm going to leave the routing policy down below to simple, which simply means resolve the name to an IP and don't do anything fancy beyond that. I'll click Create. And at this point, we can now see we've got our A record for our FQDN that maps to the configured IPv4 address. So now if I go back to my hosted zones view, we'll now see we've got our Quick 24x7. Of course, notice it is a private as opposed to a public zone. And again, if I click on it to open it up, we can see a lot of the details available for it, such as the records that are listed. And if we back out to hosted zones once again and click on the radio button to the left of that zone, then we get some details on the right. So we can see, for instance, that this is associated with a particular VPC here, VPC4. That's where the name resolution for the records in that zone will be applicable. So any EC2 instance is launched into VPC4. And of course, we could change this by clicking the Associate New VPC button down in the bottom right. Route 53 supports a number of routing policies when you create a DNS record set. The overall purpose is to reduce the amount of time it takes for a client to connect to a resource. So that happens by providing access to an IP address that provides the least amount of network latency, and also by using DNS health checks to prevent the routing of client requests to back-end servers that are not healthy or unresponsive. Let's take a look at the different types of routing policies. The first of which is a simple routing policy. This is pretty basic. It means you've got one fully qualified domain name, or one FQDN, that maps to one IPv4 address, for example, through a DNS A record. If you're using IPv6, it would be a quad A record. Now, this is the only type of routing policy you'll configure that doesn't support back-end health checks. Next, we've got multi-value answer as a routing policy. Now, this is still one FQDN with multiple IP addresses. So we've got multiple IP addresses associated with it. However, DNS queries from clients will get returned a random IP address. You can't predict exactly which IP will be returned. Now, the purpose of this and the usefulness is that it provides availability and load balancing. If you want it to essentially bounce across different IPs where you've got multiple backend servers serving up the same app. The weighted routing policy allows you to configure a weight, which is a numeric value, when you create the record. And it controls how DNS results get returned to clients, specifically an IP address. So what happens is you've got one FQDN with multiple records. Each of those records you configure with a weight value, and that value is a numeric item that falls between 0 and 255. The purpose is to allow the controlling of how much traffic is received by specific backend hosts. So if you've got one name like www.quick24x7.local, so you might create two records, same name, but different IPs. If one of those records has a weighted value of 100 and the other has a value of 200, gets twice as many client requests sent to it. In other words, that is the IP that gets sent back to the client twice as often as the other record with a weighted value of only 100. Latency-based means that you've got an FQDN with multiple DNS records, and each of those records is configured to point to a specific AWS region. And the purpose here is that the lowest latency IP address, after resolving the FQDN, is what gets returned to the client. So it improves the performance or the client experience. A failover routing policy means that clients are only directed to backend healthy hosts. Remember that other than simple routing policies, these other ones all support backend health checks. So failover would be useful then if you've got a secondary site, for example, configured as a disaster recovery site. The primary site might currently be on premises, and due to economies of scale, it might be affordable to do it in AWS where the secondary site exists. Geolocation routing policies work out to be the same type of thing we've seen previously, where you've got an FQDN, multiple records, and clients get sent to the nearest geographical location based on the client DNS query location, so the country or continent that the client request comes from. All of these are used in the end to provide the best possible experience for the end user, either getting them as quickly as possible to the content that they're trying to connect to by name, and or also providing high availability for disaster recovery, and also providing load balancing services. In this demonstration, I'll use the AWS Management Console to configure a Route 53 multi-value answer policy. Let's start by going to the Route 53 Management Console. Now here, I'm going to go to Hosted Zone, so I already have one. It's a private one associated with a particular VPC, in this case VPC 4. And I'm going to click on the link for the name of it so we can see the records within that zone. So it looks like we've got the standard name server and start of authority records, plus there's an A record here as well. Now what we can do with multi-value answer policies is have a single name, as we can see here, such as www.quick24x7.local. We can have a single name configured with multiple IP addresses, and we can't predict exactly which IP address will be returned to clients that are querying based on that name. The benefit here is high availability and load balancing. So when you create a record, let's first delete the existing one that we have here, the A record. I'm going to select it. I'm going to choose Delete Record Set, confirm, and then we'll click Create Record Set. Now we're going to do www again. It's going to add the .quick24x7.local suffix. Together, that formulates the FQDN, the fully qualified domain name. And it's going to point to an IPv4 address, so the record type here in DNS is an A record. Specify one of the IPs, let's say 12.0.0.1. Now down below, the routing policy by default is set to simple. That's not what we want here. In this case, I want it to be a multi-value answer. Now we can also provide a little description for the set ID property of this, and we can also determine if we want to associate this specific record with a health check to determine if the backend host, in this case at 12.0.0.1, is responsive. I'm not going to do a health check. Now, if I were to click the Create button, it says, well, you need to specify this set ID. Oh, okay. Well, I'm going to call it App1 Server 1, just to give it a meaningful description. Then I'll click Create. So at this point, we've got an existing record that we've just created. It shows up here as an A record. If we select it, over on the right, we can see it's a multi-value answer. We see the IP address, and of course, our little description, App1 Server 1. Let's create another record similar to that, but the only difference really, will be the set ID, the description, and of course the value. It'll be a different IP. So I'm going to choose Create Record Set. Once again, it's going to be www, and it's going to be an A record. In this case, let's say 12.0.0.2. So let's assume that these two servers at these IPs are configured with the same app. And I'm going to call this one with the set ID item, App1 Server 2 in this case. And I will click Create. So now we've got two DNS records here with the same FQDN, but different IP addresses, and each of them is configured as a multi-value answer. And of course, they've got their own unique set IDs. So now when clients query www.quick24x7.local looking for an IP address, they'll get one or the other, and it's not returned to them in a predictable manner. In this demonstration, I'm going to configure some Amazon Route 53 weighted policies. Now, this is a type of configuration for a DNS record where you've got multiple DNS records that use the same FQDN. However, each of them is configured with a different numeric weight value. And if we've got one with a value of 100 and another record with a value of 200, same name, different IPs, the one with the value of 200 is used twice as often to return that IP address to the client than the same FQDN with a weight value of only 100. So let's see how this works. I'm going to get started here in the Route 53 Management Console, which I've already opened, and I'm going to click on an existing private hosted DNS zone. Now, in that private hosted DNS zone, I'm going to click Create Record Set, and let's say that we're doing this for an app called App2. So the DNS name here is going to be app2.quick24x7.local. Now it's going to resolve to an IPv4 address, let's say, which we're going to put in here as 13.0.0.1. And the routing policy is where we need to do our work. We need to specify weighted. I want the weight of this record, as per our example, to be, let's say, 100. And for set ID, I need some kind of a description. I'm going to call it app2 server 1. And I'm going to click create. So now we've got a new A record for app2.quick24x7.local. If I select it, we'll see on the right the weighted configuration. Let's create another record set with the exact same name, except the IP address will be different, and of course, the weight value and presumably the set ID will be different too. So I'm going to click create record set. Again, this is going to be for app2.quick24x7.local, so same FQDN. It's going to be an A record, where the other record maps to 13.0.0.1. I'm going to configure this to point to 13.0.0.2, where each of these IP addresses would be a web application, the same web application. Okay, let's go down and let's choose our weighted item. This one's going to have a value, let's say, of 200, and for the set ID, app2 server 2. And I'll click create. So if we look at our first weighted record, it's got a weight value of 100. Our second one has a value of 200, which means this IP address, 13.0.0.2, will be returned to clients that query for this FQDN. That IP will be returned twice as often than 13.0.0.1. In this demonstration, I'll use the AWS Management Console to launch or deploy a new EC2 instance running Windows. So to get started here in the AWS Management Console, why don't we search for EC2 and just select that in the search results, which takes us directly into the EC2 Management Console, where I'm going to click on the Instances view to see what we have already. Now it says we don't have any instances running within this region. Okay, and the region, of course, is shown up in the upper right, and Virginia. Now that's US East. Now, if we were to select a different region, if there were any EC2 instances deployed, they would show up in the list. Now, we don't have any, and I know I want to work in the North Virginia or US East type of region because it's close to where I am geographically, so I'm going to go ahead and switch back to that original region, and then we'll get to work. Now, what we're going to do once we're back here is just click the Launch Instance button up at the top. When we click Launch Instance, we're going to be asked a number of questions, the first of which is to select an Amazon machine image, an AMI. The Amazon machine image defines things like the default storage device that contains a specific version of a specific operating system. Now, down below, under Quick Start over on the left, we can see Amazon Linux variations of AMIs. As we go further down, Red Hat Linux, SUSE Linux, Ubuntu Server. As we go further and further, we'll also come across a lot of Windows items like Microsoft Windows Server 2019 Base. Now notice next to the names of each of these AMIs, you've also got an AMI ID. Now that's going to prove useful if you start working with this at the command line. For instance, if you decide you want to deploy EC2 instances using the CLI or through PowerShell. Also take note on the right whether it's 64 or 32-bit. And notice for some items, you'll be able to choose the platform. So 64-bit x86 versus 64-bit ARM. So in this particular case, we're looking at deploying Windows, specifically Windows Server 2019 is what I'm going to choose here. It's going to be the Data Center Edition. So I'm going to go ahead and click Select over on the right. In step 2, I have to choose the instance type. This is sometimes called instance sizing. It determines the horsepower of the virtual hardware that will support your virtual machine. So down below, I've got general purpose T2.micro, consists of one vCPU, one virtual CPU, 1 gigabyte of memory. It uses EBS, Elastic Block Store volumes, and that's fine. Now, depending on the workload, if I don't think that amount of RAM or memory, 1 gigabyte, is going to do it, then I can scroll down and choose something else that would do it. So if I need 16 gigs of RAM, then I might select the T3.xlarge instance type. But of course, you're doing that at a higher cost. So it really depends on balancing the workload requirements with paying for it. So I'm going to leave it in this case on t2.micro, and I'm going to click Next in the bottom right to configure instance details, such as how many instances do we want to deploy. I'm going to leave it on 1. Now, spot instances are extra compute capacity that you can essentially request for a discount, but you're not guaranteed that it will keep running. So depending on the nature of the workload running in the virtual machine, you might want to do that for cost savings while understanding you wouldn't want mission critical stuff running that way because the compute capacity might simply go away. I have to determine which VPC here I want this deployed in. I'm going to choose VPC 2, and then I'm going to choose the right subnet for what my needs are. In this case, I've only got one subnet, subnet 1. For auto-assign public IP address, it's set to use the subnet setting, which is set to disable. Here I'm going to choose enable so I can directly contact that EC2 instance over the internet because it will be given a public IP address. Now be careful when configuring this because that could present a security risk, in this case by exposing port 3389 for remote desktop services directly out to the internet. But because this is only a testing EC2 instance, I'm okay with doing this. As we go further through, we have a number of other options, such as joining an Active Directory domain, configuring the shutdown behavior, which is defaulted to simply stopping the EC2 instance, but notice that you could choose to terminate. If you know you're only doing this to fire it up quickly to test something and then you just want it removed right away, you could choose terminate. As we go further down, we can see the default tenancy here is shared. Run a shared hardware instance, although you could choose dedicated, but there's no need for us to do that. We don't need to run all of our EC2 instances on our own dedicated hardware instance. In this case, it's going to be shared. As we go further down, we might want graphics acceleration depending on the type of workload that'll be running within the EC2 instance. And notice by default, it's got a single network interface, device ETH0, although we could have multiple interfaces or devices if we needed to. I'm going to let it automatically assign the primary IP. And as we scroll further down, that's all we have to worry about here. So I'm going to click Next to add storage, and we'll see the default storage device here, the root volume type, that contains the operating system along with the size. We can adjust the size as well as the volume type. If you want the best possible performance, you can choose provisioned IOPS where you can specify the IOPS value, but you're going to do that by paying a premium. So you might need that if you have a disk-intensive workload that's going to be running in the EC2 instance. Many times, it might be best to start with general purpose SSD and then monitor the performance of the workload in that VM to determine if you need to change it. And we could add additional volumes just like we could add multiple network device interfaces, but I'm not going to here. I'll click Next to add tags. I'm going to click Add Tag, and the key here, let's say, is going to be name, and the value will be, let's say, WinServe 2019-1. And I'll click Next to configure the security group. Now the security group controls traffic flow. So it wants to create a new security group. Well, I'm going to give it a name. I'm going to call it Windows Security Group. And it allows RDP or remote desktop protocol traffic from anywhere into this instance, which is fine. So I'm going to go ahead and click Review and Launch. So we now see a summary of our settings. We could scroll down. Notice that each section has an edit link should you want to make a change. Now I don't want to make a change, so I'll click Launch. Now at this point, I can either create a new key pair, give it a name, and download the key pair file, or use an existing key pair. Now I already have a key pair called key pair 1, where the public portion is stored with Amazon, but the private part you have to download in a file. So, and you need to safekeep that file. So I'm going to choose the check mark to acknowledge that I've got the private key portion, and I'll click Launch Instances. We can now see it says our instance is now launching, and we can even click a link directly to the ID of the instance, and we can track its instance state. So it needs to be listed as running, and it needs to pass at least 2 status checks before it's ready to be used. One of the details you need to specify when you launch an EC2 instance is the Amazon machine image, or the AMI, that you want to serve as a basis or template for the newly created virtual machine. Here in the EC2 Management Console, if I were to click Launch Instance, I can see, even for Amazon Linux listed first here, that it has a unique Amazon Machine Image ID. And as I scroll down and look at all the different AMIs, for example, even Windows Server 2019, it's got its own AMI as well. So you don't have to do this using the GUI, although personally I find it easier. You can use the command line to sift through all of the Amazon machine images, because when you're going to reference the creation or launching of an instance from command line tools, you're going to need to know this AMI ID. So here in the CLI, I'm going to use the AWS EC2 run-instances syntax. I'll use --image-id, and I just have to correct this command line a little bit, because what should follow after that is simply the ID of the Amazon machine image. So here I've specified the Amazon machine image for Windows Server 2019. With --count, I'm going to specify I only want to launch one instance. --instance-type allows me to specify the supporting horsepower for the workload in the VM. I'm going to use an instance type here of t2.micro. If that doesn't accommodate your workload, you can always change it after. Then --key-name is used to specify the key pair that's required for authenticating to the Windows EC2 instance. --security-group IDs, I've got a security group here that I'm specifying that controls the traffic flow into and out of the instance. And finally, I have to deploy an instance into a subnet, and I specify that with --subnet-id, and here I've specified a subnet ID. Let's go ahead and press enter to launch this Windows instance. Now it's going to happen pretty quickly, at least the initial creation of it. It's still going to be initializing. It's not ready to go quite yet, but having this JSON output is a good thing. Now the next thing that I do want to do is I want to take note of the ID of this instance, because using command line tools, I can essentially point to this instance via its ID and make changes. And one of the changes that I want to make is to tag it. I want to make sure it's got a meaningful name here. So up at the top, I can see the instance ID. I'm going to go ahead and copy that. Then I'm going to use the AWS EC2 create-tag syntax, --resources, where I'll specify the instance ID, --tags, where key equals name, comma, and the value I'm assigning here is WinServe 2019-2. Let's press enter. And in this case, we have a syntax error. Let's use our up arrow key to bring that back. This is no problem. We don't have a space after the instance ID and before the tags parameter. Let's try this again. Looks good. No news is good news. Let's check our work in the console. Here in the instances view, I can see WinServe 2019-2 is now showing. It's got a state of running, but it's still initializing the status checks. But nonetheless, using the CLI, we have successfully launched a Windows EC2 instance. In this demonstration, I'm going to use PowerShell to deploy or launch a new Windows-based EC2 instance. So to get started here in PowerShell, I'm going to use the new -ec2 instance commandlet, but I need to specify with -image ID the Amazon machine image, or the AMI ID, which really defines things like the root block device or the disk for the VM that contains the OS, along with the type and version of the OS, whether it's Amazon Linux, SUSE Linux, Ubuntu Linux, or Windows Server 2016, Windows Server 2019. All of that is determined by the AMI. I'm going to set the min and the max count parameters here both to a value of 1. I only want to launch one EC2 instance. -key name, I'm going to specify a key pair I've already created called key pair 1, which is going to be required in order to decrypt the admin password for this Windows instance. I'm using -security group ID, and I've specified the ID of a security group that will control traffic into and out of that virtual machine. I'm setting the -instance type to, in this case, m1.small. That, of course, will vary depending on what you suspect the workload requirements will be within that instance. And you can change the instance type after it's created if you choose. Finally, you need to deploy instances into a subnet, and so I've used the -subnet ID parameter, and as you can see, I've specified an ID of a subnet. I'm going to go ahead and press enter. Now, it doesn't take very long before we get a bit of output. that virtual machine or that instance is now in the midst of being initialized. But what I want to do is just take a quick peek at how we might tag that instance, meaning that I want to give it a name that shows up properly. Let's switch over to the console for a moment. Here in the EC2 Management Console Instances view, I can see that we have a new instance that's initializing. It's listed with the state of running, but it doesn't have a name. Of course, I could click the pencil here and give it a name, but I want to do it from PowerShell. Now, if I select that, I can also copy the instance ID. Of course, you can retrieve the instance ID using the command line as well, but either way, you need the instance ID to refer to that instance using command line tools. And so here in PowerShell, I'm going to use the new -ec2 tag commandlet -resource ID parameter. Here's the instance ID that I just copied, -tag with an @ symbol and an open and close curly brace. And within that, key equals name, semicolon, value equals, and I want this to show up as being called WinServe 2019-3. Okay, I'm going to press enter, and then we're going to check our work in the console. So here in the console, we still don't see the name, but it's simply a matter of clicking the refresh button in the upper right, and indeed we now see the name is showing up correctly. You can remotely manage Windows-based EC2 instances using Remote Desktop Protocol or RDP. Now your instance might have a public IP address, so it's directly connectable via RDP, which could present a security risk, or you might have a jump box through which you connect to ultimately remotely manage your Windows instances in AWS. Here in the EC2 Management Console, I'm looking at my instances, one of which is named WinServe 2019-3. Having that selected, it's got both a public DNS hostname as well as a public IP address. Now I'm going to copy that. While that's important to know, we also have to know the password for the Windows administrator account. So to do that, having that EC2 instance selected, I will click the Connect button. Now here I can connect using a standalone RDP client or using the Session Manager tool. I'm going to use a standalone RDP client. I can download the remote desktop file if I wish. I'm just going to pop in the public IP when I do make a connection. However, what's important is that we have a warning here. It says you might not be able to connect to this if port 3389 isn't open in network ACLs and security groups. It says your current security groups don't have ports 3389 open. Okay, well, we'll check that out in a moment. So right now, we can see the administrator name. I'm going to click Get Password. Now, when you click Get Password, you're going to have to specify a key file that you use to decrypt the admin password. It wants the key pair path. This is a key pair that you specify when you launch the instance. The public part of that key is stored with AWS, but the private part is stored with this file that you must have access to. So I'm going to choose the file here that I downloaded when I created the key pair previously. When I do that, I can see the private key listed down here below. I'll click Decrypt Password, and here is the password. So I can go ahead and click the copy icon to copy that password. So in the Remote Desktop Connection client on my station, I'm going to specify the public IP address as well as the username of administrator, and I'm going to click Connect. Now let's give it a moment to see if it can make the connection. Remember, we had a warning when we were trying to get the administrator password decrypted. And here we can see Remote Desktop couldn't make a connection. Okay, no problem. We're going to take a look at what the reason is for this issue. So first things first, having that VM selected, if I look down at the description tab below and scroll down, I can see it's in a VPC called VPC1, and more specifically a subnet called VPC1_subnet. So I'm going to click on the VPC1 link, which will open up a new browser tab. There's VPC1 selected, and down below, I can see the network ACL it's associated with. The network ACL controls traffic flow into and out of the VPC. So if I look at inbound rules, it looks like all traffic is allowed in from any source. And outbound rules, all traffic is allowed out from any source, set to allow. And for subnet associations, it would appear that we've got VPC1_subnet1 associated with this. Well, that's not the problem, because port 3389 is not being blocked, at least not by the network ACL. However, if I scroll down in the navigator on the left, I can also look at security groups. Back here in my list of instances, for that selected instance, if I go down under the description tab over on the right, I'll see the security group that is associated with this. I can click View Inbound Rules. Oh, well, I see what the problem is. It's only allowing inbound TCP port 22, not 3389. Port 22 is used by Secure Shell, SSH, which you would commonly use to remotely manage Unix and Linux hosts. But for Windows, we need port 3389 opened. We've found the issue. Now let's fix it. So I can click on the link here for this security group, or I could just navigate to it in the other view. It doesn't make a difference how we do it. But I do need to go to Inbound, and I need to click Edit. Now, I'm going to change this rule because I don't need SSH connectivity for anything here. Instead, I'm going to make sure I change it to Remote Desktop or RDP. When I do that, there's port 3389 from any location. Okay, save. We're going to try to connect to our EC2 instance once again using the Remote Desktop client. So I still have the public IP, still have the administrator username. Let's click Connect. Aha! This is good. It wants the password. And remember, that's the one that we decrypted with our private key earlier. So I'll put that here and I'll click OK. Don't ask me again for connections to this computer, and I'll choose yes. And we are now in the midst of making an RDP connection into the AWS cloud for our Windows EC2 instance. Notice that when you're into a Windows EC2 instance, automatically on your desktop, you'll see the host name, the instance ID, public and private IPs, the instance size or type, the availability zone, and so on. In this demonstration, I'll use the AWS Management Console to launch a Linux-based EC2 instance. To get started, let's fire up the EC2 Management Console. Then I'm going to go to the Instances view and I'm going to click Launch Instance. Now the first order of business is to determine which flavor or distribution of Linux we're interested in. And that could be influenced by preference or familiarity, and of course also by requirements of specific software workloads that will run in Linux. Now we can choose from Amazon Linux, Red Hat Enterprise Linux, SUSE Linux Enterprise Server, Ubuntu Server, and so on. In this case, I'm going to choose Amazon Linux, and I'll choose Select. The default username for Amazon Linux AMIs is EC2-user, where the default name, by the way, for other distributions of Linux, such as Ubuntu, would be simply Ubuntu. Okay, let's scroll back up, and I'm going to click Select for the Amazon Linux image. The instance type is set to t2.micro. I'm okay with that. Next. I only want to deploy one of these Linux instances into VPC1, and specifically into VPC1_subnet1. The subnet1 has the setting enabled to automatically assign a public IP. I'll leave that enabled for this particular VM, but always be careful about exposing your EC2 instances directly to the internet with a public IP address. You might want to use a VPN before allowing access to these instances that might only have private IPs, or you might require MFA authentication through a jump box. But in this case, it's a test instance, so I'm okay with this. I'm going to scroll down. There's really nothing else I'm going to change here for the tenancy or anything like that. I'm going to leave the single ETH0 network interface, although I could add it, another one if I really wanted to, by clicking Add Device. And I'm going to click Next. I'm going to accept the default storage device. It's only 8 gigabytes in size. Again, I could add a new volume, just like I could add another network device if I so chose, but I'm okay with that. So I'm going to click Next to add tags. I'll click Add Tag. I want the name tag to have a value of Amazon Linux 2. So I'm going to select Amazon Linux from the list, and Amazon Linux 2. Next. So we can create a new security group or use an existing one. The security group controls the traffic flow into the instance, what's allowed in or out. Here it wants to create a new security group. That's fine, we'll let it do that, where SSH TCP port 22 traffic will be allowed in from anywhere. We can always change this later, but I'll leave it that way for now. I'll click Review and Launch. Here on the summary, I can scroll through and click the appropriate edit link if I want to make changes to a section. I don't. So I'm going to click Launch. I have an existing key pair called key pair 1. I'm going to have to turn on the check mark to acknowledge I have the private key portion that I've downloaded previously, which I do. And I'll click Launch Instances. And after a moment, we can see the instance is launching, and we've been presented with a link. So I'm going to click on the instance ID link. That's just a filtered list here in the instances view, and it's showing us Amazon Linux 2 is in the midst of being created. In this demonstration, I will launch a new Linux-based EC2 instance using the AWS CLI. To do this, I'm going to use the AWS EC2 run-instances syntax. I need to use --image-id as a parameter, and I need to supply the ID of an Amazon machine image. Now, the Amazon machine image, or AMI, determines things like the version and type of the operating system. So whether it's Ubuntu Linux, or whether it's Amazon Linux, whether it's Windows Server 2012, 2019, and also the boot device, so the operating system disk. So here I've specified the Amazon Linux AMI ID. I can use --count to determine how many instances I wish to launch. I only want one. I can use --instance-type and specify the instance sizing, the underlying horsepower, which of course has to accommodate the workload that will be running in the instance. In this case, for testing purposes, t2.micro will work just fine as an instance type. Next thing I need to do is use --key-name and specify a key pair that was created previously. So in this case, I'll use key pair 1. Then I'm going to use --security-group-IDs, and I'm specifying the ID of a security group that I want associated with this instance. The security group controls traffic that is allowed into or out of an EC2 instance. Then I'll use --subnet-ID and specify the ID of the subnet into which I want this instance deployed. So I'm going to go ahead and press Enter. Now, after a moment, we're going to have some returned JSON output, which is good news. It's in the midst of creating our new Linux-based EC2 instance. But as I scroll back up through all of the details, I'm interested in the instance ID because I want to tag the instance with a meaningful name. So I'm going to clear the screen after having copied the instance ID. Then I'll use the AWS EC2 create-tags syntax with the --resources parameter, where I will specify the instance ID for the instance we just launched. That's the one I want to modify. What I want to modify about it is tags. So I'll use --tags, and I'll specify key equals name, comma, value equals, and I want it to show up as being called Amazon Linux -3. Let's press Enter to make it so. So no news is good news. It didn't respond with anything. We're going to check our work in the console. And sure enough, if we look at our list of instances, there's Amazon Linux 3. The instance state is running, but it's still initializing before it passes the 2 initial status checks, at which point it will be ready to be connected to and to be used. In this demonstration, I'm going to use PowerShell to deploy a Linux-based EC2 instance. I'll do that using the new -EC2 instance PowerShell commandlet. I need to use -image-id to give it the identifier for an Amazon machine image, or AMI, which defines things like the boot device, the OS device disk, as well as the type and version of the OS. In this case, it's for Amazon Linux. That's what this AMI ID is for. And I'm specifying a min and max count of 1 because I only want to launch one Amazon Linux EC2 instance. -keyname, I am then specifying key pair 1. This is a key pair I've created previously. The public key portion is stored with Amazon. However, the private key was downloaded as a file that I've kept available. You need that if you want to be able to manage the EC2 instance. Now, often administrators will want to use tools like PuTTY to make a remote SSH connection. So you'd have to take that downloaded private key pair file and convert it to a version of the file consumable by PuTTY. You can do that with the free PuTTY Gen tool. I'm then using the -security group ID parameter, specifying the ID of a security group that will allow the appropriate traffic into and out of the EC2 instance. Presumably, we'll make sure that port 22 traffic is allowed for SSH, remote management. I'm using -instance type and setting it to m1.small. You can change that depending on the workload that will be running in the instance. And the last order of business is to define the subnet ID that you want to deploy this Linux-based instance into. So I've done that, so I'm going to press enter. Now after a moment, we have a bit of returned output. Let's check our work so far in the console. I'm looking at my EC2 instances. I'm just going to click refresh. We can see that we've got a new instance that has a state of pending. It's initializing, but it does not have a name. While we could click the little pen here to give it a name, I won't do that. Instead, we will tag it using PowerShell. But we want to do that. Of course, we need to know this instance ID. So I'm going to go ahead and copy this instance ID, which is also retrievable using PowerShell. So back here in PowerShell, I'm using new -ec2 tag, and I'm specifying -resource ID. This is the instance ID for which I want to change tag values. Now I just noticed I don't have a space after that ID before -tag. That's important. So -tag is the next parameter. I've got an @ symbol and an open and close curly brace within which I'm specifying a key of name, semicolon, and value equals, in this case, Amazon Linux -4. That's what I want it to be named as. Let's go ahead and press enter and let's go back to the console to see what it looks like now. We're going to need to refresh our view here, and now we can see Amazon Linux -4 is showing up. You can connect to Linux instances by using the SSH or Secure Shell protocol, which uses TCP port 22. To get started in doing that, here in the Instances view, in the EC2 Management Console, I'm going to select the Linux instance that I'm interested in connecting to. It's called Amazon Linux 2 here. We can see it's running, and it's got 2 of 2 status checks that are passed. Now, having that selected down below, I'm going to copy the public IP address. I've already downloaded and installed the PuTTY key generator. The reason this is important, besides the public IP of the Linux instance, is because when you create a key pair in Amazon Web Services, which you must do at least once at the end of launching an EC2 instance, you can save that as a file. But the problem is that key pair file, even though it contains a private key, is not consumable by the free PuTTY tool, which is commonly used to make an SSH connection to a Linux instance. So we need to convert it. So here in the PuTTY key generator, I'm going to open this file I've got in the background, which I downloaded from AWS when I created the key pair. And I do that by clicking the load button. It's going to say it successfully imported the foreign key. You're going to specify a key phrase and confirm it before saving the private key. I've chosen to call that resultant file AWS_private key, and it's a PPK file. Now we're ready to proceed to make the connection to our Linux instance using PuTTY. PuTTY is a free tool, just like PuTTYGen is. I've already downloaded it and now I'm running it. So I'm connecting to the public IP of my EC2 instance, port 22 SSH, but over on the left, I need to go all the way down under connection SSH auth, where I need to specify the private key file. That's the one that is consumable by this tool, the PPK file that we converted just a moment ago. And once I've specified that, I'm going to go ahead and click Open to open the connection. Now, because it's the first time I've connected, PuTTY is asking if I trust the unique RSA fingerprint for it. I'm going to choose Yes. Now, we are using Amazon Linux, and so the default username is ec2-user. If we had selected an AMI that uses Ubuntu Linux, the default username would be Ubuntu. So I'm going to go ahead and put that in. Next, you'll be prompted for the passphrase that you specified when you converted the file and saved it, the private key file. So I'm going to go ahead and put that in. And after I enter that successfully, we're logged in as EC2 users. So we've got a remote SSH connection using PuTTY to our Linux-based EC2 instance. The EC2 instance type also sometimes called the instance size, determines the underlying horsepower in terms of virtual CPUs and the amount of RAM, those types of things that control how much power is available to run a workload within an EC2 instance. Now you can set that when you launch the instance, of course, but also after the fact. Now when you do that, you want to make sure that the instance is stopped. Here I've got an instance running Windows Server 2019. We can see its state is that it's stopped. Now having that instance selected, if we take a look down below under the description tab, we'll see that the instance type is currently set to t2.micro. Now, after monitoring the performance of that instance, if we determine that's not enough horsepower to provide acceptable performance for an app, then we can change the instance type. To do that, select the instance, go to the Actions menu, then you go to Instance Settings, and from there you can choose Change Instance Type. So currently we can see what's reflected in the background here for the instance type. It's t2.micro. So what I might do, for example, is increase it, let's say, to t2.small, then I'll click Apply. And we can now see that it's reflected here. So if we were to go to Actions, Instance State, and Start, now that we start up that instance, it will pick up the change in the underlying virtual hardware and will provide, hopefully, better performance for the application running within the operating system. When you launch a new EC2 instance, there are times where you might want certain commands to run automatically when it launches initially, maybe to install certain packages or to apply certain updates. Now to do that, we can use an EC2 launch script, which we can place inside of the user data section when we launch an EC2 instance. Let's see what that looks like. So for example, here in the EC2 Management Console, I'm going to click the Launch Instance button, and we're going to launch a Windows Server 2019 instance, although you can also use these launch scripts with Linux as well. It doesn't make a difference what the OS is. I'm going to go ahead and click Select. I'm going to accept the default instance type, so I'll click Next to configure the instance details. What I'm really interested in doing here under this page is way down under Advanced Details, is putting something in user data. You can put it as text or as a file. So for example, what I want to do is simply put in some script statements that we can test to verify they automatically executed upon launch. To do that, I'll use the script opening tag and the script closing tag and put my commands inside of it. Here I'm using the Windows echo command to echo the text. This is sample text. Now you may want to put that in quotes, for example, if you've got some spaces in it. And then I'm using the redirection symbol, the output redirection symbol, the greater than sign. And I want this stored in a file called test.log, which will be under %systemroot%. That's a Windows variable, which normally is C:\Windows, is what it results in being. Under that, under temp, and of course the test log file. Let's go ahead and see what happens here. So I'm just going to go to Next for the storage. I'm going to basically accept the rest of the defaults, and I'll click Launch. I'll use key pair 1 and acknowledge I have the private key, and I'll click Launch Instances. What we're going to do is we're going to use RDP, Remote Desktop Protocol, to go into that instance to verify the presence of that file containing the text, "This is sample text." So now that my EC2 instance has launched and I've RDP'd into it, let's take a look at the file system. So I'm going to open up Windows Explorer so we can do just that. And what I want to do is go into this PC. We want to go under C, Windows, then we want to go into the temp folder. And we're going to have a file listed here called test. And inside it says, "This is sample text." Now we don't see the file extension because that's simply turned off. So if I go to View and turn on File Name Extensions, we indeed see the file is named test.log. As a matter of both convenience and cost savings, you can use scheduled EC2 instance reservations. Now, reservation means that you are committing, for example, to a 1-year term, but you are scheduling EC2 instances to run at certain times, such as daily or weekly, maybe for batch processing of some type. So to get started with this configuration of EC2 scheduled instance reservations, we're going to go into the EC2 Management Console, where in the left-hand navigator under Instances, you'll see Scheduled Instances. And we don't have any configurations yet, so over on the right, we have a Purchase Scheduled Instances button, which I will click on. We can specify the starting date where we want this applicable, and we can also specify the duration in terms of hours, and the recurrence, whether it's daily, weekly, or monthly. Now, once we do that, we then specify the platform. Do we want it to be Linux or Unix-based, or do we want instances running the Windows operating system? And do we care about the specific instance type or sizing? So you have limited options available here. So you can choose any of them, or I'll just unselect what I've clicked on, and it's back to just saying any. You can also choose the availability zone where you want to do this. Now, if I were to click Find Schedules at this point, down below, it'll show me any availability. Sometimes there might not be availability. However, we can see the reflection of what we selected above, the starting date and time, the instance type, in this case, 4 virtual CPUs, the availability zone, and the price per hour. We can also see the price per year. Now, that's based on, in this case, a scheduled recurrence of daily for 4 hours. So we can see that listed here. So we can click Add to Cart and add the appropriate items and then review them and purchase them. Now, the overall benefit, remember, is to reserve recurring EC2 compute capacity by the hour for a 1-year term at a cost discount. An Amazon Machine Image, or AMI, really defines the root boot volume containing the OS and the OS type. Now, while there are many AMIs that you can choose from, you can also build your own custom AMI. For example, here in the AWS Management Console, I'm going to go down to EC2. Now, if I were to go, let's say, to the Instances view and then choose the Launch Instance button, here I can see a number of Amazon Machine Images listed. We can also see the IDs for each of them. So for Amazon Linux, Red Hat Enterprise Linux, SUSE Linux Enterprise Server, Ubuntu Server, even all the way down to variations of Windows and so on. And there's a lot here, and you can also search through the list. Now, let's go back here to look at our existing instances. Let's say we've got an instance, here it's called WinServe 2019-1, that we have launched, and we've remoted into it, we've configured it just the way we want it to run, we've installed some software that's required, and we want to be able to reuse that configuration for other EC2 instances. Well, the solution would be to create a custom AMI from that EC2 instance, which is precisely what we're going to do now. So I select the instance, I go to the Actions menu, I choose Image, and then I choose Create Image. We're going to have to fill in some details. Let's say we call this Custom Image -dev test. We could add a description, includes package A, B, and C, and configuration level 1, let's say. Now down below, we can specify some details like the size of the root device and add additional, perhaps, data volumes, but I'm not going to do that. I'm just going to choose Create Image. Now when I do that, it says Create Image Request Received. All right, well, let's close out. Let's see if it's available right now. Now, if we go to Launch an Instance with the Launch Instance button, we should see this under My AMIs over on the left. Now, we don't see anything listed here, so we're going to give it a minute, and we're going to come back, and we're going to do exactly the same thing. If I go to the AMIs view, notice here it's in the midst of creating our new custom image. The status states pending. And after a moment, when we click refresh, we'll see that the status now shows available. So let's go back to the Instances view and launch a new instance. And what we want to do is look at My AMIs. And when we do that, notice our custom image dev test is now showing. When you're planning the use of Amazon Web Services cloud-based database solutions, you need to consider the type of database solution that best solves a business problem. whether it be a SQL solution or a NoSQL solution. Structured Query Language, or SQL, is a language that's used to access relational database objects and data. Now, objects would include things like records within tables. The thing about this is that it's really designed so that data tables are related via common fields. For example, linking a customer table with a transaction table, perhaps linked through a common field or column such as a customer ID. So there is integrity of related data stored in different tables with a SQL type of solution. This is called normalization, and its purpose is to not only keep data integrity intact, but also to reduce repeated data. For example, we don't want to repeat all the details about a customer, like their address and credit history, every time that they generate a transaction. Common uses for a SQL database type of solution would include e-commerce gateways, customer relationship management or CRM solutions, and so on. Now, SQL objects would include things like servers and databases, rows, tables, and fields, to name just a few. In the Amazon Web Services Cloud, you could always manually deploy an EC2 instance server, whether it's Windows or Linux based, and then manually install and configure database software. Or you could use AWS Managed Database Solutions. A NoSQL type of database uses a less rigid blueprint or schema than a SQL relational type of database. Now, the schema is the blueprint that determines what will be stored, including data types and fields such as customer ID, customer last name, customer first name. But that means that we've got a very strict or structured blueprint, and we know ahead of time exactly what we want to store. A NoSQL database doesn't do that. It has a very loose schema, if at all. It's also designed for high scalability for storing and working with big data. So common uses for NoSQL types of databases would include the storage and manipulation of user profiles, such as for social media or for large-scale gaming on the internet, as well as content management for websites. NoSQL databases are designed for high performance and availability, where each row can store completely different types of data, because there might not even be a schema that defines what is to be stored. There are different types of NoSQL storage, such as key value, document, and graph. Remember that NoSQL databases are non-relational, so if you need to store information in separate tables and link them together, NoSQL is not the solution. Instead, you'd be looking at a SQL-based solution. One of the benefits of running a database in the Amazon Web Services Cloud is scalability. You also have the option of using an AWS Database Managed Service solution. Now, a managed service means that the underlying server and database software is installed and taken care of for you. The opposite is to manually install and configure EC2 instances and database software to do your own thing. Now, we have the option of using SQL type of databases through Amazon Web Services Relational Database Services, or RDS. Now, this would include using SQL types of databases, including Amazon Aurora, MySQL, Microsoft SQL Server, Oracle, PostgreSQL, and MariaDB. On the NoSQL side, you've got options including DynamoDB and DocumentDB. AWS database solutions can be managed using GUI tools or using non-GUI tools. On the GUI side, we can use the AWS Management Console to both launch our database solutions as well as to manage them, such as making sure that we create secondary database replicas in alternate regions, for instance. We can also use other standard tools, such as MySQL Workbench. We could run that on an on-premises station and connect into our MySQL RDS deployment in the AWS cloud and manage it using that tool. Or if you've deployed Microsoft SQL Server in AWS, you might use the Microsoft SQL Server Management Studio tool on premises to connect to your SQL Server database instance in the cloud to manage it. Now, without using a GUI, you might consider using the AWS CLI To deploy and manage your AWS database solutions, you can use PowerShell commandlets, and at the developer level, API calls can be made to control databases. Now, when you deploy databases in AWS, there are many different types of options, including provisioned IOPS. Now, this will be available with most databases that you deploy into AWS. One exception that's notable would be Amazon Aurora, where you cannot set provisioned IOPS. Provisioned IOPS is a setting that's going to be very relevant when you know you're going to have an intensive disk I/O workload running through that database. There's also bring your own license, or BYOL, where you can reuse your existing investment in database licenses in the cloud. So if you've already paid for licensing for on-premises Oracle or Microsoft SQL Server, you can bring that into the cloud and reduce your costs that way. You can also create multiple database replicas across multi-availability zones for both high availability and performance. For example, you might deploy a secondary database replica in an alternate region where you know there's going to be heavy querying activity. Of course, always an option in the cloud and a benefit is scaling. Storage auto-scaling allows your database to grow along with the requirements that go along with that solution. There's encryption of data at rest and accessibility of the database either publicly, such as through the internet, with a public IP address, or only privately, such as after authenticating to a VPN connecting to the AWS cloud. You can also configure security group rules to control traffic into and out of your databases. So let's say you deploy MySQL through Amazon Web Services RDS. Well, your security group rule would have to allow traffic destined for 3306 because that's the standard management point to connect to MySQL. If you were using Microsoft SQL Server, your security group rule would allow 1433 as a port number, and so on. RDS instance types control the underlying horsepower for that database, just like a standard EC2 instance type controls the horsepower in terms of vCPUs and disk IOPS and the amount of RAM. The standard classes, including the M classes, work well if you know you don't need to cache too much database information in memory. But if you know that you're going to be caching a lot of information in memory, which can also provide a performance enhancement, then you should use memory optimized classes that include the R and the X in the instance type names. And there's also the burstable classes that include a T in the instance type name. Burstable means that when you have some kind of a performance spike, meaning you have an increased demand, all of a sudden, it can meet that demand. It's burstable. And you might do this initially when you deploy a solution, an application in the cloud that uses a database, to monitor its performance so you can kind of gauge what the baseline should be. So burstable classes are good for initial deployments when you don't know what the baseline is. Amazon Aurora is a relational database service offering in Amazon Web Services, and it's compatible with MySQL and PostgreSQL. The thing about it is that from the ground up, it was designed to run in a cloud environment, where if you look at something like MySQL, originally it was designed to run on physical servers. And so Aurora then is designed to be very quick while being compatible with MySQL and PostgreSQL. So from the AWS Management Console, I'm going to search for RDS, the Relational Database Service. Now that's going to put me in the RDS console where I'm going to click the Create Database button. I'm going to leave it on Standard Create while I'll have all of the configuration options. Easy Create uses best practice configuration, so you don't get to see all of the choices. So I'll leave it on Standard Create. Down below, we can see our 6 relational database engine options. The first of which, and it's automatically selected, is Amazon Aurora. Now, because it's MySQL and PostgreSQL compliant, you get to choose the option below. Do you want MySQL compatibility or PostgreSQL compatibility? If I leave it on the default of MySQL, then I can choose from a variety of different versions of MySQL for compliance. Also, at the same time, if I were to scroll way down in the settings, all the way down to the additional connectivity configuration section, notice that it's using the MySQL port of 3306. Whereas if I go all the way back up to the top again, if I were to choose PostgreSQL, Well, first of all, for the database engine version, I now have variations on PostgreSQL. And as you might imagine, if I go all the way down to what we looked at previously, that would be the additional connectivity configuration. Notice now it's using the standard PostgreSQL port of 5432. So in this case, let's say that I want it to be MySQL compatible. So I'll select that and I'll leave the default selection. Then we've got some options as to whether we want the database to be provisioned regionally in a single AWS region, that's the default, or for availability if we want it global, where we can provision the database in multiple regions. Now, replication will keep the different copies of that database in different regions in sync. I'm going to leave it on regional down below. Database features. Is it going to be one database writer with multiple readers? So for example, for an e-commerce web app, you might have one writer, which would be the software for the front-end web app, but you might have multiple queries on the information stored in the database for data analytics. Or do we want to set it up for one writer and multiple readers, or multiple writers, or serverless, where we just specify the amount of resources that would be needed. And it says that serverless would be good if you have intermittent or unpredictable workloads. So it really depends on the application in question that will be reading and writing to and from this database. Down below for templates, I'm going to choose dev test. Scrolling down, I can see the DB cluster identifier is database-1. Now, the default username is admin. I'm going to have to specify and confirm the master password. And down below that, I have to select the appropriate DB instance size depending on the workload that will be accommodated. So if it's going to be memory optimized or burstable, if we've got some peak variations of workload demands, or if it's unpredictable. So I can select the appropriate option. In this case, it's going to be memory optimized classes. And here I can select the appropriate item. So I can specify the number of vCPUs and the amount of RAM that's available. So I'm just going to go ahead and leave it at the default item. Down below, availability and durability. I'm not going to create any replicas, so we're not going to create a multi-availability zone deployment for dev and testing. I can deploy this into a specific VPC that I select from the drop-down list. And we already looked at the additional connectivity configuration in terms of the port number down at the bottom, but there are some other things here that are very important. The default for this is that it will not be publicly accessible. So if you want to manage the database, which of course you would want to, you're going to have another EC2 instance on the network that you connect to first, that in turn can be used to connect to Aurora. And you could even use some standard tools like the MySQL command line tool to connect to the Aurora database. You'll need to enter the root user account password, the admin password that we just specified above. If I want this to be directly publicly accessible from the internet, then I would choose yes. I can change that after the fact, so I'll leave it on the default of no. Then comes the VPC security group to control access to the database. So we can choose an existing VPC security group, or we can create a brand new one. So I'm just going to leave the default one selected here. We could remove that by clicking the X, but I'm going to leave it. And we know the database port is 3306. Finally, we've got database authentication options for Aurora, the default of which is password authentication, but you can use password and IAM database authentication, which means you need to have an IAM user account. That set of creds would be required to connect to the database. Under additional configuration, if we go down and take a look, we can see we've got some options for backup. So the backup retention period is set to 1 day. We've got encryption so that we can have protection of data at rest. And of course, we can see the master key that is being used to do that. We've also got the retention period available here for performance insights, if you want to be able to monitor performance metrics against the database to see how it's doing. So we have a number of these monitoring options available as well. Then we've got some logging options. Now, what I want to do here is only publish error log entries to Amazon CloudWatch. So I'll turn that item on. And at this point, I'm going to click Create Database. And after a moment, you'll see that the database instance has been deployed. We have a message at the top that says it successfully created our database, and we've got a View Credential Details button where we can see the master username and the master password and the endpoint for connectivity, such as if you're reconfiguring an app to use a different database, then you could point it to Aurora using that endpoint. I'm going to click Close. Now we've got two items listed here. There's a bit of a hierarchy. We've got our database 1 listed here, but underneath it, we've got a specific instance, which is listed as being a writer instance. Now, if we click on our link for the database identifier, database-1, then down below, we've got a number of tabs with configuration items. So for example, for connectivity and security, we can see we've got two different endpoints listed here. Their status is available. One is for writer, one is for reader, both on port 3306, which is the standard MySQL port number as we discussed. So we've got a lot of options that we can go back and make changes to by clicking on these various tabs. For example, if I go to configuration, we'll also see we have a number of items that we can make changes to. Now, by making changes, what I mean is by clicking the Modify button up at the top. If I actually click on a database instance, the one listed below as writer, then when we look at things like the connectivity and security items for that particular instance, we'll see that we see items such as the VPC it's been deployed into, public accessibility, which is set to no. Again, we can go up and click on Modify and make some changes to some of these items. So now that I'm modifying it, I can scroll all the way down, for instance, to public accessibility and change my mind to yes. And then I've got failover options where I could choose which replica, if we have multiple replicas, should be promoted automatically to the primary. It's going to be the one flagged with the highest tier level, such as tier 0 being a higher tier than tier 4, for example. We also have a number of options. Let's first go down here and cancel because we're not going to actually make any changes to that. We also can go to the Actions menu, and because I've got a specific database instance selected at the bottom, we can reboot it, delete it, or take a snapshot. But if I were to select the database itself up above and go to the Actions menu, we have different items. We can stop the database, which is important. If we don't want to use it currently for testing purposes, we should stop it so we don't incur charges. We can also add a reader instance or, for example, create a cross-region read replica. Now, when I do that, naturally, I'd have to specify some details like the DB instance class to handle the workload. I'd have to determine whether it's publicly accessible. And of course, I have to choose the appropriate location or destination region where I want to create this replica. So we've got a number of options available then as we work with Amazon Aurora in Amazon Web Services. In this demonstration, I'll use the AWS Management Console to deploy MySQL. MySQL has been around for quite a while, and it's well known and it's trusted. And we can deploy it very quickly and easily as a managed service through Amazon RDS, Relational Database Service. I'm already in the Amazon RDS console where I'm looking at my dashboard on the left, and I have the option of creating a database. Now, I can go to my databases listing to see any existing databases that might have been deployed. Here I see I've already got Amazon Aurora MySQL compliant databases deployed. But that's not pure, true MySQL. It's Aurora, which is MySQL compliant. If I want to actually work 100% with pure MySQL, then I can create a new database deployment. So I'm going to click Create Database. Now at this point, I'm going to leave it on Standard Create, so I have all config options visible, and I'm going to choose MySQL from the list. Now down below, I can choose the specific database engine version that I want to run with MySQL. So depending on what I'm doing with that database will determine if I need to select a specific version. Now down below, I'm going to use the dev test template because when I do that, notice I have options available such as, if we go further and further down, creating a multi-availability zone deployment. I have that option. However, if I were to go up to the top, and if I were to choose the free tier, which ultimately is what I'm going to use, when I go all the way back down, I have very limited options for availability and durability. Notice the multi-availability zone deployment option is not even selectable because of the tier I've selected. Let's go back up to the top here, So we've got a database instance identifier filled in. We can change that. I've got to specify the master username and password and confirm the password. Next thing I'll do is scroll down. Now I've got a limit to the database instance size because I'm in the free tier. So I have a couple of options here, but notice that they are grayed out. That's okay. For this purpose, I'll leave it as it is. I can determine the type of storage. So if I need the utmost in disk throughput, then I would choose provisioned IOPS SSD. I can specify the amount of storage I need and the IOPS value. If I were to choose general purpose, then we don't get to specify the IOPS value. But at the same time, it's less expensive than provisioned IOPS. So you have to weigh the disk I/O performance needs against the potential costs. We can determine if we want to enable storage auto-scaling as we need more and more space. And as I scroll all the way down, I have to deploy this into a VPC, so I'll leave that selection. And under additional connectivity configuration, if I want this to be publicly accessible, this database from the internet, which I do in this case, I'll choose yes, although I can change these things after. I can also associate this with a VPC security group to control traffic, and of course MySQL uses port 3306. Down below, the database authentication can be either password authentication or password and IAM database authentication. And then under additional configuration, we have a number of other items like backup and retention items and monitoring and logging options. I can also, as I can with other databases, enable deletion protection. In other words, I can't delete the database unless I specifically come in and turn that option off and then delete it. So it's just an added layer of protection. Finally, I have estimated monthly costs that are listed down below. So at this point, if I'm happy with my selections, I would click the Create Database button. And we can now see our MySQL database instance, so the identifier is called database-2, is listed here. And at the top it says it's creating the database and it might take a few minutes. And after a moment, we can see that our MySQL database 2 instance has been deployed. We can see that the status column shows that it's available. And at the top, we have a message about the successful creation. We can click View Credential Details to see the admin username and the password. And we can also, of course, select the radio button to the left of that MySQL database instance. And we could choose Modify if we wanted to make configuration changes, basically to make different settings in effect beyond what we set during the initial config, such as whether we want a multi-availability zone deployment configuration, or we want to change the storage type to provisioned IOPS or magnetic for even slower performance if we don't need speed. As we scroll down, we can see all the options, such as whether the database is publicly accessible, the port number for the database. For MySQL, it's always 3306. Now, I'm going to cancel out of that. I'm going to scroll down, cancel. We're not going to make changes. Having that selected, we can also go to the Actions menu. We can stop the instance, reboot it, delete it. We can also create replicas or take a snapshot. We also can restore it to a point in time if we have a problem with the database. So we can see the last restorable time, the most recent one, or we could choose custom and specify the date and time that we want to restore from. So I'm just going to go all the way down to the bottom here because we aren't going to do that, and I'm going to cancel. So when you look at the database, if I click directly on it, we get the same types of things that we've seen with other RDS types of databases. We have the tabs at the bottom for connectivity and security. We can monitor some aspects of the database in terms of its performance, so CPU utilization, number of database connections, free storage space based on our configured settings when we deploy the database itself. And of course, we can continue going to the Configuration tab to see any other settings based on our initial selections when we created the database. And if I go back under Connectivity and Security, here we have the database endpoint that we would use to make a connection to this MySQL instance in the AWS cloud. So here on premises, I've downloaded and installed the free MySQL Workbench tool. This is a GUI tool that you might elect to use to make a connection to your MySQL instance in the AWS cloud. So by the MySQL Connections text here, I'm going to click the plus sign to add a new connection. I'm going to call it AWS MySQL. And for the host name, I'm going to paste the endpoint that we just saw in the RDS console. It's port 3306. The username is admin in this case. For the password, I'll click Store in Vault, and I'm going to put in the password that I specified when I deployed that MySQL instance. I'll click OK, and then I'll click Test Connection. And it says it successfully made the MySQL connection, because remember, we defined that as being publicly accessible. So at this point, I could click OK, and I could actually just double click on that to actually open a connection to that database in the cloud. And at this point, we can start managing details related to that database. So for example, if I click Service Status on the left, we can see here some details over on the right about our MySQL database deployment running in the AWS environment. MariaDB is another relational database service offering as a managed database solution in Amazon Web Services. Here in the RDS console, I'm going to start by clicking the Create Database button. And you'll see, if we scroll down just a little bit, that MariaDB is a selectable option. Now, this uses port 3306 for connectivity, just like MySQL does, and you can actually think of MariaDB as being a sort of replacement for MySQL, in the sense that if you want to use a database that is fully compatible with MySQL, MariaDB is another option. It's open source, but it actually supports more database engines than MySQL, so therefore it's more flexible. And it provides more enterprise-class features than MySQL does as well. One example of which is parallel data writes to multiple replicas. So I'm going to go ahead and select MariaDB Standard Create. And down below, I'm going to choose from the list of versions of MariaDB. So I'm going to leave the default selection. And for the templates, I'm going to choose free tier. So much like when we deploy other RDS database solutions, we have some common things we need to specify, like the database instance identifier and the credentials. So the default name supplied here is admin. I'm going to leave that. I don't want to auto-generate a password. I'm going to specify and confirm the master password. And then I'm going to scroll down, and here we can select from the appropriate database instance size. Now, because we're using the free tier, we have limited options. Many of them are grayed out. If we were to use production as a template up at the top, then when we go back down, notice that the DB instance size options are all now available. They're not grayed out. So just bear that in mind if you're testing this out. So I'm going to leave this as free tier. Then for storage, the default is general purpose SSD, but we can use provisioned IOPS if we need the utmost in disk I/O performance. So I'll leave it on general purpose. We can also determine what the storage space should be. The allocated storage by default here is 20 gigabytes. Down below, we can enable storage auto scaling, so increase the size as required for the database. And of course, there's a maximum ceiling limit threshold here of 1,000 gigabytes. And if I scroll down, multi-availability zone deployment is unavailable only because we are using the free tier template. We have to deploy this database into a VPC, and under additional connectivity configuration, we can determine whether this database is publicly accessible or not. So we can make a connection to it either from the internet using tools on premises that we would normally use to connect to a database that's MySQL compliant. Remember, this will be listening, MariaDB will be listening on port 3306. Or if you leave publicly accessible to no, you'd have to have an EC2 instance in the VPC that you would connect to, and from it, you could manage your database instance. The default VPC security group has been set here. I'm not going to set an availability zone as a preference, and of course, there's our database port 3306. Under additional configuration, we can specify the initial database name. As we go further down, we've got backup and monitoring and logging options. And finally, we can enable deletion protection. So being happy with those settings, I'm going to go ahead and click on Create Database. And after a moment, we can see in the upper left, it says Creating Database. It might take a few minutes to launch. So our database identifier for MariaDB, database-1, is listed here. If we scroll over to the right, we can see the status is listed currently as creating. So we can see the database was deployed. We can click the View Credential Details button to see the admin name in this case and the password, just like we can with other RDS database deployments. We can see that the status of our MariaDB database instance is now listed as being available. And if we select the radio button to the left of that listed database instance, we can modify the config of the database. We also have the option when we're modifying the database instance to change some of the items that we configured specifically initially. So we can change the storage type. Notice that we have the magnetic disk storage type option, which is not available initially during deployment. That uses traditional magnetic hard disks with moving parts, which is considered slower than general purpose SSD, and of course, ultimately very much slower than provisioned IOPS SSD. Now at the very bottom, I'm just going to click Cancel. We could also go to the Actions menu and stop the database instance, which is very important if you're not going to be using it, specifically if you're testing, because you're incurring charges while it's running. We can create a read replica. You could also go to the Actions menu and restore to an earlier point in time because it's taking database snapshots. So we can use the last restorable time, or we can select Custom. And as we proceed through the wizard, we specify details such as the database instance identifier, the VPC that this will be deployed into, public accessibility, pretty much the same type of thing that you specify initially when you deploy MariaDB. PostgreSQL is a relational database engine type that's been around for a while. And sometimes when you're deploying an RDS database in Amazon Web Services, aside from performance and scalability, you might look at what you're already familiar with. And as a result, you might choose a relational database engine such as PostgreSQL. So here in the Amazon RDS dashboard, I'm going to click the Create Database button over on the right. I'll scroll down a little bit and select PostgreSQL, after which I need to select the specific version of the PostgreSQL engine that I want to use. Down below that, I have three templates: Production, which gives us the best for high availability and performance, Dev Test for testing outside of production, and Free Tier. Free Tier is what I'm going to select here, although some options will be unchangeable down below, specifically the database instance size, which determines the underlying horsepower, so the number of vCPUs, the amount of RAM, and so on. I can't change that unless I'm using either, way back up above, the production or the dev test template. With the free tier selection, also what's not available is multi-availability zone or multi-AZ deployments. However, for this purpose, that's going to be okay. So let's scroll back up here. The database instance identifier is set as database-1, but of course I could change it. Notice that the master username is Postgres, and I'm going to specify and confirm the master password for that username. Then we've got some standard options below, such as the storage type, which is defaulted to general purpose solid-state drives or SSD. But if we need better disk throughput for disk I/O, we might choose provisioned IOPS, where we can specify the provisioned IOPS value. We can also specify the allocated storage space, and notice that storage auto-scaling is automatically enabled. So as we need more space, it will be available. However, we've got a maximum threshold here specified, the default of which is 1,000 gigabytes. Scrolling down further under connectivity, we have to deploy this database into a VPC. And if I open up additional connectivity configuration, we can determine items such as whether or not the database is publicly accessible. I'm going to choose yes in this example. That way I don't have to have an EC2 instance in the VPC that I first connect to so that I can manage PostgreSQL. As I go further down, the default security group, which controls traffic flow in terms of what's allowed, is selected. I don't have an availability zone set, but I could choose one specifically. So I'm going to select one. And down below, notice the default database port here for PostgreSQL is 5432. Down below, we've got a number of database authentication options. Now, normally with most RDS database deployment types, so different engines, you'll have password authentication and password and IAM database authentication. But PostgreSQL also gives us password and Kerberos authentication. Now, Kerberos is the authentication protocol used by Microsoft Active Directory. So when I select that, I can click the Browse Directory button. Now, I don't have any Active Directory instances in AWS, but we could create a new one. There's a link, or select one if it already exists. I'll click Cancel, and I'll go back to just password authentication. If I open up additional configuration, then we've got a number of other items, such as backup options. So automatic backups are always enabled in RDS unless you change it otherwise. Also, we've got performance insights for performance metrics that's enabled by default. Also, as we scroll further and further down, we have monitoring options we could turn on for enhanced monitoring, log export options. So we have a number of items that can be configured, and many of these you can change after the fact. So I'm going to go down and click Create Database. Now once we do that, we're placed back in the databases view. We can see our database instance for PostgreSQL that's in the midst of being created. The status is creating. We've also got this progress message that says it might take a few minutes before it's ready to go. We also, as is the case with other RDS deployment types, have a View Credential Details button where we can see the master username and the master password. Once the database is deployed, you'll see it says it created it, and if we look at the status, it'll say available. Now, of course, like other RDS deployments, I can select the radio button to the left of that database identifier for PostgreSQL, and I can click Modify if I want to modify any of the configuration settings that we would have specified upon initial creation, such as whether it's publicly available or not, and the storage auto-scaling options, and so on. However, I'm going to cancel out of that. I could also, still having it selected, go to the Actions menu and stop, reboot, or delete that database. I could create a read replica, take a snapshot at this point, and restore it to an earlier point in time if the database is corrupted or some of the data has been deleted. Now also, if I click on the link for the database identifier, we'll see a lot of settings. So scrolling down below under connectivity and security, for instance, we can see the endpoint. Now that's going to be important if we want to make a connection to this one, and I do because we did set this to be publicly accessible. Now remember that accessing PostgreSQL occurs in a destination port type of way to port 5432. Now you can download the free pgadmin GUI tool so you can connect to and manage PostgreSQL, whether it's on premises or, in our case, in the AWS cloud. I've already downloaded the Windows binary installer and installed the tool, and when I launch it, it looks something like this in my web browser. So it's connected to my local machine at 127.0.0.1. What I need to do is essentially create a profile, and the way we do that here is by clicking Add New Server with the connection details for our database instance. I'm going to call this PostgreSQL AWS, and under the connection tab, I'm going to paste in the endpoint. We know that the username is Postgres because we saw that upon initial deployment. So I'm just going to go ahead and specify the password that I specified when I deployed the database, and I'm going to click Save. And it automatically will try to make a connection to it, and it succeeded. Here's the name of our connection, and we can even select that and get some statistics: transactions per second, server sessions, block I/O. The counters for tuples in and tuples out are really specific to a returned, not necessarily a row within a table, but a returned row that might be spread across multiple tables through a relationship. So we've got some of those performance details listed here. I can also drill down under databases to view databases. I can also right-click on databases to create a new one. And when I'm finished working with PostgreSQL, I can go ahead and right-click and disconnect server. So that's it. It's pretty easy to get the database deployed and connect to it to manage it in AWS. The tricky part becomes populating data into database tables and then using it, for example, from a front-end web application. Microsoft SQL Server is an available Amazon RDS database engine type. To get started here in the Amazon RDS dashboard, I'm going to click the Create Database button, where down below, I'm going to choose Microsoft SQL Server. When I do that, I can select the specific edition, whether it's SQL Server Express, SQL Server Web, SQL Server Standard, or SQL Server Enterprise. And within each of these, regardless of the edition selection, I can choose the specific version, whether it's SQL Server 2017, 2016, and so on. In this case, for testing purposes, I'm going to go with SQL Server Express Edition, which has a maximum database size of 10 gigabytes. But for this purpose, that will be sufficient. Now, scrolling down below, I can use either the dev test or the free tier template. If I use the free tier template, I won't be able to change some items such as the database instance class that determines the underlying horsepower to support the database workload. It's simply not changeable, only because I've selected the free tier template up above. The database instance identifier can be changed. Here it's been set to database-2, and I'm going to leave it as such. The default master username is admin, so I'm going to specify and confirm the password that goes along with that for SQL Server. Then I'm going to continue scrolling on down below where the storage is set by default to general purpose SSD. We could change that if we had a more stringent disk I/O requirement. We might use provisioned IOPS. We can see the size that's allocated and the maximum threshold and the ability to auto-scale the amount of storage capacity. Scrolling down, the connectivity area allows us to define a VPC into which this database instance will be deployed. Under additional connectivity configuration, if we scroll down, we can see that we can turn on public accessibility, which I will do here to allow direct access from the internet to the database instance. Now, you might choose no for security reasons and instead have an EC2 instance that perhaps serves as a jump box or is only accessible through a VPN before allowing access to the database. But in this testing case, public accessibility set to yes will work. There's also the default security group to control traffic flow. And down below, we can see, of course, the standard SQL port of 1433 for Microsoft SQL Server. Microsoft SQL Server supports authentication via Windows, so we can choose an Active Directory instance if we've got one deployed here in AWS. If we don't have one, there is a link to create a new Active Directory instance, depending on the type that we want. So I'm going to go ahead and close out of that. We're not going to do that. Under additional configuration, we'll have options related to things like backups that are automated by default, some performance metrics, and also some logging and monitoring options. And we could enable deletion protection, essentially make the database read-only unless we otherwise decide we want to come in and turn that off so we can actually delete it. So we're talking about here preventing accidental deletion, not just writing to the database. Once I'm happy with my selections, I can click Create Database to deploy Microsoft SQL Server here through Amazon RDS. And we can see it's in the midst of being deployed. And if we scroll down, we can see it's SQL Server Express Edition, and we can see the status is that it's currently creating it. Now we can select that database by clicking the radio button on the left, and from here we'll have a number of actions. Now a lot of these are unavailable only because the database is in the midst of being created. We can stop the database if it's not being used, reboot, delete it, take a snapshot. For safety purposes, you might do that before you apply an update or you make a major configuration change. And we can also restore to an earlier point in time. After a few minutes and clicking refresh, you'll see that the status of the SQL deployment is now available. And so now if we select it and we go to Actions, we'll just have to refresh once again. And I'll click on the link for the database identifier. So from here, we can go to Actions, and now the items are available. We can also modify the configuration. And as we scroll down, we can see the endpoint, which I'm going to copy because I want to connect to this database deployment in the cloud because public accessibility was set to yes. I want to connect to it over port 1433 from on-premises using Microsoft SQL Server Management Studio. So here in SQL Server Management Studio on-premises, I'm going to paste in that endpoint in server name. The authentication type is SQL Server, and I'm going to specify the credentials that were put in when we deployed this through RDS. After which I will then click the Connect button. And after a moment, we can see indeed that we have made a successful connection into our Microsoft SQL Server RDS deployment in the AWS cloud, where we can begin working with database objects in the Object Explorer. So we could drill down under the database, We could also go down under security, and we can make changes as needed. Amazon RDS supports Oracle Database. To get started here in the Amazon RDS dashboard, I'm going to click the Create Database button on the right, where down below I can select Oracle from the available database engines. And when I do that, I can see a variety of different types of editions, some of which support BYOL, Bring Your Own License. So for example, Oracle Enterprise Edition, we can select the specific version from the drop-down list, and right down below that we can see it says license, bring your own license. Whereas if I choose some other ones, they will also support that option, or there might be a drop-down where you can select license included and pay for that as well here in the Amazon Web Services Cloud. So in this case, I'm going to select the Oracle Standard Edition 1, and I'm going to choose license included down below. From the templates, I can choose production or dev test. So for example, because I don't need the utmost in high availability and performance, I'll use dev test. Now notice, unlike some of the other database engine types, there is no free tier template to select from. So I'm going to go down and specify the master password for the default admin username. And then I'll just scroll down where I can choose the appropriate DB instance sizing to accommodate the database workload. So I'm going to make a selection based on the number of virtual CPUs and the amount of RAM I need. So I'll choose something here. And I'll scroll down where I can make changes to the storage type. So for better disk throughput, I can choose provisioned IOPS, but for testing purposes, I'll leave it on general. The allocated storage is set to 20 gigabytes with auto scaling and a max threshold of 1,000 gigabytes. I'll accept those defaults. I'm going to leave the availability and durability to do not create a standby instance, although we could do that if we're going to use this in a production environment for high availability, and that's part of a multi-availability zone or multi-AZ deployment. I have to select the VPC into which I want to deploy this Oracle database, and down below, I can expand additional connectivity configuration to make this publicly accessible. I'll leave it on the default of no. We can also select the security group, and finally, notice the default port number here is 1521. Under additional configuration, we can specify the initial database name, and as we go through, we can see the standard options here in RDS for automatic backups. We can enable encryption for data at rest, and also we have some performance metric options and logging options. So we can see the estimated cost here. So at this point, I'm going to click on the Create Database button to launch this Oracle database instance in the AWS cloud. So now that our Oracle database is established, we can see the status is showing now as available. And we can select the database and click Modify to make changes to the configuration, such as the licensing config, whether it's license included or BYOL, bring your own license, as well as the database instance class, multi-availability zone deployment, and so on. Now, if we cancel out of those modifications, under the Actions menu, notice we can stop, reboot, delete, take a snapshot of the database, or restore to an earlier point in time. Now, the other thing to bear in mind is that if we go back to our list of databases in RDS, do this again and click directly on the link for the database identifier, it takes us into the summary information as well as the tabbed details listed down below, including the database endpoint. We can see the database endpoint listing on port 1521. So there are a variety of tools that you might use to connect to and manage your Oracle database deployment in AWS. You might use, for example, the Oracle Enterprise Manager Database Control web-based GUI tool. Amazon Redshift is a cloud-based data warehousing solution. What does that mean? Well, data warehousing is used when you need to ingest many different types of data from a multitude of different data sources all together to analyze it as one to derive business value and insights from that analysis. That's what Amazon Redshift is about. Now, this is a petabyte scale type of solution. Now, a petabyte is a big amount of data. 1 petabyte equals 1,000 terabytes. So this is definitely well suited for big data analytics. Redshift is based on PostgreSQL. It supports massive parallel processing. Parallel processing means that we've got multiple cluster nodes working together to analyze data. So it's used for data analysis and also supports very fast querying. That's what Redshift is designed to do. So Redshift is a warehouse solution in the AWS cloud. It's designed for big data, large-scale data storage and analysis, and you can migrate data into Redshift using the copy command. Now you can bring data in from other solutions like Amazon EMR. This is Elastic MapReduce, another cloud-based data analytics solution. You can bring data in from the NoSQL DynamoDB type of database, or S3 buckets, even via remote hosts through an SSH or secure shell type of connection. You can also ingest data in terms of streaming data via Amazon Kinesis Firehose. So remember that a data warehouse is a centralized way to bring multiple disparate data sources together for analysis, and this is where we can get that data. Now, we use Redshift node types to determine the type of performance that we need. Think of it as the EC2 instance type. So we've got scalable storage, RA3, as a node type versus fixed storage, DC2. Scalable storage, RA3, is more expensive because of its scalability and also its better or superior performance compared to fixed storage. The other thing to consider is how external data can get into S3 to be consumed by Redshift. Now, we can use the PostgreSQL psql command or the MySQL dump command, or we could use a multitude of other solutions like exporting to CSV or JSON file formats to get data from different sources into S3, and then, of course, bringing it from S3 into Redshift for warehousing and data analytics purposes. Now, in order to manage and work with Redshift, you need to connect to the Redshift cluster. You can do that in many different ways. You can use the built-in query editor in Amazon Web Services. You can use tools commonly used in the PostgreSQL community like pgadmin and psql to connect to the cluster, or tools like SQL Workbench J. And when you make the connection to the Redshift cluster, you do this using the cluster connection string. Now, if we were to copy data from S3 to Amazon Redshift, we would use the copy command, and the syntax would look like this. We would specify copy, specify the target table name in Redshift, and then use the from directive and specify the source. In this case, we've got S3 bucket 1 transactions, and then we can specify the IAM role. Now, the IAM role is required in order for the copy command in Redshift to have permissions to read items outside of Redshift. So by doing this, we would be ingesting bucket 1 transactions from S3 and putting them into Amazon Redshift. Amazon Redshift is a managed solution in the AWS cloud that's used for data warehousing. So it works by having a cluster of nodes working together that result in very fast querying, which really lends itself nicely to data analysis. Now let's get started with this in the management console by searching for Redshift, and then I'll choose Amazon Redshift from the list, and that takes me into the new Amazon Redshift console where I have a Create Cluster button, which I will click. Now, the first thing to note at the top is that we've got a button to calculate the best configuration for your needs. So it really depends on the type and amount of data we'll be ingesting and the type of analysis that should be performed on that data. I'm going to click that button, and from here, we can find the best cluster config to suit our needs. First of all, we're asked what the compressed data size is. Now, of course, we can specify the unit of measurement, so maybe I'll switch it to gigabytes. And as I drag the slider up, it allows me to then select the appropriate configuration. So for example, here, DC2.large would provide the best throughput and the best cost for our needs. If we were to choose something a little bit different, so if I were to switch it to terabytes, then we get a different recommendation. Of course, we get the pricing that goes along with that as well. So we can use this to select the appropriate configuration. So I'm going to select the one that was originally recommended. So DC2 now is selected. So it's got high performance with fixed local SSD or solid state drive storage. We can select from a couple of variations that are available here. So I'm going to leave it at the default selection, and I'm going to scroll down, and we can determine the number of nodes that we might want within our cluster. I'm going to kind of reduce that to a value of 2. We can see our configuration summary listed below. So we have a cost on a monthly basis. And as I scroll even further down, we can see the cluster identifier. The database port number, 5439, is what's used by Redshift. We can see the master username. It's AWS user, so I'm going to specify the master user password. Down below, under cluster permissions, I can select up to 10 IAM roles that will allow this cluster to have permissions to the appropriate AWS resources. For example, if it needs access to S3. So we could specify the roles and then click Add IAM role, so we can see that's been assigned. Down below, under additional configurations, use defaults is turned on, so we can see the network that this will be deployed into, the backup options, security, and so on. Now, if we wanted to make a change, let's say to security, maybe to enable encryption, then we could turn off use defaults, and we could go down under the appropriate option. So for example, let's see, under database configurations, encryption is currently disabled. Well, we might use AWS Key Management Service. So from there, we could use a key that we might have defined from our account. However, I'm going to go back to simply using the defaults for the configuration of this Redshift cluster. And I'm going to click the Create Cluster button in the bottom right. Looks like we have an error. I think that would result from when we turned off use defaults and had turned on encryption but not specified a key. So I'm going to disable encryption. And let's go down and create the cluster. This time, it's on its way. It's being provisioned now. We can see it's now in the midst of creating the Redshift cluster. Now from the Redshift dashboard, we can see that we've got one cluster that's available. Of course, we can click the clusters view on the left, and we can see our Redshift cluster again is listed here as available. We can see CPU utilization is up and that we've got one snapshot. If I click directly on the link to open up the details related to that Redshift cluster, we've got some query monitoring here. Remember, the purpose here is really fast querying. However, we could also go to properties. So I click on the properties tab area. Here we can see things such as the endpoint to make a connection to the cluster. We can also see the cluster details, so the node type and the number of nodes. I can even scroll down, and under the database config, I can see the port number and the database name, which in this case is dev. And the great thing about this is that you need to work with this in terms of creating tables and populating them with data, such as from an S3 bucket, and then you can start taking advantage of querying directly here in the console in the query editor. So if I click the editor link over on the left, from here I can start specifying queries that I might want to run. Now the other thing to bear in mind is that if you've not yet connected to a cluster, then you can specify that you want to connect to it by specifying the name of the database and the default username, AWS user, and so on. I've already connected when it initially asked me, but I can click the Change Connection button in the upper right where I can tell it the name of the cluster, the database password, and so on that I want to use to make a connection to the cluster with. In this demonstration, we'll bring some data into a Redshift cluster and we'll query it. To get started here, I'm going to go to a tutorial from Amazon Web Services documentation where in step 6, it refers to a download file. It's a zip file that you can download, unzip, and then place in S3, which I've already done. So in S3, I've got a bucket named bucket YHZ where I've got this text file that is a part of that sample data that we're going to feed into our Redshift cluster. Now, to do that, we have to have a place to accommodate that in Redshift. We have to build a table. So you have to know the structure of the data. So back here in my Redshift console, where I can see my cluster is listed and available, the first thing we should be aware of is that we can select the cluster, and from the Actions menu, we can choose to manage IAM roles. Now that could be important if the cluster will need to talk to other external data. So here under Manage Roles, I've got a custom Redshift role that's assigned here. And actually, if we go into the IAM Management Console, which I've got open in another window, I can filter for Redshift. And here's my Redshift custom role. And the only attached policy here is Amazon S3 read-only access. Of course, up at the top, we can see the role ARN. We can see the AWS resource name for it. I'm going to copy that because I'm going to need that to copy the data from S3 into a table in the Redshift cluster. So I'm going to copy that role ARN. Let's go back to the Redshift cluster. Specifically, actually, I'm going to click on the editor on the left. I've already made a connection to the cluster. So from here, I'm going to start by creating a table. So I'm going to use the create table command to create a table called sample users, where I'm defining all of the columns and their data types, such as character and the lengths of them, all the way down to the bottom, where I close it off with a closing parentheses because we have an opening parentheses up here at the top after the name of the table. And then, of course, we have a trailing semicolon. So I'm going to click Run to run this query, which isn't really querying data, but rather creating a table. And after a moment, if I scroll down, we can see the query results down here. It was completed. So the table has been created. I'm going to click Clear just to clear out all of that information. And at this point, we now need to copy data, the sample data from our S3 bucket, into the newly created table. So my statement will be copy sample users, that's the name of the table we want to copy into, from, and then I'm going to specify my S3 bucket and file name. And I'm going to use the credentials clause here, and I'm going to give it the ARN of my Redshift custom role that we looked at in the IAM console. I'm setting the delimiter to a pipe and the region to US East 1. So let's go ahead and click Run. This is going to take a little bit longer since it's going to populate our sample users table with all of the data from that sample text file. After a moment, if we go down and look at the query results, we can see it completed. So we've now got some sample data that's been copied into our sample users table. When we look at the sample data file, we can see that there are some users from the state of Texas. So the 2-character code being TX. So we're going to query on that. So my query is going to be select, and I want to see the last name and the first name columns from the sample users table where the state equals TX for Texas. So I'm going to go ahead and click Run to run that query. And we can monitor the result of that query, of course, and see the results once it's completed down at the bottom under Query Results. And before you know it, we'll have our return results of user information, last name and first name for the state of Texas, which was run against our Redshift cluster. Amazon Web Services supports both document as well as key-value NoSQL databases. So document and key-value databases come in the form of DynamoDB and DocumentDB. DocumentDB and DynamoDB support document-style databases. Now, what does that mean? What is a document when we say that? A document is a set of key-value pairs. The operative word here is set. It's not a single key and value pair, but rather a set or collection of them together in a document. Multiple documents, which you can think of as records, are called collections. So those are stored in tables. So stored documents then can be stored as XML, JSON, or BSON. BSON is simply a binary version of a JSON text file. Now, key-value type of NoSQL databases are much simpler, and that would come in the form of specifically DynamoDB as an option within Amazon Web Services. It's a simple, single key-value pair, the operative or keyword here being single, whereas with a document-based database, it's a set of key value pairs. And notice, DynamoDB supports both simple single key value pairs as well as document or sets of key value pairs. So it's designed to be very fast for read and write operations. However, it has limited querying options compared to a document type of solution. So you would use simple key value type of NoSQL database solutions for simple uses like shopping cart apps or user session data as they connect to a web-based application, for example, from a mobile device. The DocumentDB is a NoSQL solution, and it's compatible with MongoDB. DocumentDB clusters share a cluster volume. That's where the data is actually stored. All of the nodes have access to it. Now, in a DocumentDB cluster, you will have a single primary instance, and then you'll have up to a max of 15 additional cluster nodes in the DocumentDB cluster. Those additional nodes are only read replicas. So the primary instance then supports reading and writing. So you want to make sure the primary instance then is available and geographically as close as possible to where the data will be written into the cluster. The other read replicas can be placed where you suspect you're going to need to read that data. DocumentDB uses semi-structured data storage, and because it's a NoSQL type of database, that's in line with the fact that NoSQL databases don't have a schema, or if they do, it's a loose schema as opposed to a rigid one used by SQL type of solutions. So it's good for social media feeds, mobile app data storage, and product catalogs, to name just a few uses. The next thing that's important to know about DocumentDB is that storage and compute aspects of it are separate. They are independent, and as a result, each can be scaled independently of the other. So there's a lot of flexibility and power, while at the same time reducing costs. The maximum amount of storage with DocumentDB is 64 terabytes. It's designed to be highly available by replicating across up to 3 availability zones, and it also is highly available because there are automatic backups that get stored in S3. On the security side, TLS or transport layer security is used over the network, and encryption of data at rest is applied using AES 256-bit encryption. Now, DynamoDB is a managed scalable database service where backups are sent to S3, but it supports what are called WCUs. These are write capacity units. It also supports RCUs. These are read capacity units. So what happens is that RCUs and WCUs need to be reserved when we want to have read and write activity to and from DynamoDB. And these charges are incurred on an hourly basis for the throughput capacity that was reserved. Now, even if that throughput capacity was not used. In this demonstration, I'll be using the AWS Management Console to deploy a DocumentDB cluster. So to get started, I'm going to search up the word document, and then from the resultant list, I'll choose Amazon DocumentDB. We don't have any clusters yet, so I'm going to click the Create button over in the upper right to do that. I need a cluster identifier that's unique, so I'm going to call it docdb-app1-cluster1. I can choose the instance class, which controls the underlying number of vCPUs and RAM, which need to support the workload in the cluster. So in this case, I can choose something different from the list, but naturally, as the number of vCPUs and RAM increases, so does the cost. So I'm going to leave that selection as it is, but I am going to reduce the number of instances or nodes in the cluster from 3 down to 2. For authentication, I'm going to specify a username of C. Blackwell. Don't use words like admin, since that has special meaning to the cluster engine and it won't allow you to do it. I then need to specify and confirm a password. And then down below, I can choose to show advanced settings if I want to control things like the network placement, so the VPC that this is deployed into, and the security group, firewall allow rules. Here it's selected the default VPC security group, and cluster options like the port number, whether Data at rest is encrypted, backup and logging, and maintenance options. Now I'm okay with all of these settings, so I'm going to go ahead and click Create Cluster. We can see now the status says creating. So I'm just going to wait for a minute or two, and I'll keep clicking the refresh button until such time the status is that the cluster is ready, it's available. Okay, we can now see the cluster is available. I can select the radio button to the left of the cluster, and under Actions, I can stop the cluster, modify configuration settings, I can add instances, I could even configure failover for high availability. Here it says that failover will promote the read replica with the highest priority, that's the lowest numbered tier, like tier 0, to a primary. However, I'm going to cancel that. I'm not going to do it. We can click directly on the cluster identifier as well to get some details, including what you would need if you wanted to make a connection to the cluster. So for example, if I wanted to use the Mongo command line tool, here we've got the specific command to connect to our cluster using the user account that we specified upon creation, although the password isn't shown, for security reasons. We can also go to the instances view and see the instances that are available within the cluster. We asked for 2 nodes or 2 instances, so here they are. One has the role of writer, the other the role of reader. We can also see the status of each individual instance shown here. Now, if we click on any one of these individual instances, we can also see that we've got the string that's used to make a connection as well. So here using the Mongo shell, we can see it's listed here as well as connecting with an application. So if we want to make a connection in any way to populate the database and begin working with it, we have the information required to do that. In this demonstration, I'll deploy DynamoDB here in the AWS Management Console. So I'll start by searching for Dynamo, and then I'll choose DynamoDB. Normally, developers will access DynamoDB and populate it programmatically because DynamoDB is a NoSQL type of database that really works well. It scales well when it comes to working with big data. So I'm going to go ahead and click Create Table. Table here is going to be called Customers. The unique partition key item that will distinguish one row from another, let's say, will be Customer ID, which I'll leave as a string value. You can also set the partition key to a binary data type or numeric. Now down below, I'm just going to scroll down and click Create. And after a moment, we'll see that it's creating our new DynamoDB table called Customers. And after a moment, our Customers table exists. So we've got a number of options that we can configure up at the top, such as backups. Now it says backup is being enabled for the table, and that's because it's newly deployed. So it'll take a moment for that to become an option that we can actually make a change to. Then we've got capacity, where we can specify what kind of capacity units, read and write capacity units, should be specified. And this really is a measure of throughput related to the database. If I go to items, here I can create an item. So it knows that customer ID is our current partitioning item within this table, but we can also add multiple items. So for example, I can append a string, let's say lname for last name. So maybe for the customer ID, we'll have 1, 2, 3, and for the last name, we'll specify Jones. We'll click Save, and we can see that that item has been written here in Document DB. The Elastic Transcoder service in AWS is all about video processing in the cloud. So essentially, it's the manipulation of source media files to result in some kind of different output media file. And we would do this so that we could allow for the playback of media on a wide variety of devices, where we could modify the size, the type or file format of the media, and also the quality in terms of audio and video. There are many different types of target formats that you could use with Elastic Transcoder, some of which include MP4, FLAC audio, animated GIFs, MP3s, H.264 audio and video, and many other formats. To work with Elastic Transcoder, you need a transcoding pipeline, and you also need 2 S3 buckets, as seen here in our diagram. On the left, we've got a source input S3 bucket where the source media files would exist. Now we then configure our transcoding job. So what we do is we create a new pipeline and we specify options such as the source input S3 bucket. We also can specify details like if we want to use watermarks or enable closed captioning and create thumbnails. And in that creation of that pipeline, we specify the target S3 bucket where the result will be stored. Now you're also going to need to set up an IAM role that has permissions for S3 as well as to create transcoder jobs in the pipeline. Now you could also take this a step further if you really wanted to and create a Lambda function that might be triggered when transcoding is complete. This way, users can access the content immediately. So when you're configuring the transcoding job details, you can use from AWS presets, or you can even generate your own custom presets that have details such as watermarks being enabled, closed captioning being enabled, target format, and so on. In this demonstration, I'm going to use the AWS Management Console to work with Elastic Transcoder. The first thing I'll do is create a pipeline, and then I'll create a job in the pipeline to convert a video file to a different output format that gets stored in S3. So to get started here in the Management Console, I'm going to search for transcoder, and there's the Elastic Transcoder. I'm going to go ahead and click on that to open that console. The first option I'm presented with is the ability to create a new pipeline, and this is the first thing that we need to do. So I'm going to choose Create a New Pipeline, and I'm going to call it Pipeline 1. Now you can create multiple pipelines to handle jobs, and you might even have one pipeline used as a high priority one for last minute transcoding jobs that absolutely need to be processed immediately before lower priority jobs. But here we're going to go with just a single pipeline, and I'm going to call it Pipeline 1. I then have to specify an input bucket where I want to retrieve media from that will be placed into the pipeline. I'm going to choose an existing S3 bucket I've got called Bucket YHZ. Then the next thing I'm going to do is go down and specify the output bucket, which in this case I'm going to choose as the same one. So we're reading media, for example, video files or audio files from an S3 bucket, creating a job in the pipeline and converting it to some other format, and then storing it in an S3 bucket. In this case, it's the same S3 bucket for input and output. So for the storage class of resultant output, I'm just going to use standard within S3. Then I can determine where I want to store thumbnails. Well, I want thumbnails generated for any videos that get converted. That is an option that you specify within the job, but for now I'm going to specify the same bucket, and I'm going to choose a storage class for storage of the thumbnails to be standard. Unless they're not considered crucial at all, then I might even choose reduced redundancy to save on costs. Then I can determine if I want notifications about job items, such as the job progressing, or warnings, completion, or errors. So I can create or use existing SNS topics for those notifications. I'm not going to configure them. And also I can determine whether I want encryption to be used. So I'm just going to leave it on the default, and I'm going to choose Create Pipeline. So we now have a pipeline. And if I just click over here on the left and go back to the pipelines view, there it is, Pipeline 1. So I can select that, and I can create a new job in that pipeline. I could also create a new job, of course, by going to the Jobs view and creating a new job from it. Over here, we've got a number of different presets for a variety of different types of media formats. And we do have the option of creating a new custom preset if we feel the need to do that, where we can specify that we want thumbnails generated and the specific codec that we want to use, and the number of frames between keyframes, all of these details, and the output bitrate for quality. We can select this in a custom preset. However, in this case, I am not going to do that, so I'm going to click the back button in my browser. I'm going to go back to Pipelines and select Pipeline 1 and choose Create New Job. So the job is what actually has the details about the media that's going to be converted. So Pipeline 1, I'll choose from the list. I can then specify an output key prefix. For example, when I click there, it knows that the bucket I've selected for Pipeline 1 has a couple of folders like vids. So I'm going to put in vids/ as the output key prefix of where I want to store output. Then I can specify the input key. Now I've got a video in the vids folder in my S3 bucket called demo_video.wmv. That's what I want to convert. So down below, I'm not worried about decryption because it's not already encrypted, the source media file. I don't want to add any captions or I don't want to clip any portion of the video, so I'm not going to turn those items on. And notice I could add other inputs if I have multiple items I want converted here in this job. Then I can choose a preset for the output, and this is where our custom presets will also show up. So for example, if I were to choose a system preset of iPhone 4S, then the output key is the output file name. Maybe I'll call it demo_video, and notice that there's a note that recommends the file extension be set to .mp4, which I will specify. I'm going to tell it I do want to create thumbnails, yes, and the thumbnail file pattern, let's say, will be demo_video, and we can see that the first thumbnail would be called demo_video-00001.png, just so we get a sense of the nomenclature. That's fine. I don't want encryption for thumbnails. I don't need to rotate the video. There's really nothing else that I need to do here. Maybe I'll go down actually and specify a watermark. You can have a watermark superimposed over video, maybe for legal reasons, such as the protection of intellectual property, or maybe it's only a sample video. So I'm going to choose top left, and I'm going to select a file I've got already stored in my S3 bucket called logo.jpg. So I'm going to go ahead and do that, and at this point, we're good to go. So I'm going to click Create New Job in the bottom right. Now what I'm going to do is go back to the Jobs view, and I'm going to click the Search button at the top. Of course, I'll have to select the pipeline I want to search in for jobs. And we can see that the job is listed here in a pipeline. The pipeline ID has been assigned automatically by AWS, and that the status is currently set to Progressing. And depending on the size and format selected for the output transcoded video will determine how long it takes for the status to say complete. Let's go check our work in the S3 bucket. I've opened a new web browser window and navigated to the S3 Management Console, where I'll open up the bucket in question, the one we specified with the pipeline. That's bucket YHZ. Click that. There's the vids folder. And if I scroll way down, I can see the original source video, demo_video.wmv, but I can also see the MP4, and I also see all of the thumbnails, the PNG files. I can click on them and open them up to get a sense of what those files look like that were generated as a result. And let's actually go back and let's click and download the output file to see if the watermark has been inserted in the upper left. Click on it to open it. I'll click the Open button. And we can see that our logo has now been inserted in the upper left. Amazon Kinesis is a real-time cloud analytics service. It's designed to bring in data in real time, so data stream processing, and with real-time collection and analysis of data, we have the ability to allow decision makers to more quickly be informed to make good decisions. Now, this data can come from many different sources, including social media feeds, financial transactions, or it could be the result of click data from a website based on where users click and what they visit when they are on a given website. Kinesis can use many different types of source input locations, including Kinesis data streams. This means that we would get large amounts of data records that are provided to Kinesis in real time, or Kinesis data firehose. This can be used so that we can take streamed data and write it to storage locations like Amazon S3 or Redshift. Kinesis data analytics can also be used for the processing and analysis of data using SQL. And there's also Kinesis video streams, which can be used to stream video from a variety of different types of devices for analysis. Amazon Kinesis begins with data providers. Now, this results in data records. And as this data is streamed into Kinesis, it's distributed into what are called shards. And a shard is used as a throughput unit of measurement within the Kinesis data stream. And you can always increase the amount of shards in that stream. Kinesis uses a cluster of instances to handle the data collection and the data processing. And the resultant output is stored in an S3 bucket. Now, you could even have S3 bucket results that are triggered through an AWS Lambda function. So, for example, the Lambda function might be responsible for transforming data from the original input format to some target format. In this demonstration, I'm going to use the AWS Management Console to create an Amazon Kinesis stream. Now, as is the case with some of these AWS services, creating the component, such as the Kinesis stream, is really only a part of it. The next part would be developers writing code to put data into the stream, and then also writing code to read data from the stream. So let's get started here. In the console, I'm going to search for Kinesis, and I'll click on the Kinesis search result. Then I'll click the Get Started button. Now we have a number of different types of streams we can work with. A data stream, which ultimately we will do. A delivery stream, so we can store the resultant information fed into the stream to another location. Now remember, the purpose of Kinesis is really to collect data and then to process and analyze it, ideally in near real time, if not in real time. So we need to store that resultant information in another location, such as Amazon Redshift or Amazon S3, as it says here. We can also create an analytics application or a video stream. For example, if you want near to real-time facial recognition for video surveillance, as an example. So I'm going to click Create Data Stream, and I'm going to call this Data Stream 1. Now, down below, I can specify a unit of measurement called a shard. For example, if I put in a unit of 3 shards, then I have 3 megabytes per second of write capacity, which turns out to be approximately 3,000 records per second that can be written into the stream. And we have approximately 6 megabytes per second of reading. So I can always adjust that later, but I'm going to go ahead and stick with that, and I'm going to click the Create Kinesis Stream button in the bottom right. We can see that the stream is in the midst of being created, and it does say it can take up to a minute or so until it's ready to work with it. So we can now see that the stream has been created. The status has now switched to active. So if I were to click directly on the data stream as an example, we can see that it is active. And if I were to go, let's say, under monitoring, here I get statistics about this data stream. I'm particularly interested, let's say, in the put record type of metrics. Now, these would start to jump up as developers write code that start feeding data into the stream. Now, the code would normally run within an EC2 instance, and the developer would also have a config file in the instance with AWS credentials so that that software can write to the stream. Elastic MapReduce clusters are collections of Linux instances. Now, these would not show up if you go to the EC2 console, but they're EC2 Linux instances that you can get into using SSH if you need to manage them. Now, the cluster for Elastic MapReduce exists for data analysis, especially of large amounts of data, big data. So in this demo, we're going to deploy a MapReduce cluster. To get started, I'm going to search for MapReduce, and we can see EMR, Elastic MapReduce Managed Hadoop Framework. I'm going to go ahead and click on that to open up that console. And I'm going to create a cluster by clicking the Create Cluster button. Now, let's say that this is going to be for pharmaceutical applications. So I'm going to call it Pharma App 1. Next thing I'm going to do is go down below, scroll down further, and I'm going to specify that I only want 2 instances available in this EMR cluster. We can also select the instance type depending on the workload that needs to be supported. So just like with the normal EC2 instance, you want to carefully select the instance type so that it supports the workload properly but doesn't have too much power that isn't being used, which means you would incur additional costs. I'm going to scroll back down even further, and down under Security and Access, we can choose a key pair that would be used, for example, for authenticating to the Linux instances. So I'm going to go ahead and select that from the list, and I'm going to choose Create Cluster. We can now see our cluster, Pharma App 1, is now starting. So we can see some details here, such as going to the Hardware tab in the cluster and seeing the current state of the two cluster nodes. We can see the two instances are in a status of provisioning. We can click Refresh to keep track of that. We can see, of course, the instance types shown over here on the right. We can also monitor activity related to this at the individual node status or at the cluster status. We can also view I/O details related to the cluster, the EMR cluster. And we can also go to steps. You add a step to the cluster when you want to pass it some activities that need processing. For example, I might pass a Hive program here that I've got stored in S3, so I've got an input location. I can also specify where the resultant output should be after performing data analysis. I can pass any arguments that might be required by the Hive program that I'm submitting here for data analysis in the cluster. And I can also determine what the action on failure will be should that occur. So just continue, cancel and wait, or terminate cluster. Amazon Recognition, that would be with a K as opposed to a C in the word recognition, is all about facial analysis in images as well as in videos. And there are obvious benefits for law enforcement, airport security, but also from a marketing perspective, perhaps determining people's emotions based on uploaded pictures. Here we're looking at the API reference for Amazon Recognition. Developers can go through the API reference. For example, I can click on Compare Faces, and here we can read up on what is required to make an API call or a request using JSON syntax. Of course, the resultant output will also be JSON. We can see the response syntax. Now let's close that down. Here in the AWS Management Console, if I search for recognition with REK as opposed to REC, we can select that from the list and we can look at some sample methods of using recognition for facial analysis. So for example, I can click the facial analysis item on the left where we've got a sample image of a woman, and using API calls, it's been determined that it looks like a face, 99.9%, appears to be female, age range 17 to 29 years old, which looks about right. The person is smiling, appears to be happy, but you can also upload your own image. When you do that, it will perform an analysis, and we can see here that it looks like it's a face, appears to be female, between 1 and 7 years old, not smiling. Well, that one is a little bit off. This is 99.7% not smiling, when in fact, it does look like the little girl is smiling. Appears to be calm, 98%, and not wearing glasses. This is the kind of stuff that can be analyzed using the Amazon Recognition API. You can also do other things like celebrity comparisons. So here we see Jeff Bezos, and we can see it's a 100% confidence in a good match. We can also do text in an image. So we can take a look at any text strings that might be existing within an image file. And also you can perform a video analysis. Now when you do a video analysis, you can go through and determine objects that are in the video, activities being performed in the video, and also determining who is in the video. As the name implies, Amazon Elasticsearch is a searching mechanism in the cloud where developers can make API calls, so for example using Node.js, or you can use the Linux curl command, which is built into the Mac OS and Linux, to upload files to an Elasticsearch domain. Now you upload files and they get indexed so that the result is searchable. And you would upload these files, for example, even using the built-in Linux curl tool, which you can also download and run on Windows, using an HTTP put verb. Now what happens is that the indexing results in a JSON document. So let's go and set up an Elasticsearch domain here in the AWS Management Console. I'm going to search for Elastic, and immediately I see Elasticsearch Service. I'm going to go ahead and click on that. I'm going to click Create a New Domain. Now I get to determine the type of deployment that I want to create for my Elasticsearch domain, whether it be production or development and testing, custom. I'm going to choose development and testing, and I'll leave the default Elasticsearch version to 7.1, and I'll click Next. I have to give this Elasticsearch domain a name, so I'm going to call it Quick 24x7 Search. And then I have to specify the instance type and the number of nodes that will support my Elasticsearch configuration. So as is the case with EC2 and also other types of clustering solutions like Elastic MapReduce, take care when selecting the instance type to make sure you select one that is powerful enough to support your needs, but not overly powerful where you have exorbitant charges that are not necessary. Same goes with the number of nodes. I only want one node to handle this for testing purposes, but if you're going to use an Elasticsearch domain on a larger scale for many concurrent type of searches, then you might want to start bumping up the number of nodes as required. Down below, the data nodes storage. I'm going to leave it on the default of EBS, general purpose, and the storage size per node. So 10 gigabytes is the value there. I'm going to leave that. I'm not going to have a dedicated master node because I only have one node in my Elasticsearch cluster. And I'm going to make sure I leave the default for HTTPS required as encryption when communicating with the Elasticsearch service. And then I'm going to click Next. Now from here, we have to think about how we want to use this Elasticsearch domain. Where will searches be conducted from? So it can be VPC access or public access, such as over the internet, which is what I'm going to select in this case. Now we can enable authentication or we can leave it open. So for example, the access policy down below has a drop-down list where I can choose the appropriate item based on my needs. In this case, I'm going to allow open access to the domain, full open access. I'm going to choose I accept the risk. This is for testing purposes only, and I can see the access policy here is set with an effect of allow, where the AWS principal is asterisk, and all actions are allowed. So we can see that that is shown here for Elasticsearch, for ES. So I'm going to go ahead and click Next, and here we have a summary of our choices, which I'm going to accept, and at the very bottom right, I'm going to click Confirm. So now that my Elasticsearch domain is now shown as active, I can see the endpoint, which I'm going to copy to my Windows clipboard. Now here in PowerShell on my on-premises system, I can put data into my Elasticsearch domain to generate an index using the PowerShell invoke-web request commandlet. You could do it with a number of other tools like Kibana, which we'll take a look at in a moment, the GUI visualization tool, or even the built-in curl command, curl, for Linux and Mac OS. So here what I'm doing is with the use basic parsing parameter, I've passed it my endpoint that I just copied from my Amazon Web Services Elasticsearch domain. And after it, I've added the name of the index I want to create called sample index. And then I'm creating a sample data type. The method I'm setting is HTTP post, so just post. And I can see the content type I've set with -content type is application/JSON. And then the body parameter within the curly braces contains what I want to actually write up to my Elasticsearch area. So this is the data that will be indexed. User is test1. I have the post date. And I have a message that contains the text Elasticsearch test. So I've pressed enter and we get this returned information below. So we know it's been submitted to Elasticsearch. And back here in the console, we were looking at the overview of our Quick 24x7 Search Elasticsearch domain. If we go to the Indices tab to view all the indexes, we might have to refresh, but we're going to see that we have beyond the default, which is always there, .cabana_1, I've got my new index, sample index 1. And if I look at the mappings, here we have message, post date, and user. That matches the body information that was written up into the Elasticsearch domain. Now, if you go to Overview, you'll also notice that you've got a link for Kibana. Kibana is a tool that's designed to work with Elasticsearch. It's more of a GUI web-based visualization tool. So I'm going to go ahead and click the link for Kibana. Now that's going to take me into the Kibana interface where I can begin working with any indices that are a part of my Elasticsearch domain. So if I scroll down on the Kibana page just a little bit under Use Elasticsearch Data, I've got a link to connect to your Elasticsearch index, which is what I want to do. So I want to make sure that I can find our sample index. Here is our sample index. So I'm going to go ahead and click Next Step. Now it knows in the index I've got the post date item, so I can use that for time filtering, but I can also select I don't want to use the time filter, which I'm going to do, and I'm going to choose Create Index Pattern. And as we scroll down, we can see the post date field, the user field, the message field. So all of this stuff is being picked up from the index from the file that we upload using PowerShell. So now on the left, if I click the Discover icon, the third icon down, we can now see from our connected index from Elasticsearch that we can actually see some of the data. There's user test 1, there's the posted date and the message, which we specified when we uploaded it to Elasticsearch. The message text is Elasticsearch test. Here in a web browser, we can see that if we connect just to the endpoint URL, that we get some returned information for our specific Elasticsearch cluster. So it's up to developers at this point to write code to use Amazon Elasticsearch. Amazon Athena is a big data querying service. It's designed for very fast SQL queries, which could be used for data analysis. The source data can come from a multitude of sources, such as from S3 or from AWS Glue. AWS Glue is a managed AWS service that's designed for data extract, transformation, and loading into other services, where extract, transform, and load is often referred to as ETL. Working with Athena begins with getting data, for example, into S3, and then creating an external table in Athena to house that data, and then writing a query against it. Now, there are a number of big data services available in AWS. Amazon EMR, or Elastic MapReduce, is one that supports developers writing custom code and custom apps, including those related to machine learning, and it's used with streaming data for very large data sets. Amazon Redshift is another big data service comparison item. It's designed for very fast querying that is considered complex, and it brings together data from a multitude of different sources, not only S3. And of course, Amazon Athena is a managed service, meaning we don't have to set up the underlying infrastructure, that supports SQL querying of S3 data. So you might use Amazon Athena, for example, if you have a lot of data coming in from website logs and you want to analyze activity on that website. Amazon QuickSight is a tool designed for business analysts. The first thing we need to do before we can start analyzing data is we need to sign up for QuickSight. So here in the console, I'm going to search for QuickSight. I'll choose it from the list, and that will automatically redirect me to the quicksite.aws.amazon.com URL, where it shows my AWS account ID, and I have to initially sign up for QuickSight. I'm going to go ahead and click that button to proceed with this. And then I'm going to choose the standard edition, and then I'm going to click on Continue. So I've got the QuickSight region selected. I've specified a unique QuickSight account name and a notification email address. I'm going to scroll down and tell it I also want QuickSight to be able to get data from Amazon S3. And specifically, I'm going to select the check mark for a bucket, and then I'll click Finish, and then I'll click Finish once again. And after a moment, I get a sign stating that I've signed up for QuickSight, so I'm going to click the button, Go to Amazon QuickSight. That will take me to the Welcome to QuickSight page, which I'm just going to close, so I've now successfully signed up for a QuickSight account. So now in the future, when I go to the AWS Management Console and search up QuickSight, instead of prompting me to sign up, it's going to know I've got an account associated with my AWS account number, and it's going to take me directly into the QuickSight console. Amazon QuickSight is a data analysis tool that provides visualizations. And after you've signed up for an account, this is the landing page for QuickSight. Now you can launch it from within the AWS Management Console by simply searching for QuickSight. It'll take you here. First thing I notice in the upper right is I can click Manage Data. I can see any existing data sets. Usually these are sample data sets set up automatically when you provision a new QuickSight account. However, I could click the New Dataset button at the top. I could upload a file, such as a JSON file or a CSV file. I can connect to Salesforce. I can connect to an S3 bucket by providing a manifest file of items I want to upload into QuickSight. I can connect to RDS, MySQL. When you click on each of these items, you'll have to specify a way to get the data. So for MySQL, it would be the database server name, the port number, the database name itself, the username, and the password to be able to start getting data. So we've got a number of different types of data sources going all the way down to GitHub, Twitter, Jira, Adobe Analytics, and so on. However, we can also analyze the sample data that is made available by default, which we'll do. So I'm going to click on the QuickSight icon in the upper left. Here we've got, for example, web and social media analytics analysis. This is sample data that's loaded automatically. So I'm going to click on it to open it up. Now, this is what you can expect to see once you start analyzing larger data sets. For example, in this case, we've got visualizations for the number of website page views and visits over time. And this is a good thing in that it's steadily increasing our website audience. We can also look at the unique visits by device type. We can also see mailing list subscription graph information and free versus paid signups, where paid is dark blue and free is a light blue. We can see Twitter mentions and followers. This can be a very valuable way to start to analyze data to make very important informed decisions. But the key, of course, is that we start off with accurate data in the first place. Identity and Access Management, or IAM, is a part of AWS that controls resource access through the creation and management of users, and then organizing those users into groups to facilitate management on a larger scale, and also the creation and management of roles. Now, users and groups pretty much speak for themselves, but what is a role? You could think of a role as being used to allow resource access for a software entity. As an example of this, imagine that you've got a piece of custom code that you've built that's running within an EC2 instance, and that piece of custom code needs to read and write to an S3 bucket. So what you would do then is create a role to allow that to happen and make sure that that piece of code is associated with that role so it gets those permissions. Identity and access management begins with authentication, and after successful authentication, followed by authorization to access resources. Authentication is the proving of one's identity. Single-factor authentication would mean, for example, that we are specifying a username and a password. Now that's two items, but it's referred to as single factor because it's one category, the category being something you know. Multi-factor authentication uses multiple categories, such as a username, a password, and a smart card. So the username and the password constitute something you know, but the smart card constitutes something you have. You must physically possess the smart card in addition to having knowledge of a username and a password to authenticate. Needless to say, multi-factor authentication is considered superior when it comes to security, above and beyond single-factor authentication. We know that authorization occurs after successful authentication. It allows us to control access to AWS resources, such as an app that needs to talk to an S3 bucket. You can also work with policies. In AWS, policies are collections of permissions that are grouped together. For example, a policy that might control management of EC2 instances. Now, you can build your own custom policies, or you can use built-in policies, of which there are many, and assign them to users, groups, or roles so that the permissions are actually effective. Here we have an example of the AWS built-in administrator access policy, which is expressed in JSON, JavaScript Object Notation. So notice that the effect here is to allow, as opposed to deny access to something. The action here is shown with an asterisk, which means all actions are allowed, as opposed, for example, to only allowing the starting of an EC2 instance. And the resource here is also shown as an asterisk. We aren't limiting what we are allowing access to in AWS. So that's why this is the administrator access policy. Access to all resources, all actions against them, is being allowed. Now, there are a lot of built-in AWS policies as well, some of which are shown here. This is only a tiny list. Things like Amazon EC2 full access, to allow, as the name implies, full management access only to EC2 instances. And then there's a policy named Amazon EC2 read-only access, Amazon S3 full access, Amazon S3 read-only access. And then for other aspects of AWS like Route 53, we have Amazon Route 53 domains full access. Then another topic, we have auto-scaling full access. So as you can see, the entire gamut of AWS resources, access to them could be controlled through the use of built-in policies. And if that doesn't suit your need, you can build custom policies. Identity and access management in AWS begins with account requests. This could be automated with your new hire process within your organization, whereby adding a new employee might automatically trigger the creation of an account to AWS technicians, after which the account would be created. The enforcement of user access means controlling things like multi-factor authentication, if it's going to be enabled for user accounts, and perhaps also making sure that users are added to groups, and those groups might be assigned policies so that they have permissions to access resources. The next part of the lifecycle of identity and access management would be the logging, auditing, and reporting on user access against AWS resources. And then there's the inevitable removal of accounts over time when they are no longer needed, such as when a user leaves the organization. In Amazon Web Services, you can create IAM users to allow programmatic access to AWS resources, for example, for developers, or you can build IAM user accounts to allow access to the management console, such as I am doing here. In the upper right, I can see the name I am signed in with, and this happens to be the AWS initial root account, so it is not an IAM user. So to get started here in the AWS Management Console, I'll simply search for IAM and press Enter to get into the IAM Management Console. Now I can see here from the dashboard, which is where I'm placed by default, that I have 0 users, but I do have one group. And if we take a look at the groups, indeed, there's a group named Group 1. But if I go to Users, we don't have anyone listed. I'm going to go ahead and click the Add User button. The first user I'm going to create here is going to be named J Gold. So make sure to adhere to your organization's naming conventions when it comes to user accounts. Now we can click Add Another User, and we can add multiple users on this same interface all at the same time, but I'm going to stick with just adding a single user, J Gold. Down below, I have to select the AWS access type. As was mentioned, we can determine whether we want to allow programmatic access for this account. So it says that if you're going to do this, you need to make sure that the user, in this case J Gold, has the access key ID and a secret access key so that they can access resources using this account. For example, for the AWS API, calling upon resources. We can also, or instead of programmatic access, depending on your requirements, enable AWS Management Console access. This way, the users would need a password along with the username that would allow them to sign in. Now, depending on which policies users are attached to, either directly or through group membership, would determine what they can do once they are signed into the AWS Management Console. So I'm going to go just with that option, the AWS Management Console access, and I'm going to let it auto-generate the password. You could choose custom password if you so wish. Down below, I can also require a password reset upon initial user sign-in. That's a good idea for security purposes. So I'm going to go ahead and do that. I'll click Next. So at this point, the wizard is prompting me to add the user to a group. So I can see any existing groups down below here, but we also have the ability to create a new group. So if I want to add this user to group 1, I would simply put a check mark on it. Notice over in the next column to the right down here where we're looking at the group name, we can see a list of attached policies. Group 1 has the Amazon S3 read-only access policy attached. So by extension, then, our new user that we're in the midst of creating will also have Amazon S3 read-only access. Notice at the top, we can also copy permissions from an existing user. If we have essentially sort of a template in place and we want to copy those permissions, or we can attach policies directly to this individual user account, which can be very useful sometimes. But in this case, I'm okay with my selection, so I'm going to click Next. We can also add tagging or metadata information to IAM users that we create. For example, if this user is in a department, let's say called IT-East, then I could add that key and value pair here. So you can have up to 50 in total when it comes to tagging information assigned to an individual AWS resource. I'll click Next. Here I can review my settings. I'm happy with my settings, so I'm going to go ahead and create this user account. Now, after we have a successfully created message, we can see that we can download a CSV, a comma-separated value file containing the user account information, including passwords information. And we only have one user, so it's not really as prevalent here than if we had created many users all at once. Down below, we can see our current username, jgold, and we can show the auto-generated password. We can also send an email so that the user would have login instructions. So we now have this user created. So down below, if I expand it, we can see it created the user, added the user to the group, and created the login profile or the account for this user. So the other thing to watch out for is to make sure that you either copy this password or download it. Otherwise, after you close this screen, you will have to reset the password to allow the user to sign in if you haven't saved it already. Now, the other thing is that after you've created users, let's just close out of here, you'll see the user or users, if you made more than one, listed here in the view. Now, if we were to select that user account, up at the top, we have the user option of deleting the account. So we can do that if a user, for example, is leaving the organization. And we would do this in accordance with organizational policies. You can use the AWS CLI to create and manage IAM users. I've already downloaded and installed the CLI, and I've connected to my AWS account using the AWS configure syntax. To get started, I'm going to type AWS space help. If I don't know what the next level command is in the syntax, and I'll just hit my space bar to continue going through the help screen, which is listed alphabetically, as we can see here. And eventually, as I get down to the I's, I'll see that IAM is listed. So I'll press Control C. What this is telling me then is syntactically, in the hierarchy, I have AWS space IAM. I just don't know what to do after that. So then I'll add in the word help after that to get the next level help beyond AWS IAM. And from here, if I take a look in the C's, I'll eventually see the create -user syntax. So we can learn about the syntax by using the help suffix. So let's get right down to it. I'm going to run AWS IAM create -user -user -name. And in this case, I'm going to create a user with the name of M. Bishop. Now, I get some returned information about that newly created user in JSON format. Here I can see the username, the user ID that was assigned, the Amazon resource name, the ARN, and the creation date and timestamp. So at this point, I've got the user created, but what I want to do is add the user to a group. So I'm going to use the AWS IAM add -user -to -group the user name. So user -name in this case is M Bishop, and --group -name. I already have a group created called Group 1. I want to add this new user, M Bishop, to that existing group. So I'm going to go ahead and press Enter. Okay, now we're good. Next thing I'm going to do is run CLS to clear the screen, and then I'm going to run AWS IAM get-user name, in this case mbishop, to return some information about that user account. And we can see, of course, the user exists. We already saw that. That was kind of the default JSON output that confirmed the user was created in the first place. Next thing I'll do is run AWS IAM list-groups-for-user, and then --user-name, in this case mbishop. Let's see what we get. So it looks like user mbishop indeed is a member of a group named Group 1. In this demonstration, I'll be using PowerShell to create an IAM user. To get started, I'm going to run the new -IAM user commandlet. I need to specify the -user name parameter, and I'm going to create a user named C Blackwell. When I press enter, we get a bit of return information, including the Amazon resource name, the ARN, for this newly created user account. We can see the creation date. We can also see things like the assigned user ID. And of course, the username that we just specified is echoed back to us, C Blackwell. I'm going to type CLS to clear the screen. I can run the get-IAM user PowerShell commandlet, which will return information about created users. Now, in this case, all we're getting returned back by default is the AWS root account. Well, what about the user we just created, C Blackwell? Well, the way this commandlet works is it looks at who you're signed in as currently, what kind of access that you're authenticated to AWS with. So what I could do is run get-IAM user-user name and specify, for example, C Blackwell. And when we do that, we can see it now has returned information for that specific IAM user account. So I'm going to clear the screen again with CLS. Next thing I want to do is add user C Blackwell to a group. So I'm going to do that using the add-IAM user to group commandlet, -username, in this case it's going to be C Blackwell, and then -group name. I have an existing group named Group 2 I want to add this user to, so I'll specify that and I'll press enter. Then I'm going to run get-IAM group name, and in this case we added C Blackwell to Group 2. Let's take a look at Group 2. And I can see here that Group 2 has two members, another user named mbishop and our currently newly created user account, C Blackwell. Your company's security policies might have specific requirements when it comes to user sign-ins in terms of how passwords are created, managed, and used. So we have the ability then to configure the AWS Identity and Access Management password policy. To get started here in the console, I'll search for IAM and press enter to open the IAM Management console, and in the left-hand navigator, I'll see Account Settings. When I click that, one of the things I'll see over on the right is the password policy. So we can see here, currently, the password must be at least 8 characters. It needs to require at least one uppercase letter, and also one lowercase letter, one number, one non-alphanumeric character. So we have an example of those symbols. Password expires in 30 days. Users can change their own password, and it will automatically remember the last 5 passwords that were used, so users can't keep using the same password over and over and over again, one after another. Now we can change the password policy. I'm going to go ahead and click that. So let's say, for example, that we want password expiration to be not 30 days, but every 60 days. Now the next thing down below is maybe for preventing password reuse, I'm going to put in a value of 8. Now, notice that if I delete 8, it says this field is required because we have the check mark enabled for prevent password reuse. Just bear that in mind when you're configuring some of these items. So if I were to set that to 8 and click Save Changes, we can now see that the changes are in effect. The password expiration is now set to 60 days, and we can now see that AWS will remember the last 8 passwords before allowing password reuse. In AWS, IAM users can be created to allow programmatic and/or AWS Management Console access to AWS resources. Here in the IAM Management Console, I'm already looking at the user's view as per the left-hand navigator. On the right, I see I've got one user with the name of J Gold. That is in a group named Group 1. So if I actually click directly on J Gold to open up the properties of the user account, I can see things like the Amazon resource name, the ARN listed here, when the account was created, including the time zone, AST of Atlantic Standard Time, and down below I can also see permissions for the user. So we can see here that from a group membership, this user has the Amazon S3 read-only access policy assigned. So they have read-only access to S3. If I go to the Groups tab, I can see the group that this user is a member of, in this case, Group 1. I also have the option of adding the user to a group. I can see any tagging information, in this case, a department of IT-East. And if I go to Security Credentials, here I can see the console sign-in link. This is what I can provide to a user, or it would have been provided in the initial email message that was sent to new users with login instructions. Now, this console sign-in link would be used in conjunction with things like the user password. So we can see, for example, the console password here says it was enabled. User has never signed in. We could click the Manage button here so that we can disable console access if we so choose. We can keep the existing password, auto-generate a new one, or specify our own custom new password, require a password reset. But in this case, I know that the user has the initial set password. I can see they've never signed in, so I don't need to do that. I'm not going to assign multi-factor authentication or MFA device configurations to this account. So all I'm going to do then is sign in as this user. Now I'm going to go ahead and copy this user sign-in link, and I'm going to open a new web browser to try it out. Now, when I go ahead and pop that information into a new web browser window and sign in, it takes me to this screen where it automatically has the AWS account ID listed. That's part of this. Next thing it wants is the IAM username. In this case, that would be J Gold. It also then wants me to specify the password. So I'm going to go ahead and specify it, and I'll click the Sign In button. Now, the first thing it says is you must change your password to continue. Well, that is a default setting upon initial sign-in. So I'll specify the old password, and I will specify a new password and retype it before confirming the password change. Now, notice on all of these screens, we always have the option to sign in using the AWS root account credentials. Well, that's not what we're doing here. We're signing in with an IAM user account instead. So I'm going to confirm my password change. And before you know it, I will be signed in to the AWS Management Console. We can see this reflected in the upper right where we see JGold at, and then we've got the AWS account ID listed. Now take note here that JGold is in a group named Group 1 that has an attached policy called Amazon S3 read-only access. And so, for example, if this user were to go into S3 here in the console, there would be limited access. So we can see existing buckets. However, when we go to create a bucket, and if we were to specify a name and continue to go through here, all the way through, eventually we'll get an error message saying access denied because this user does not have the ability to create a bucket, only read-only access. Groups can be used in AWS to organize users that have similar requirements for accessing AWS resources, as opposed to assigning the same resource access permissions to individual users over and over and over again. So here we're going to use the AWS Management Console to create an AWS IAM group. So to get started, here in the AWS Management Console, I'm going to search up IAM and I'll press Enter to open the IAM Management Console. Now here in the dashboard, I can see very quickly that we have 0 groups as well as 0 users. So what I'm going to do then is click the groups view over on the left. And again, we can see on the right it says no records found. There are no groups yet. So I'm going to click the Create New Group button up at the top. The first thing I'll do is specify a name. In this case, the group will be called Group 1. And I'll click the Next Step button. Now the wizard will automatically assume that I want to attach a policy to the group. Now this means that members of the group would then automatically, by extension, get the permissions afforded by the attached policy. So you can select one or more of these built-in policies to allow access to AWS resources. Now, if you've built custom policies, you'll also see them here. Notice that if I remove the check marks here, we just take a look in the upper right, it says showing 524 results. That is telling us how many of these policies we have. As I scroll further down the list of policies, the list keeps updating and updating and updating. So this is an important aspect of working with groups. For example, let's say I go and type in S3 into the filter, then I can see any policies related to working with S3. And for example, here I'm going to select the Amazon S3 read-only access policy. Now, while the wizard is asking me to attach these policies upon creation of the group, I can change it at any point in time thereafter. So I'm going to go ahead and click the Next Step button. Then I have a little review screen where I can edit the group name or the attached policies. I'm going to leave it as it is, and I'm going to click Create Group. And so now we can see that Group 1 exists. If I click directly on the group to open it up, we can pop into the properties, and here we can see the group ARN, the Amazon resource name. You can copy that, and depending on what you're configuring, for example, if you're configuring something at the programming level, you might want to refer to the group by its ARN. We can see there are 0 users in the group, at least at this point in time. We can see the creation timestamp, including the time zone. AST is Atlantic Standard Time. And from here, we can also add users to the group. If I go to permissions, I can see our attached Amazon S3 read-only access policy, although I could attach other policies. I could detach the policy. Now, we also can go to the Access Advisor, so we can see here if any users are in the group and when services were accessed. Now, the reason this can be useful is because over time, for example, if we realize that members of this group aren't even accessing S3 at all, we might detach the policy from the group. That way, we have a more secure and tight, solid environment where there aren't extra permissions that aren't required. So at this point, if I go back to the Groups view and select the checkbox to the left of the group, I can go to the Group Actions button. I can also, from here, add users to the group, delete the group, edit the name, or remove users from the group. The AWS CLI can be used to create and manage IAM groups. To create a group, I'm going to use the AWS IAM create-group syntax. Now I need to name the group, and I'll specify that with the --group-name parameter, whose value I'm going to set here to group 2. I want to name the group group 2. I'll go ahead and press enter, and we can see we have some returned information that indicates the creation was successful. We could also run AWS IAM get-group-name, and let's say we want to return information for group 2, so I'll specify group name of group 2, and we get the same kind of thing returned. We can see there are currently no users that are a member of that group. I'm going to clear the screen. Now I want to add a user to the group. To do that, I'm going to use AWS space IAM, and then add-user-2-group. Now, which user? Well, I'll specify that with --user-name. I want to add a user I've already created with the name of M. Bishop to the group. Now, which group though? Well, we haven't specified that. --group-name, and then I'll specify group 3. Now, in this case, I have an error because I've specified a group name that does not exist. No problem. It's just a mistake, so I'll use the up arrow key to bring up the previous command. I know I've got a group called group 2. Let's try that one out for size. This time, we don't get an error message because group 2 exists. The next thing I'll run is IAM, or AWS first, followed by IAM list-groups-for-user. And in this case, I'll specify --user-name, and we're talking here about user M. Bishop, who is the user in question here. And when we look at the groups for M. Bishop, we can see they were already a member of a group named Group 1, but it now reflects the newly added group membership that we just completed for Group 2. In this demonstration, I'll use PowerShell to create an IAM group. To get started, I'm going to use the new -im group PowerShell commandlet, and I'll use the -group name parameter to create a new group that I'm going to call group 3. We can see the return information, including the Amazon resource name, the ARN, the ARN. We have the creation date and timestamp, the automatically assigned group ID, and of course, we can see the name of the group that we specified on the command line, group 3. Now, the next thing I want to do is add a user to the group. To do that, I'm going to use the add-im user to group commandlet -user name. I'll specify the user I want to add, in this case, an existing user named mbishop space. Then I'm going to add the -group name parameter. I have to tell it the group I want to add the user to. It's going to be the newly created group that we just worked with. That would be group 3. Next thing we want to do is check our work, and I could do that with get-im group name, in this case group 3, where we can see indeed that user mbishop has been successfully added as a member. IAM policies are essentially collections of related permissions that you can assign to users, groups, or roles. To get started here in the AWS Management Console, I'm going to search up IAM and press Enter, because that's going to take us into the IAM Management Console. Now from here, I'm going to go to the Policies view. Here we're going to see a large list of policies. They are alphabetized, that are essentially, as we've mentioned, collections of related permissions. For example, if I search up EC2, then I can see a number of policies related to that, such as Amazon EC2 full access versus Amazon EC2 read-only access. In the same way, if I were to filter or search up S3, I see any S3 related types of policies, such as Amazon S3 full access, Amazon S3 read-only access, and so on. Now, there's also this notion of service control policies, or SCPs. This is a little bit different because it's used when you are managing AWS organizations. Here we're talking about policies directly available in IAM, Identity and Access Management. So if I were to go to the users view, let's say on the left, that exposes my list of users on the right. Let's pick on user J Gold. If I click on that user, under the Permissions tab, I can see any existing permissions that were acquired, for example, through policies. Here we can see the Amazon S3 read-only access policy is available to this user, or is effective for this user, due to being in a group called Group 1. But notice we have the Add Permissions button. And from here, we can add a user to a group, copy permissions from an existing user, or in this case, attach existing policies directly, which I will do. When I click on that, I then get my alphabetical list of policies. That's what we were looking at a moment ago. So if I filter it for S3, we'll see only the S3 related types of policies, such as Amazon S3 read-only access, and so on. However, you can also set permissions at the group level. So if I cancel out of here, I can also go to Groups, open up an existing group, go into the Permissions tab, and click the Attach Policy button, and we're back to the exact same place. So for example, if I were to choose the Amazon S3 read-only access policy and then click the Attach Policy button, it's now attached to this group, which is called Group 2. And of course, by extension, any user that's a member of Group 2 will get this policy, Amazon S3 read-only access. You can also assign these types of permissions, so policies, to an IAM role. Let me just scroll down. Now, a role is a little bit different from a user because it normally represents a software entity, such as software running in an EC2 instance that needs access to other AWS resources. So what you're looking at here is a list of roles. And if I were to click on an existing role, then just like with users and groups, there's a Permissions tab. We can see any existing policies down below, but we can also attach policies. So policies then are the method by which users, groups, and roles in AWS gain access to resources with the required permissions. In Amazon Web Services, you can use IAM roles to give the appropriate permissions to software entities that need to access AWS resources. To get started here in the IAM Management Console on the left, I'm going to go ahead and click on Roles. And on the right, if I scroll down, I will see an alphabetized list of existing IAM roles. And I can filter them out. So for example, if I filter for S3, I see only S3 types of roles, where S3 is in the name. We can also create new roles, and there are times when you might need to do this, such as when you have custom software, perhaps running within an EC2 instance or part of a web app that needs to call upon AWS APIs to talk to AWS resources, like S3 buckets and so on. So I'm going to go ahead and click the Create Role button. From here, we can determine if the trusted entity is an AWS service. So it might be, for example, a Lambda function, or we might want to create this role to represent another AWS account, a web identity, or some other SAML 2.0 identity federation entity. So what I'm going to do then is base this on an AWS service, which is automatically selected. And in this case, let's say that we've built a Lambda function. So I'm going to choose Lambda. That's what we want to assign the permissions to. Then I'm going to click the next button to go to permissions. Well, which permissions will our Lambda function require? We can either create a new policy. When I go to create a new policy, I can use the visual editor, or I can click on JSON and type it out manually. However, I'm going to cancel that because I really don't want to create any kind of policy. I just want to use an existing one. So I'm going to close down this second tab. In the first tab, we're back in the midst of our wizard where we're creating a role where we can attach permissions or create a new policy. So for the existing listed policies, let's say I filter it for S3. And I'm going to choose, let's say, Amazon S3 read-only access. Now, let's say that we know our Lambda function will require only the ability to list objects stored in S3 and nothing more. Hence, the reason we are selecting this specific policy. I'll click Next for tagging. Maybe I want to tie this to a project for tracking and billing purposes, so maybe project XYZ. I'll click Next, and on the review page, we've got to give this thing a name. So I'm going to call this function 123S3. And down below, we can see the policy that was attached to give the permissions that are required by, in this case, the Lambda function. So we're good to go. I'm going to go ahead and click Create Role. Now, when you go to assign roles, there are a couple of places that you can do that. For example, let me go back to the main AWS Management Console and click on EC2. And I'm going to go to Instances, and let's say we want to launch a new instance that we know is going to have some code in it that's going to need these permissions to talk to Amazon S3. So as you go through the wizard to deploy or launch an EC2 instance, on step 3, Configure Instance Details, notice that you have an IAM role option. You can assign an IAM role to the EC2 instance, and from the drop-down list, you can choose one. Now, you can also do that after the fact. So if I already have an existing instance, which I do, and I select it, I can go to the Actions menu, and from here, I can also go to the Instance Settings, and I can make a change to the role. So I can choose Attach, Replace IAM Role, and again, I can then go through and select it from the list, or I can create a new IAM role if required. So IAM roles are very useful when we have software entities that require specialized permissions to access AWS resources. Over time, as you manage more and more IAM users, groups, and roles, and by that I mean attaching policies to give permissions to those items, you'll find that it might be difficult to track which effective permissions actually apply, especially when you have users that might be members of multiple groups and so on. That's where the IAM Policy Simulator comes in. It's available at this URL, so policysim.aws.amazon.com. Now, you have to already be signed in to AWS, which I am, and what it's showing me on the left by default are my IAM users, of which I have 3. But from the drop-down list, I can also choose groups. There are the groups I have in my environment, and roles. Now, let's say, for example, I were to choose, let's say, users, and maybe a user JGold. When I click on user JGold, it then shows me that that person has the Amazon S3 read-only access policy assigned. There are no custom IAM policies or anything like that selected. Now, the next thing I can do, given that I have a subject selected on the left, is apply the permissions that might be available through policies to that subject to some kind of action to run the simulation. So for the selected service, let's say we're going to go to S3. So I'm going to filter this list for S3. Then I'm going to select actions specific to S3. Let's say we want to try creating a bucket. We also want to, let's say, list buckets. Now that I've got those specific actions selected for the simulator, which will apply to the subject shown here on the left, JGold, I can then click the Run Simulation button. Now we notice here that for Create Bucket, JGold will be denied, but the List Bucket action succeeded. It says permission is allowed. Well, that makes sense in this case because the policy here is Amazon S3 read-only access. It doesn't allow writing, and that's why the Create Bucket option has been denied. So I can click the back button in the upper left, and if I want to do the same type of thing for groups or roles, it's really the exact same set of actions. So let's say I choose group 2. I can see Amazon S3 read-only access. Let's just clear the results here on the right, and let's just choose Get Bucket ACL here for S3. We don't have to have it on S3. It can be anything, but let's leave it there. And I'll click Run Simulation. And here we can see the permission is allowed for whichever users are a member of group 2. And as you might guess, it's pretty much the same thing for roles. So if we've got a specific role that we want to test here, so we've got an Amazon service role here for ECS, let's say, and we want to test access to something, whether it's Amazon S3 or anything else that's available from the list and any actions, let's say create job, and then run simulation. And again, in this case, it's denied for the listed role over on the left. So this is a great way, really, for two things. Number one, to determine what permission sets you should assign, so you can play around and experiment, but you can also use this as a sort of auditing tool to check out maybe extra permissions that might be assigned to groups that users are a member of, where those permissions might not actually be required any longer. Multi-factor authentication, or MFA, is becoming more and more prevalent even across the internet with a multitude of websites and apps. Multi-factor authentication means that users must specify additional authentication factors upon user sign-in beyond the traditional username and password. It often uses out-of-band authentication mechanisms to send unique codes. For example, requiring a user to enter a username and a password and then have possession of a smartphone where a unique sign-in code is being sent. There are many other ways that that's done, but that's a common example. So you could consider MFA to be much more secure than standard username and password authentication. Even though a username and a password constitutes two separate items, they're both something you know, hence single-factor authentication. Multi-factor authentication then combines two or more authentication categories. So it could be something you know, like a username and a password, plus something that you have, like a smart card or a mobile device that receives some kind of an authentication code. Another example would be something you know, like a username and a password, and something you are. In other words, biometric authentication, such as requiring, in addition to the username and password, a fingerprint scan. Or it could be something you have, like a smart card, plus something you do, like a specific movement or a swipe gesture on a screen to authenticate. When you enable IAM user MFA, or multi-factor authentication, you begin by selecting the IAM user and assigning an MFA device to them. Now, what does this mean? It means that you can assign either a USB device that your company perhaps is issuing to employees, you could enter a device PIN, or you could scan the QR code. What does that mean? Well, if you choose to scan a QR code, it means that you have a mobile device with an app installed, some kind of authenticator app, and when you scan the QR code, it has enough information about this user account. So in the future, then, when you sign in, you would specify not only the IAM username and password, but also a unique MFA code for sign-in. In this demo, I'm going to enable multi-factor authentication, or MFA, for an existing AWS IAM user. So I'm already in the IAM Management Console, and on the left, I've already clicked the user's view. I want to enable multi-factor authentication for a user named J Gold. Now we can see for user J Gold, if I scroll a bit to the right, under the MFA column, it currently says not enabled. So I'm going to click directly on the username J Gold, and I'm going to go to the Security Credentials tab, where from here, we can see assigned MFA device says not assigned. When I click the Manage button for assigned MFA device, it gives me three options. I can use a virtual MFA device, so using some kind of authenticator app installed on a mobile device or a computer, install it on my Android phone, for example, or I can use a UTF security key device or something similar, or some other type of hardware MFA device, such as a Gemalto token device. I'm going to leave it on virtual MFA device, and I'll click Continue. Now, the first thing you might wonder if you've never used this is you might say, well, what is it I need to install on my smartphone, for example? Well, here there's a link to list compatible applications. And when I do that, it opens up a new web browser window, and I can scroll through this list to view the compatible apps for the Android and iPhone platforms. So for example, I've installed the Microsoft Authenticator app on my Android phone. So I'm just going to go ahead and close that down. So it says, okay, use your virtual MFA app, such as the Microsoft Authenticator app, and your device's camera to scan the QR code. Well, that should be built into the app. When you go into an Authenticator app and choose to add a new account, it should automatically engage the camera on your phone so you can scan the QR code, which you can turn on by choosing Show QR Code here. So when you've used your Authenticator app and the camera on your phone to scan this QR code, it will automatically know the user account information, and it should immediately generate a 6-digit PIN that counts down from 30 seconds all the way down to 1 when it resets. So this is perfect. So as I go further down below, it says, okay, well, now that you're setting this up initially, enter the MFA code. So I'm going to go ahead and enter the first one, and I'm going to wait for the 30-second cycle to expire and enter a second MFA code. Okay, it just changed now, so I'm going to go ahead. I'm looking at my phone to do this. I'm going to go ahead and enter it in, and I'm going to choose Assign MFA. It says, okay, you've successfully assigned virtual MFA, and it's now going to be required during sign-in. Perfect, that's what I want. So I'm going to go ahead and close that. So now I'm going to make sure I sign in as this new, well, it's not a new user, but what's new is it's enabled for virtual MFA. I'm going to try signing in as user J Gold now. To do that, of course, I can click on J Gold and go back to security credentials, and here I can see the console sign-in link. So when I go to that sign-in link, I can see the AWS account ID is already populated. I've specified the username of J Gold and the password for that account. So I'm going to go ahead and click Sign In. Aha! Immediately says, well, that's great, but now you also have to have your mobile device, for example, with that Authenticator app and specify the 6-digit PIN, which counts down from 30 seconds. So it's always changing. Okay, I'm going to enter in that PIN. Let's see if it works. I'll click Submit. Aha! We are now logged in using multi-factor authentication as user J Gold. A network directory service is a centralized network database. The type of items that you will find in this database can range from things like user accounts, groups, devices, for example, machines joined to a Microsoft Active Directory domain, or application configurations and other settings. All of these items can be stored in a central network database. Now, in the AWS environment, we have the option of using AWS Managed Microsoft Active Directory, or AD. The fact that it's managed means that we don't have to manually launch EC2 instances using a Windows AMI, and then we don't have to manually configure them as domain controllers for Active Directory. Managed Microsoft AD takes care of a lot of that underlying work for you automatically. It also doesn't require you to replicate the cloud version of Active Directory with your potentially already existing on-premises Active Directory. When you go to set up a directory service in Amazon Web Services, you have a number of options. The first of which is to select AWS Managed Microsoft Active Directory. This is actually running Active Directory, Microsoft Active Directory in the cloud, but it's managed, so as we've mentioned, you don't have to manually deploy instances or configure the domain controller software. The next option is Simple AD. This is very similar to standard Microsoft Active Directory, but it's not actually Microsoft Active Directory. Instead, it's an underlying Linux EC2 instance running Samba as an Active Directory compatible server. Now, either way, whether you use AWS Managed Microsoft AD or Simple AD, you need to specify things like the domain name and the password for the administrator account. The AD connector option is essentially a proxy feature. What I mean by that is it can take any authentication requests, for example, for AWS resources, and redirect it to our on-premises Microsoft Active Directory. And that way we don't have anything from our on-prem AD stored in the cloud. So that's yet another option. Then we've got Amazon Cognito user pools. This is of interest for developers if they want to be able to add registration for user accounts and sign-in types of features to custom applications. Now, the other thing to bear in mind is that there are plenty of benefits associated with using options such as AWS Managed Microsoft AD, like single sign-on or SSO, the use of group policy to centrally manage settings on domain devices and for domain users. You can join EC2 instances to the domain. You can do this when you're launching the EC2 instance. It's one of the wizard options, or you can do it after the fact. Then once you've done that, you can use standard Active Directory management tools within your joined EC2 instance to manage Active Directory in the AWS cloud. You can also join RDS database instances to the domain as well. So with the AWS AD connector, as we see picture, we've got a user that's trying to connect to a cloud app that requires authentication. With AD connector, that will be redirected to your on-premises AD. You can join an EC2 instance to an Amazon Web Services hosted Active Directory domain either when you launch the EC2 instance initially or at any time thereafter. We're going to focus on the anytime thereafter option. First, here notice that we've got an existing instance of Simple AD whose status is showing as active. I'm going to click directly on the directory ID link to open up some details because I need to know these two DNS server IP addresses. I want to configure my existing EC2 instance in the TCP IP properties to point to both of these DNS server addresses. This is important because if I don't do this, the instance won't be able to locate service location records for domain controllers and thus will not be able to join the domain. I've RDP'd into an EC2 instance in the same VPC where the AD instance is hosted. And what I'm going to do is configure my TCP IP settings here. So I'm just going to go into the control panel for the instance, and we're going to configure it accordingly. Now, what that means is I need to go into my network and internet settings, network and sharing center. There are many ways to get here. I'm going to go to change adapter settings. Here's my Ethernet adapter. I'm going to go ahead and right click on that and go down into the properties of it, into Internet Protocol 4. And I'm going to go into the properties of that. And currently it's set to obtain DNS server addresses automatically through the VPC configuration, but I'm going to choose to use the following DNS server addresses. These are the IP addresses that we initially looked at that are tied to our Simple AD instance in Amazon Web Services. So now that I've got those in there, I'll click OK and close. Now we can join the domain. So I'm just going to search the start menu, let's say, for join. I could also just go into the control panel to do that. So it says connect your device to your work or school domain. Now the options will vary slightly depending on the version of the OS that you're trying to join to a domain. So here I'm just going to go in and once again, I'm going to search for join directly in here. We'll go into the options for that. Here I've searched for join in the control panel, yet another way that we could also possibly get to the options. So I'm going to choose join a domain. I'm going to click change. And here, while I'm at it, I might as well change the computer name. How about WinServe 2019-1? And I want to join a domain called quick24x7.local. And then I'm going to click OK. Now, ideally, it should find a service location record that'll connect me to a domain controller. And this is good news if it's asking me to specify admin credentials. So I'll put in administrator and the password that was specified for simple AD. If we don't know it, we can always reset it, and I'll click OK. So at this point, it's kind of like doing it on premises, really. And I'll click OK again. We're good. We're part of the domain. I'll close out and restart. So at this point, we have joined an EC2 instance running the Windows Server 2019 operating system to our simple AD instance. After you've joined an EC2 instance to an Active Directory domain hosted in AWS, make sure that you sign in using domain credentials. Now, I've already done that. The next thing I want to be able to do is to manage my Amazon Web Services simple AD instance. Now, this machine is joined to the domain, so therefore I'm going to install the appropriate AD management tools I would normally use. So for example, I'm going to go to the Start menu on this server and fire up the Server Manager. Now, there are many different ways you can install software components for the Windows operating system, including using PowerShell commandlets, but I'll use the Server Manager GUI to add the Active Directory management tools. So to do that, I'm going to click Add Roles and Features. I'll click Next, Next again, and I'm going to continue on through the defaults until I get to the Features section, where I'm going to scroll down to the Remote Server Administration Tools, and I'll go to Role Administration Tools, and I'll turn on ADDS, Active Directory Domain Services, and ADLDS Tools. I can also drill down under there and choose exactly what I want, but I want them all, so I'm going to go ahead and click Next and Install. Once that's done, I'll just go ahead and click Close, and I'll close down the Server Manager, and from the Start menu, I'm going to go to Windows Administrative Tools, where I'll see a number of Active Directory items, such as Active Directory users and computers. And if I fire that tool up, because this host is joined to an Active Directory domain hosted in AWS, and I'm signed in with a domain account, it takes me right in. Here I see my domain name, quick24x7.local, and from here, I could expand that and start building things like OUs, organizational units, and users and groups. For example, I'm going to click the Create OU button and create one called Site 1. I'll click OK. And from here, I'm going to click the Create Group button to create a group called Group 1. And I'll just click OK. I'm going to create a user by clicking the Create User button. I'm going to create, in this case, Cody Blackwell. And I'll specify C Blackwell as the username. So this is no different than if you were really administering Active Directory on premises. I select the appropriate domain name. There's only one here. Specify the password and confirm it. So I'm going to go ahead and do that. This is a domain user account I'm creating. The only difference here from what you might normally do on premises is the fact that this is being hosted in Amazon Web Services. So I'll leave the user must change password at next logon checkmark turned on. And there you have it. So we've now created a user, a group, and an OU called Site 1 in our simple AD instance in Amazon Web Services. Amazon Cognito is a service for developers that allows those developers to add user capabilities to their applications. That includes user sign-up or registration, user sign-in. It's all about access control, and even sign-in from third-party IDPs, identity providers. That means that developers could build their app such that it would allow third-party logins using Google credentials or Facebook, or even through Microsoft Active Directory. The Amazon Cognito service supports common security standards when it comes to authentication and authorization, including SAML 2.0, OpenAuth 2.0, and OpenID Connect. Cognito supports user pools for user identities, identity pools, as well as external identity providers. Let's focus on identity pools for a moment. With an identity pool, what you're really doing is building the identity to reference a software component so that your app would have access to AWS resources that it needs to talk to. You could even use it for guest user access or anonymous access to S3 resources. Cognito also supports synchronization of user app data across a multitude of devices. It also supports SMS text messaging, multi-factor authentication, and you can even migrate existing users to Cognito user pools instead of having to recreate them from scratch. And you can do this by importing a CSV file. Also, you could set it up so that user sign-ins could trigger a Lambda function to create users in Cognito user pools. Cognito user pools have a number of user sign-in options, such as the username, their email address, their phone number. There are other additional attributes that you can specify in addition to the user sign-in items, such as the locale, their middle name, picture. It supports user self-sign-up. It supports various password strengths and password recovery options, and multi-factor authentication, and finally, the verification code method that will be used to verify a user account. So developers then could write code for their application to use Amazon Cognito for user registration and authentication. You can use the AWS Management Console to configure AWS Simple AD or Active Directory. To get started here in the console, I'm going to go ahead and search up the word directory, and I'll choose directory service from the resultant search list. Now from here, I'm looking at my list of existing directories of which there are none, but I can click the Setup Directory button over in the upper right. At this point, I have to choose between AWS Managed Microsoft AD, so that's actual Microsoft Active Directory hosted in the cloud, or Simple AD, which is what we're going to select. That's Linux Samba-based Active Directory emulation. We've got the AD connector to forward authentication requests in the cloud to an on-premises instance of Active Directory. We've also got Amazon Cognito user pools that developers can use for user registration and user sign-in to apps. So I'm going to choose Simple AD, and I'm going to click the Next button. Now I have the option of selecting either small or large, where small is suitable for approximately up to 500 users, groups, and computers, so each of those items, where large would be for in the range of 5,000 users and 5,000 groups and 5,000 computers, that type of thing. I'm going to go with small for this configuration. I have to give this a DNS domain name. So for example, I'm going to use quick 24x7.local. I can specify a NetBIOS equivalent name. I'll just put quick 24x7 for that one. And I have to specify the administrator password for the administrator account. So make sure you tuck that password away somewhere safe so you'll be able to authenticate to your simple AD. I'm going to forego filling in the directory description. I'm just going to go ahead and click the next button in the bottom right. So then I have to choose the VPC and subnet affiliation for this AD deployment. So I'm going to choose, in this case, an existing VPC I've got called VPC1, and I've got two subnets here, subnet 1 and subnet 2. So that's perfect. I'm going to go ahead and click Next, and I've got the summary screen. So I'm okay with all of this. I'm going to go ahead and click Create Directory. So you can monitor the status by clicking the refresh button here when you're in the directories view. Here I can see under the status column, it says it's still creating my directory service instance. So just make sure you monitor this for a little while until such point that you come back and refresh it and it's ready to go. Eventually, you'll see that your simple AD instance has a status that will change to active, so it's ready to go. And if you select that instance from the Actions menu, you can either choose to reset the user password, or you can choose to delete the directory. Notice you can always choose Setup Directory to add multiple instances of directory services. Now, what we can also do is join EC2 instances to the domain, for example, even at launch. If I were to go to the EC2 Management Console, let's say, go to the Instances view, click the Launch Instance button. Of course, I'd have to choose an instance type or an AMI that supports joining to a domain, like Microsoft Windows Server 2019 base. Click Select. I'm just going to keep going down to step 3, where we have the Domain Join Directory option. Now, what we can do from here is, from the drop-down list, we can simply choose our instance of simple AD. We can see it's listed here, quick24x7.local. Of course, you can always do that after the fact, but at this point, we've established our instance of simple AD in Amazon Web Services.